Any doubt with the previous topics? You can keep reading climatology. Climatology is never going to end. Lot of concept based questions comes from climatology. If you master this climatology, you master civil service. I'm telling you, the climatology is the toughest because lot of science is there. Students struggle. Now onwards the topics get intense from now onwards. Future classes I'll discuss monsoon, tropical cyclone. Okay, lot of application topics will come. With the previous topics basics, like we have discussed air density, we have discussed insolation, correct? We have discussed air temperature, we have discussed normal lapse rate, the rate at which temperature decreases with height. Based on that, we have divided our atmosphere into various layers. Structure of atmosphere, don't write anything, please write. Based on two factors. One is air temperature, based on air density. Based on these two, we have divided our atmosphere into various layers. Okay, we'll see one by one. When you start writing this, make sure the heading is on the top of the page. At the bottom of the page, you write the Earth's surface, because atmosphere layers are above the Earth. So this is the Earth's surface, let's say. See, this is the Earth. Like this, Earth's surface. Above the Earth's surface, we have various layers of the atmosphere. So we need full page for this. Full page, I'm saying almost like entire page you have to use. Okay, so I want you to notice first how I'm going to write. Then you can copy. First layer here, above the Earth's surface is troposphere. First layer. The word tropo means change. It is the most immediate layer above the Earth. First layer above the Earth. All of us are breathing air, right? In this layer. Correct? All of us are living on the Earth. Under which layer? Troposphere. Every second of our life, we are interacting with troposphere. The air we breathe comes from troposphere. It is the most important layer. Life-sustaining layer. The word tropo means change. Remember, okay? Simple introduction I'm giving you. First layer. As you go further, stratosphere. Strata means layer. This is where we have ozone. So ozone divides this into two parts. So stratum is what? Layer. Oh, careful here. What is this? Vandalism. You are becoming vandals rather than civil servants. So next layer is mesosphere. Meso means middle. Understand the meaning. First round you understand the word. Tropo means change. All changes that take place is here. Troposphere. Stratum is layers. Meso means middle. Okay, middle atmosphere. Then the top layer, thermo. Inside thermosphere, we have ionosphere, exosphere. Ionosphere above this exosphere here, upper. So that is the reason I told you, your page should extend up to the top. Notice this first. All of you notice this. Or I'll use white color here. The troposphere goes up to like 8 to 16 kilometers. You write this first. I'll tell you. Then stratosphere goes up to a height of 50 kilometers. Then mesosphere goes up to the height of 80 kilometers. Then the exosphere goes up to 1000 kilometers. 1000 slowly. Top of the atmosphere goes up to the exosphere. That is, after that it merges with space. Exosphere is a very faint layer. It is merging with outer space. Okay, so remember this, exosphere. So your heading should be on the top of the page, and all the way up to exosphere you have to write. So notice this is that troposphere's uppermost part. Here all of you notice, as you come here, from troposphere to stratosphere, there is a transition layer called tropopause. Pause means whatever changes that are taking place here. Remember what is tropo? Change. That change will pause here. Tropopause. Let's say you are watching a movie, there is an interval in the middle, that is pause. Again you continue like that. So this is pause. Then again after that stratosphere. Then above that is stratopause. Again the changes here will pause. Again mesosphere. Then mesopause. So these are the various layers of the atmosphere. First layer, tropo, strato, meso, thermo. Within thermosphere we have ionosphere and exosphere. In some books, 4th and 5th they have given. This is 4th and this is 5th. But NASA, ISRO follows this. Okay. The source of the data is NASA. Okay. As a result, I am taking that and I am giving you here. So remember this. Above the Earth's surface, we have various layers. First, you write down this. And also, let me tell you one more thing, very interesting thing. Let's say this is the Earth's surface. This 0 degree, 20 plus, this side minus 20, minus 40. Because as we go up, what happens? Temperature decreases, minus 60, minus 80, minus 100. See, in our atmosphere, as we travel, see, this is tropopause, stratopause, mesopause. Various layers we have, correct? From the Earth's surface, all of us are where? Here, on the Earth's surface. From the Earth's surface, if I start going up, what happens? Temperature starts decreasing. See the graph. Let's say the surface temperature is 15. Average surface temperature of the Earth is 15. 15. See this graph. Temperature decreases with height. See. Temperature decreases with height. As I am going up in the atmosphere, what happens? Temperature declines. At the top of tropopause, minus 40 is the temperature. Dekho, minus 40 is temperature. You read the graph. Here it becomes constant. For 2 kilometers, because of tropopause, it becomes constant. Tropopause thickness is 2 kilometers. So it becomes constant. Then after this, as you come here, you can notice why this happens. Air density. Because air density decreases with height, decreases with altitude. So number of gas molecules, greenhouse gases will be high here. As we go up, greenhouse gases also decrease. So there will be less molecules on top to hold the heat. As a result, heat escapes. So temperature decreases at the rate of 6.5 degrees Celsius per kilometer. So lapse rate, how much is the lapse rate here? 6.5 degrees Celsius per every kilometer. Normal lapse rate, we call this as. In the yesterday's class, previous class, we have discussed this. Normal lapse rate in troposphere is how much? 6.5 degree drop in every kilometer you go up. You remember this. This is first layer, troposphere. Here in second layer, what happens? We have, all of you notice this board. O2 we have, oxygen. Oxygen molecules here. Here also we have, here also we have. Oxygen molecules here, what happens? Interacts with UV rays. Sun's UV, ultraviolet. I'll write this in the next page. Please give me 2 minutes. I'll explain and I'll get back to that. O2 is there here in stratosphere. So the UV rays from the sun, UV, ultraviolet radiation falls on the O2 molecules. In UV, we have 3 types. C, B and A. Remember this. 3 types of UV rays. In the previous class also I had given this. So for this is almost 380 nanometer close to. This is 100 nanometer. So UVC is very dangerous. UVC is close to X-ray. This side comes X-ray. Okay. X-ray here. So as a result, the UVC radiation is having lower wavelength. So it's very strong rays. So it can split O2 molecules into 2. You can notice this. O2 splits into 2 like this. 2 individual atoms it becomes. This oxygen atom merges with another O2 to form O3. So like this, ozone is formed in stratosphere. This ozone, just like oxygen, it has capacity to absorb UV rays. Just like oxygen, it can also absorb UV rays. See, UV rays again will fall on it. UVC, this one, UVC. What happens? This will split again. Will merge with another O2. This will merge with another atom, forming O3. O3 again. The process continues. This is called as oxygen-ozone cycle. Oxygen-ozone cycle. Like this, ozone is formed in our atmosphere. Okay, please remember this. Ozone is a gas molecule with 3 oxygen atoms. It has 3 oxygen atoms, ozone. Okay, this ozone is capable of stopping which rays? UV rays, especially UVC. Okay, so ozone protects us from the harmful UV rays coming from the sun. Let's say ultraviolet radiation is coming, C, B and A. Please notice this. This is O3. So this C is blocked completely, 100% blocked. C. B, UVB is blocked 50%. Only 50% is blocked. Other 50 comes to the surface of the earth. UVA is not dangerous, so it reaches earth. UVA, UVB are partially blocked, we can say. UVC is completely blocked. So which is dangerous? UVC. So our ozone is protecting us from harmful UV rays. It is like a natural sheath around Earth. It protects us. UVB is partially blocked. UVA is not blocked at all. It reaches the Earth's surface. Okay. So please remember this. So UVB, ultraviolet B radiation, correct. So it falls on our skin here. So on our skin we have something called 7-DHC, especially on the epidermis, below the epidermis, upper part of the skin, we have something called 7-DHC, 7-dehydrocholesterol. Any medical students here in the class? Medical. Okay. Yes, you heard of this 7-DHC. So 7-dehydrocholesterol in the epidermis. So what happens when UVB interacts with this turns into vitamin D. Vitamin D is synthesized in our skin naturally with exposure to which rays? UVB. Please remember this. Okay. Long-term exposure, short-term exposure is good for us. Long-term exposure to these UV rays can cause a lot of problems. Premature aging, for example. We look older than our age. Graying of hairs also has been noticed. So some of the case studies conducted in US, they are also indicating, so long-term exposure can cause cancer also. Sunburns as well as cancer. So as a result, UV rays say we generally need to avoid, especially if you are a long-term exposure. Okay. That is, then have you noticed, let's say we have a lot of sunscreen lotions nowadays. Like men don't know, women know. So I'm talking about Lakme, L'Oreal sunscreen lotions that you all use. So notice that next time above the MRP, there is something called SPF 20, SPF 30, SPF 40 written on it. Sun protection factor. They'll ask, what is SPF 20? Means sun protection factor. UPSC can ask anything. So they'll ask this. What is SPF 20 means? That means when you apply this sunscreen lotion or Lakme or L'Oreal or Fair and Lovely, I think now you know Fair and Lovely guys. So that one, when you apply that, what happens? So it will protect your skin by preventing the UV rays from penetrating into the skin. It makes it 20 times harder for the UV rays to penetrate. SPF 20, if you apply, it makes it 20 times harder for the UV rays to penetrate your skin. As a result, sun protection factor. Especially you might have seen test cricket players test may you have to stand from entire day. Correct? Day and night match is different. Day and night match, afternoon they start, evening they start, night it will go. Day matches, full day match, test series and all. You have seen our cricketers wearing patch. Correct? They'll be wearing sunscreen lotion. They'll be wondering, they'll be carrying with a bottle also, big lotion bottle. This is the one. To protect themselves from overexposure. Okay. So long-term exposure. That is the reason melatonin and melanin pigmentation. So we'll talk about that. Melanin pigmentation mainly. If your skin has very high melanin pigmentation, it naturally protects the skin. Melanin pigmentation helps you to protect yourself from the exposure to UV rays. Okay. So that is one part. We'll discuss that. So SPF 20, SPF 30, SPF 40, there are many. You just check it out. Which one you are using, you just see this one. So UVB rays, you know now. So UVB, UVA, they'll ask this. So UVB, UVA is reaching the earth here. Where is that image? Here. Here. It is reaching the earth. UVB, UVA is reaching the earth. UVC is blocked here only. So because of the ozone, I'll just write ozone. We have ozone layer here. Please remember this. O3. So this layer is called a strato. Stratum is what? Layer. Because of the ozone layer, this layer is called a stratosphere. So what does ozone do? Ozone is also a gas molecule. One. It also blocks UV. So because of the interaction of UV rays here, so there are more gas molecules here. So air density increases. Because of more ozone molecules here, air density increases. So temperature also increases. Because I told you, when the air density increases here, so temperature also tends to increase here. Notice this, like this. I'm not saying increases means it will come to plus. From minus 40, it is coming to minus 20, you can see, and then it becomes constant. So in the first layer, temperature decreases. In the second layer, temperature increases with height. See the temperature, how graph is changing. Okay, suddenly the temperature starts increasing here because of ozone. Ozone is also a gas. It increases the air density. So more molecules. Ozone is also a greenhouse gas, don't forget. Ozone is also a greenhouse gas, it can trap heat. So temperature increases. Okay, so please remember this. So ozone was discovered in 1913 by Charles Fabry and Henry Buisson. Please remember this. These are the two scientists, French scientists, who discovered ozone. Okay, and we measure ozone using unit called Dobson unit, DU. 1 DU is equal to 0.01 mm of ozone, DU, Dobson unit. So this you remember, UVB, UVA, all of you know. So how ozone protects us, you know, and how vitamin D is formed, you know. Vitamin D is very important for body immune system. Okay, overall body functioning, bone density and all, it's very crucial. Okay. So remember the Dobson unit. Okay, so we'll discuss this further, don't worry. I'm just giving you introduction to which layer? Ozone layer in stratosphere. Okay, so please remember, I'll give you time to write this. Okay, I'm just showing you how the ozone was formed, what happens in this layer. Now, you know, temperature increases. Now as you come here in the mesosphere, what happens? Density is very low, air molecules are very far. Most of the gases are in atomic level here, like nitrogen atom, oxygen atom, like that. So most of the gases are in their atomic level, and also air density is very low. What happens when the air density is very low? And also greenhouse gases are absent here. So as a result, temperature drops to -100. This is the coldest part of the atmosphere. Mesosphere is the coldest part. Okay, please remember which is the coldest part of the atmosphere. Middle atmosphere here, because air density is very low, greenhouse gases are absent. We have N2O2 also we have, but greenhouse gases are all absent here, because most of the greenhouse gases are found here only, this layer. Above this, very less. Okay, so please remember the -100 to -80. Because of this very low temperature, what happens? Sometimes the moisture that is present here will freeze and becomes like ice crystals. The water molecules which come up here, water vapor, sometimes because of very low temperature freeze and become pearls, look like pearls. Crystallized water droplets are called as pearls here in this section. When I talk about pearls in mesosphere, it means crystallized water vapor. The water vapor, because of very low temperature, it freezes, crystallizes and look like pearls in the sky. They glow in the dark, especially early morning, evening, they glow. Correct, that is called as noctilucent clouds. Noctilucent clouds. Okay, very beautiful clouds. I'll show you this. Next, when we come here, what happens? Here, ionosphere, exosphere region now, thermosphere, if you notice that. Here, all the gases here, nitrogen, oxygen atoms here, interact with the X-ray UV. I'll show you that here, please. Let's say we have an atom here, nitrogen atom or oxygen atom. So all of you know, atom consists of a nucleus. Within the nucleus we have protons and neutrons, around which we have electrons. Protons are positively charged, electrons are negatively charged, neutrons have no charge. Correct? Protons are positively charged, electrons are negatively charged, neutrons no charge. All of you know. In most atoms, number of protons inside the nucleus will be equal to number of electrons orbiting the nucleus. It's called as a neutral atom. It is called as a neutral atom when number of protons inside the nucleus is same as the number of electrons orbiting it. Okay, so think of this layer, uppermost layer, where we have nitrogen atom or oxygen atom. So the X-ray UV falls on this. As soon as the X-ray and UV are ionizing radiation, high intense radiation of very low wavelength. As soon as they fall on the gas atoms, some of the electrons get the energy. Correct? They leave the atom like this. You can notice that the electrons, as they get energy, what happens? They get excited. So they change their energy levels from one energy level to the next. And some of them leave the atom and join other atoms. Some atoms will lose electrons, some atoms will gain. So then it is no longer neutral. You can see no longer neutral now because some electrons have been lost here. You can notice some of the electrons went out and joined the other atom here. This atom lost the electrons. So what happens? Protons will be more now. Electrons have decreased. In this case, electrons have increased. Protons are same. Whatever protons we had. Correct? Electrons have increased in this case. Some atoms have gained electrons, some atoms have lost. Okay. So whenever some gas atoms exchange electrons like this, they get ionized. They are called as ions. Ions are electrically charged particles. They are atoms which have either lost electrons or which have gained. Since here the atom has gained the electron, here you can see more negatively charged atom. This is called as anion. It is called as anion, negatively charged. Here more positively charged particles are there, cation. All of you heard of this, cation, anion. This happens in our atmosphere. So the name ionosphere. So the name ionosphere. Why do you think this layer was called as ionosphere? Here, Evala. This is the reason. See the word ion. Ions are formed in this layer. Because of this kind of electron exchange between atoms due to the exposure to X-ray UV, this happens. That what you have studied in physics, chemistry, that really happens in the sky. Okay, so here because of ions we have ionosphere. So ions are formed more during the day because of exposure to sun rays. X-ray UV comes during the day. Allah. So more ions are formed during the day than at night. So ionosphere mein ions form during the day or night? Day. Because exposure to X-ray UV. So this happens. Exchange of electrons take place. So ions are electrically charged particles. They are atoms which have either gained electron or lost electron. This happens in the ionosphere. So lot of ions are here. During the day we have more ions. D layer, E layer, F1, F2. There are so many layers of ions. F1, F2. There are so many layers of ion during the day. At night they will all merge. F and E. F and E. So a lot of ions are here. Nitrogen ions, oxygen ions in the ionosphere. Okay. They all interact with which rays? X-ray, UV. Electron density is very high. So because of this interaction, correct, slowly the temperature rises. I am not saying it's very hot layer. Temperature increases like this. See the graph, it goes like this. So temperature slightly increases. But it's still in under zero only. So see the graph. First temperature decreases, then increases, then decreases, then slightly increases. Okay, compared to this layer, it's slightly warmer. So the name thermo. Now you know the graph how it changes. Okay, and now you write this diagram. And on the right side, you keep space for the graph. That is the reason I wrote that first, so that you all can easily write. I'll add more information now once you write. Divide the book into two parts. One side graph, other side the diagram. What about that some event they are saying 10 o'clock? What? You also have to attend? No, if they are organizing from the institute, you have to attend. Let's see. Till then, let's finish this. By the time they start, it will be 10:30. So anyhow, we'll finish by then. If they are starting with the program also, by the time they start, it will be 10:30. So when you write, you memorize. What are the four layers of atmosphere? You memorize and write. Tropo, strato, meso, thermo. Like that. Don't just write. Don't just copy. When you copy this, what you should do? You should memorize what you are writing. Tropopause, matlab kahan aayega? Dekho, you should memorize this. They ask, where is tropopause? They are asking. Is that a question? I don't think it's a question. Where is ozone? They have asked. In many of the state service exam, your Telangana or Andhra or Karnataka state service exam, if you notice, this ozone question is they have asked almost 4 or 5 times. So many times they have asked. Okay. So as a result, one question on this topic. Structure of atmosphere. Draw the lines properly so that the division is seen. All the height is measured from the surface. This also 8 to 10 from the surface here, arrow mark. From the ground 50. That means this will be 30 kilometers approximately. 80. That means this is 30 kilometers again approximately. Correct. This is the biggest layer. Thermosphere. This is 4A. This is 4B. 4B. During the day we have many layers. At night we have only 2 layers. So be careful with the graph. Here it is decreasing slowly, it is increasing, then it drops to 100. Okay. So while writing ozone, you should know, many of you will have the doubt. Sir, only ozone is formed here. It is not formed here, Anta. Yes, it is formed here also. Here also ozone can form. Because some UV rays enter Allah. Here also ozone can form. I am not saying no. Because oxygen is here also, right? Oxygen is here also, ozone can form here. But ozone in the troposphere is called as bad ozone. This is bad ozone. Why? Because it is a pollutant, greenhouse gas in the lower atmosphere. This is good ozone in stratosphere. Because it protects us from UV. You got it? There are 2 types of ozone. Good ozone, bad ozone. Location is very important. If it is in stratosphere, it can block UVC. If it is here, it is of no use for us. It is a pollutant in the troposphere. So ozone in troposphere causes lot of health related problems. Like many cases, medical let's say tests have been done to prove that ozone inhalation can cause heart attacks, cardiac arrest. That is there, and it can cause respiratory problems in cattle, livestock. Ozone exposure, ozone inhalation can cause respiratory problems in cattle. It can damage sensitive plants like orchids. This one, bad ozone below, and it's a greenhouse gas. So it's a pollutant. It has been declared as a greenhouse gas and a pollutant in lower atmosphere. Here in the stratosphere, it is good ozone. It protects us from UV. Okay. So if you have the doubt, ozone is not formed here, air formed also. Okay. Another doubt, where do the planes fly? Most of the students ask that. So planes kahan jayega? Most of the short distance, let's say I am going from Hyderabad to Bangalore, short flight. It will go in troposphere only. It will go up and come down. Because 1 hour flight. I am going to Tirupati, let's say. It will go up, come down. That's it. Short distance flight in troposphere. Long distance flight goes in stratosphere. Yahan pe jayega. Like this. Long distance flights is about tropopause. Let's say I am going to London or North America. Correct. Then it will go here. The plane will be here in stratosphere. Short distance flights and all within troposphere. That is another doubt most of the students have. What about International Space Station? ISS is here at the height of 428 kilometers. International Space Station is a joint space mission of many countries like NASA, Japanese Space Agency, Canadian Space Agency, European Space Agency. Together they have made International Space Station. Okay. ISS is in which layer? Ionosphere. In one diagram we have to fit many other information as well. You can write one plane also here. Long distance flight. एक छोटा सा plane दिखाओ. Like this. Long distance flight here. Short distance flight here. Short distance flight here, long distance flight here. So next I will explain how auroras are formed. Auroras occur in which layer here? Aurora borealis, aurora australis. Many of you might have heard of. Aurora borealis and aurora australis are natural display of colorful light in the polar sky. Beautiful display of colorful light. That occurs in which layer? Ionosphere. That I'll explain now. Next. Okay. But now you write in this diagram. Many times all of you would have seen, let's say here, let's say I have a FM broadcasting station here, radio station here. AM FM signals are transmitted from here, radio station, correct? So the low frequency, medium, high frequency signals that I am sending, broadcasting from here, amplitude modulated or frequency modulated signal I am sending here, from here, it will go up, it goes up. As it goes up, it interacts with the ions. These ions are out electrically charged particle, don't forget. Ions are, so as a result, these ions, what they do, they deflect low frequency, medium, high frequency signal back to the earth. As a result, when it comes back, the receiving station, your mobile phone, act as a receiver. Radio, you'll be able to hear radio, or a radio you have with antenna. Your mobile phone connected to a like earphone acts as an antenna. Remember, earphone acts as an antenna. When you unplug it, then only your mobile radio will operate. So it will receive the signal. Long distance radio wave propagation. How does long distance radio wave propagation take place in our atmosphere? With the help of ionosphere. Ions in the ionosphere help us in radio communication. Simple words. Ions in the ionosphere help us in radio communication. Okay. So whatever signal we send from the earth, low frequency, medium, high, very high, they send it back. Only ultra high frequency signal goes up to space. Let's say satellite communication, we use UHF. Ultra high frequency signals we use because it can penetrate through the ionosphere, goes up in space. Rest of the signals come back. Radio signals, low, medium, high, very high frequency signal comes back. Your walkie-talkie communication, planes may communication hoga na, planes to like airports, all that uses this. So ionosphere helps us in long distance radio communication. So they'll ask all this, which layer in our atmosphere helps us in radio communication? Then answer is ionosphere. Where does aurora occur? Ionosphere. Where is ISS? International Space Station, ionosphere. Why they have placed it here? At the height of 428 kilometers. Height is 428 kilometers here. Here. At this height, why? Because gravity is very low here as you go above ionosphere. Okay. So they are conducting research in microgravity or zero gravity. Okay. So various types of researches and all are conducted at the microgravity level here. And it is orbiting Earth many times a day. Taking live footages of Earth as well as for space. They have a telescope also. In-house telescope on ISS. So they study space as well. Observe Earth. It's a Earth observatory type here in space. So please remember here. Next, at the height of 100 kilometers, all of you see this, 100 kilometers, we have a line called Kármán line. Kármán line here at the height of 100 kilometers. In which layer? Again, ionosphere. This ionosphere Kármán line, named after a scientist, Theodor von Kármán, a famous astrophysicist. Kármán is the name of a scientist. So this line divides atmosphere into homosphere, heterosphere, because up to here the gravity is there, but above this gravity is very, very low. So as a result, this layer is called as homosphere. Above this 100 is called as heterosphere. Please remember this, they'll ask this. What is homosphere? What is heterosphere? Many of the things that I am telling you here is not given in the books, nor in the NCERT. Okay, what is homosphere? They'll ask. The layer within 100 kilometers from the Earth's surface is called as homosphere, where sufficient gravity can be experienced. Above 100 kilometers, microgravity, zero gravity. It's called as heterosphere. So a lot of things are there in one topic. So you have to try to understand that. They are not separate. They are all linked with our atmosphere, structure of atmosphere. What are the various layers? Tropo, strato, meso, thermo. That is first. Many exams may silly questions they are asking. Arrange the layers of atmosphere from Earth to space. So then you have to write tropo, strato, meso, thermo. From space to Earth they are asking. Thermosphere, mesosphere, stratosphere, troposphere. That is the question. But in UPSC they are asking this. What is homosphere, heterosphere? What is Kármán line? That level they are asking. They have already gone ahead. They are asking about aurora borealis, how auroras are formed. They're asking about radio communication and all. They're asking advanced question. They're asking. Okay. You write down quickly first. Make sure that you have written everything. UVA is close to visible violet. Violet starts at 400 nanometer. If you are wondering, violet, indigo, blue, green, yellow, orange, red. Violet, visible light. UVC is close to X-ray. So ozone is formed from which of the following types of UV? Ozone is formed from which of the following types of UV? UVC. Vitamin D. Vitamin D is formed from which of the following types of UV? UVB. Okay. Charles Febvre, Henry Buisson. Dobson unit, you remember. 1 Dobson unit is 0.01 mm. Formula also you remember. Above Hyderabad, last time when we checked, it was 500 DU. National Geophysical Research Institute is there here in Hyderabad. NGRI, National Geophysical Research Institute. They conducted a ozone experiment. Above Hyderabad, at the height of 35 kilometers, they discovered 500 DU. What is 500 DU means? 5 mm. 5 mm. Example. I am giving an example. It's normal. It is considered normal ozone. Okay. So ozone is formed in this layer, stratosphere. From there also, that also you mentioned. So that I didn't mention. All this I am explaining for which layer? Stratosphere here. Ozone is the gas molecule containing 3 oxygen atoms. And don't forget to check this SPF when you go home. If you have this sunscreen lotion, just check. If you have it in your bag, you can check it now also. You should see the students in Delhi. You will be like, oh, they would have shown it to me by now. So see this Santa. Ah, 50, huh? 50 plus. See, high altitude trek. When you said 50 plus, I remember. When we go for high altitude treks like Ladakh, Mount Everest, Tibet, exposure to UV is very high. Then you need that. High sun protection factor is required when you are exposed to over UV rays, especially in higher altitude. So that is then when we go for, we wear polarized glasses. Polarized glasses are required because exposure to the harsh rays can affect your eye also. Plus skin, we use high SPF factors. Okay. PF. The protection factor only. That is for dust. For example, we have so many things mentioned. That is, sun protection factor is for ozone. Just normally protection factor is from the dust also. Dust pollution from the vehicles, exhaust and all. Carbon comes na. Carbon from the diesel engines and all. Unburned hydrocarbon. That also deposits on your skin. Men don't care. Women worry about all that. So as a result, they use all this. Okay. Protection factor and all. Done? Can I go to the next page? So this, you remember, ozone itself is a question in exam. In some paper, full length question on ozone they will ask. What is ozone? How is ozone formed? How ozone is depleted? How ozone is measured? Correct. Like that one question will be there on mains May. One full length question, 150 words question we can expect on ozone. Then you have to write what is ozone. Ozone is a gas molecule containing 3 oxygen atoms. It is formed in stratosphere through a cycle called oxygen-ozone cycle. It was first discovered by Charles Febvre, Henry Buisson, French scientists, both. Okay. Then that you can show. Ozone protects us from the harmful UV rays. UVC, UVB, UVA, you can mention. Wavelength also you can write here only if you want. 100 nanometer to 380 nanometer. UVB around 220 nanometer is responsible for vitamin D. Like that you can write. Okay. I'll add few more information. Since we are talking about now ozone, I'll just finish this topic now only. See, on the Earth's surface, We are using so many industrial processes, we are using so many chemicals, we are using at the household level itself, ACs we are using, correct? We are using various chemicals, coolants, refrigerants we are using, refrigerants, correct? So most of them are hydrochlorofluorocarbon based, CFC based, chlorofluorocarbon based, or hydrofluorocarbon based. HFC, CFC, CHFC and all we are using as cooling agents. Nature has given two best harmless cooling agents, air and water. Air and water are the best. They don't cause any damage. So they are the best cooling agent. But we require temperatures very low. Let's say sometimes in minus also to store medicines in some cases, to preserve food. We need lower temperatures. So for that we use refrigerants. Refrigerants are basically chemicals which reduce the temperature of the air and water. So these refrigerants, please notice, since they are released from the Earth's surface, slowly they go up. So most of them are CFC, I told you, or HFC based, or HCFC based, hydrochlorofluorocarbon based. All this go up. Especially chlorine is very dangerous. Chlorofluorocarbon mein chlorine is very dangerous. Chlorine reacts with ozone here. When it reacts with ozone, oxyfluorine is formed, ClO is formed, or chlorine monoxide is formed. It is called as oxychlorine or chlorine monoxide. Okay, single atom I am putting a dot like this. You can see monatomic here inside the chlorine. So ClO is formed. Then O2 is released. You can see. That means ozone is getting damaged here. Notice this. Again, when the UV rays falls on it, UV, it will split. Chlorine and oxygen atom. This chlorine will merge with another O3 and the reaction continues. One chlorine atom can damage 1 lakh ozone molecules in the atmosphere. One atom I am talking about. One chlorine atom can damage up to 1 lakh ozone molecules. Same is with the fluorine also. Fluorine damages almost around 50,000 ozone. One atom damages nearly 50,000. That is when CFC and HFC are very dangerous. You got it? So like this they damage our ozone. So ozone thickness decreases wherever this is happening. So as a result, chlorine can cause a lot of harm to CFC can cause a lot of harm to, especially CFC can cause a lot of harm to ozone layer. Okay, so I'll show you this now. Since this topic is important, notice this. This is tropics, 30 degree to 30 degrees tropics, 30 to 30. This is 0. This is 60 north, 60 south. This is 90 south, 90 north. So here in the tropics we have warm air. This is all warm air because of more insolation from the sun, warm. Okay, this warm air goes towards the poles like this. When the warm air goes towards the poles, it will carry all the pollutants also. Most of the pollutants don't remain here. They'll move towards the polar region. Here in the polar region, the air is cold. Cold air, dense air. The cold dense air in the polar region here comes down towards temperate here. See? So cold K, I'll see. Here I'll write K only. I'll tell you why. W is called as warm here. Notice that warm air mass, cold air mass are meeting each other. Okay, warm air mass, cold air mass are meeting each other. What happens when the warm and cold meet? Warm air mass is light, it goes up. The warm air mass is rarer in density, so it slowly goes up. When it goes up, it takes all the pollutants up. All the pollutants coming from here, it goes up. All the pollutants coming from here, goes up. You might ask, sir, why pollutants will come from Antarctica? There is nobody. Research stations. Antarctica has large number of research station. Like we have Maitri, Bharati, Dakshin Gangotri here. Our research base in Arctic Himadri, like that. So there are hundreds of research stations here and here. They all use different chemicals, refrigerants released into the air. Okay. So these chemicals come down, accumulate here, goes up, takes up, goes up. So moisture going up will come down as rain. Moisture will become clouds here and come down as rain. What about the rest of the pollutants? Gases will remain here. Will accumulate where? Here. It will accumulate here and accumulate here. So they are called as polar stratospheric clouds. Polar because they are close to poles. Stratosphere, all of you understand about troposphere? Stratosphere. Stratospheric clouds. Polar stratospheric clouds. PSC ban jayega. They will become polar stratospheric clouds. Polar stratospheric clouds. Polar stratospheric clouds, which will contain CFC, HFC. Now you know, okay, यहाँ पे जो CFC हम release कर रहे हैं, कहाँ जा रहा है? यहाँ जा रहा है. It is not causing harm here. It is causing harm here. There is an ozone hole यहाँ पे है अंटार्कटिका के ऊपर. You got it? Ozone hole is forming where? Near Antarctica, close to Antarctica, 60 degree के ऊपर. We have one ozone hole here. Ozone hole here because of this. Ozone hole, ozone dimple here. Means small depression, dimple on the your chin. You'll get a small depression, a dimple like that. Ozone dimple in the Arctic, ozone hole in the Antarctic. There are two ozone holes now. Ozone dimple, ozone hole बोलते हैं इसको. See how it is happening. It is not damaging here. It is happening here. So ozone has become very thin here and here in two places. One over Norway, Europe. This is over Europe. Great Britain, Norway के बीच में. North Sea, above North Sea. All of you understand North Sea? All of you know North Sea Allah. There. This one is above Antarctica. I'll show you this now. Ozone hole. All of you remember, I'm going to NASA website directly. Okay, this is NASA. Okay, so see this. All of you can see
this here, the ozone.
Okay. See, now this is Antarctica here. Can you notice Antarctica? Okay, this is DU, Dobson unit scale. DU all stands for, all of you know, no, Dobson unit. 500 DU is normal, red. Normal is 500. How much is 100 is blue. You can see this ozone hole. कितना बड़ा है देखो. This 2019 footage. This is all normal. See this. Over the Antarctica, ozone has become very thin, means 100 DU है यहाँ पे. That means UV rays can easily reach Antarctica surface. You got it? Antarctica is now exposed to UV now. So like that we are going to lose our ozone, means what? UV rays are going to reach the Earth's surface. It can cause a lot of damage. UVC exposure can cause a lot of damage, like cancer directly to everyone. Okay, so UVC is dangerous. So this we'll discuss. This is jet streams. In climatology class, we'll discuss a topic called jet streams. So they are showing different years में how ozone was. Okay. This is our, I told you, ISS. So you remember this now. How ozone is getting depleted here? You got it? So ozone dimple, ozone hole. Okay, so please remember now. So scientists discovered this in 1980. 1980 में first time the ISS took the footage, and all the scientists around the world, they were like alerted about this, what is happening anta. So they all gathered, and we should do something about it. So they all convened a meeting with international leaders in the year 1986. Correct? The first time the discovery was in 1980, the ozone hole. In 1986, all the leaders, then scientists came together in a place called Vienna. Vienna Convention. Vienna is a place in Austria, capital of Austria. So there was a gathering, convention of all scientists and world leaders about ozone depletion. Vienna Convention on ozone depletion. So they all gathered and discussed what is ozone, how it is getting damaged and all. So in the next year, 1987, Montreal Protocol was signed. Montreal is a place in Canada. Montreal is in Canada. Montreal Protocol was signed. Protocol means an agreement, legally binding agreement. It is the only agreement signed and ratified by all countries. This protocol bans CFC. This puts a complete ban on CFC. CFC based chemicals nobody can use now. All countries stopped using it since then. So slowly it was phased out. So they started using HFC based, HCFC based chemicals after 1987. So all of you got it. First the discovery was in 1980. The gathering convention took place in 1986. They'll ask Vienna Convention. This will come in environment class also. When I discuss environment, there also I will talk about ozone. Vienna Convention के बारे में. Then Montreal Protocol the next year. Montreal Protocol exam they'll ask is related to which of the following? Ozone. Remember that. Okay. And very recently in 2016, there was an amendment to this. Montreal Protocol was amended in 2016, Kigali Agreement. Kigali, remember, we have discussed this. Kigali is a place in Central Africa, Rwanda. Rwanda's capital, Kigali. So in 2016, again, there was gathering of all scientists and leaders where they banned HFC also. Okay, so HFC, fluorine based chemicals also they banned. Kigali is an agreement, is an amendment to Montreal Protocol. This bans HFC as well. So we have to use alternative chemicals now. Okay, because these HFC, CFCs we are using, chemicals we are using R12, R22. These are name of the chemicals we are using. R12, R22, R32. R means refrigerants, chemicals, cooling agents. So they are causing a lot of harm. I'll show you that also. Okay, so I'll show you the scientific aspects of this. GWP and ODP. GWP is global warming potential, means how much they can cause global warming. ODP is how much ozone they can deplete, ozone depleting potential. We have a lot of scientific data. All of you see this? The image is not clear, but you can, what to do? I'll take some other image. I think this is clear. You can see type gas, that is R12, R20. I was telling you R12. R means refrigerants. Okay. ODP means ozone depleting potential. Means how much ozone it can damage in a year. GWP is global warming potential. You should understand all these terminologies now only. Exam they will ask, then you can't learn that in the exam hall. ODP, GWP, they'll ask. What is ODP, GWP? So CFC we were using first. R12 we were using first. You can see it has very high global warming potential. You can see. Okay, you can notice this. And also ozone depleting potential you can notice here. It was used in early car air conditioners, home air conditioners and all, we were using it. We use ACs in car also. So you can see they are harmful. Then you can see other HFC based chemicals we started using here. You can notice this. Various of them you can see. Now you can see R32 we were using. Presently this AC uses R32. On the side they have given this R32 mentioned on top of that list. Okay. So these are something that we are using on daily basis. Chemicals. Okay. So as a result, most of our ACs are using all this. I'll show you one more. So notice this. The various chemicals. You notice R290. R290 you notice this. R32 you notice this. Presently R32 being used. Global warming potential you can notice. But you notice 290. Hydrocarbon based R600 and R290 here. They have very low global warming potential. We can use this. But problem is they are highly flammable. R290 is propane. As a result, you know, it will catch fire. If I use that here, it is good. It doesn't cause harm to environment, but it can catch fire. That is another big headache. So as a result, we can't use hydrocarbon based. We can't use hydrocarbon based are highly flammable. You got it? So we are using other chemicals. You don't have to remember this. Just remember the words. Okay? How much they can damage. Ozone depleting substances. So write this down. Start from here. Quickly write this. Ozone depletion reaction. How ozone is getting depleted also I have given. Same chapter, same topic you continue. We will complete this today. Ozone depletion reaction also they will ask. Done. This is simple. So if they ask you what is ozone, how ozone is formed, how ozone is getting depleted, why it is getting depleted in these areas, correct? What are polar stratospheric clouds, and what is the protocol we have done to prevent ozone from depletion? Everything in one question I am writing here, one topic, so that it is like full essay type. If you start writing from the starting, you can stop at here. So you can just give a conclusion saying that ozone is very important for us. It protects us from harmful UV rays. It's our responsibility, collective responsibility. What is collective responsibility? Everybody's responsibility globally. Correct, not at a national level, at an international level, it's a collective responsibility of the world to protect ozone. So that you can write. UPSC is very fond of this topic, especially polar stratospheric clouds. Why ozone is formed, ozone hole is formed only there. Okay. And also in the last 3 years, we have noticed ozone depletion over Himalayas also. That I will tell you next. That is very interesting. I am doing research on that presently. I have a paper on that. One of the scientific publications I have on that particular topic, where ozone is getting depleted over Himalayas. That is my present topic as of now. Done. Shall I go to the next page? This will discuss again in environment class. I am not completing this topic. I am just telling you what it is. So what is polar stratospheric clouds? They'll ask. Polar stratospheric clouds, when I say, it is not a cloud of moisture. It is a cloud of gases. Cloud of CFC. Means I am saying this is a normal cloud. So we get rain from. These are normal. But these are ozone depleting substances they have. Polar stratospheric clouds are clouds which contain ozone depleting substances like CFC, HFC. Okay, when I say cloud, don't think of normal cloud. They are chemical clouds basically, dust cloud, aerosol clouds which contain ozone depleting substances. Ozone depleting substances, ODS. ODS. Okay. So questions can become technical. Okay. So as a result, you have to be very careful. In this, you can notice in one of the paper they had asked this also. I was talking about refrigerant category here, global warming potential, and NBP also they were asking. Means normal boiling point of different refrigerants. See the questions they are asking, like which of them has a very high boiling point and all they are asked. Low boiling point they have asked. So as a result, you can't expect that UPSC is not going to use this. That we can't say that. They might ask anything. 3 statements they'll give. So the chemicals that we use on daily basis are R22 has a very high global warming potential and ozone depleting potential, and it has a very low NBP, normal boiling temperature. See, they're using all these terms in one sentence, and students who are reading it, they'll be wondering where the question is coming from. And very scientific they are asking. Okay. Because the trend in UPSC is once they ask the question, then all coaching institutes start teaching. You got it? Then everybody will know. Till then, even teachers don't know. That is the problem here. That is the reason what we are doing is we are doing that the research level topics only we are discussing many times, so that it is part of SNT also or geography also plus current affairs. Okay. So remember up to this, how ozone. This part is clear now. Ozone part we have covered. We are here. Next, as we go up, here you can notice because of ozone also I told you temperature slightly increases. Because ozone interacts with UV, blocks UV, temperature slightly increases. Then as you come here, you can notice as I go up, here the air density is very low. Correct, molecules, number of molecules are very low. So temperature drops here. Air molecules are very far apart. So temperature drops to -100. Here you can see the water molecules, they freeze and they crystallize. You'll be asking, sir, how did the water molecules come here for the, up to this height? Most of the water vapor is here in the lower atmosphere. All the clouds we have are in this layer. Correct, in troposphere only. How did the water vapor come here? Anta? Like rockets we launch. PSLV, GSLV rockets we launch, these rockets go up like this through various layers. First troposphere, stratosphere, mesosphere. So the rocket exhaust releases a lot of smoke, lot of the combustion heat comes out, exhaust say, and moisture also comes out. Okay, that is one source, one of the source of this. Then most of the fighter aircraft like our Sukhoi or MiG, they fly in this mesosphere. Fighter jets take up this path up in the atmosphere, mesosphere. Okay, so as a result, the water vapor that is released from the jet engines or from the rockets will freeze, forming pearls. They glow in the dark. So the word nocti means nocturnal, night anta, nocturnal. Lucent means to glow. Noctilucent clouds. They are up in the sky, looks very beautiful. Many of you would have seen that. Noctilucent. If I show you the photo, you might recognize. Correct. This is the one. See, it looks like this. Okay, you can notice this is the sunset. You are noticing here, sun is setting here. You can see the red color, orange. You know why? Then you can see this sky. This is this crystal type particles, pearls in the sky. These are the noctilucent clouds. In which layer? Mesosphere. On a clear sky, on a clear evening, you can see this. Because there are no clouds here. As a result, up in the atmosphere, you can notice this noctilucent clouds. Late evening or early morning, you can see this. Okay, please remember. Yesterday's class, we started with weather and climate. And we are discussing air temperature. First topic. Air temperature. Check your notes. All of you know what is air density. Okay, we have discussed different layers of the atmosphere. Okay. Any doubt from yesterday's class? Structure of atmosphere is a very important topic. Lot of things we discussed in that. Correct. Many things which are not there in the books. Okay. If you notice that I have the source for that information is Just Perodos volume 1, volume 2. NCRT. All the NCRTs. GC Leong and other standard books. All that combined in one notes I have given. Okay. So as a result, you remember that is a very important topic. Structure of atmosphere. Next, weather and climate, air temperature. All of you know air is a mixture of gases. This is clear. Gases, dust and vapor. Then temperature is indication of how warm or how cold the air is. Correct? It indicates the presence or absence of heat. Presence or absence of heat is indicated by temperature. So yesterday's class I told you how we measure it. We use thermometer. Okay. Mercury based or alcohol based thermometer. Unit is degree Celsius or degree Fahrenheit. Conversion formula also I gave you. Okay. Then also write isotherm. Line joining places of same temperature is called as isotherm. What is isotherm? Line joining places of same temperature. Please write. Iso means equal. Therm means temperature. Equal. Iso. Therm andre temperature. Okay. Isotherm is the line joining places of same temperature. Okay. Isotherm or equal temperature. Who missed yesterday's class or starting classes of climatology? Anyone? You missed. Why? Why did you go? Why did you come back? No, but you can't miss the class climatology. I'm telling you, this is very serious topic. Okay, if you have missed, please make sure you watch the classes twice or thrice. Because if you don't understand this, you can't blame me because you have missed the previous classes. These classes of climatology, you understood what I'm saying. The all topics are connected. Whatever is the reason, you should make sure you have come and attend. These topics are like biology. You understand basic topics of biology, cells and all, right? Those classes are very important before you go to other advanced topics. Here you are directly coming to the post-mortem here of the topic. Then what will happen? You will not understand anything. Okay. So as a result, the climatology, I'm telling you, by today's class or next class, you'll understand why this topic is so technical. So please remember this. Okay. Whoever has missed, make sure you watch all the videos first before attending. So remember this. Okay. Temperature, presence or absence of heat. Okay. So now, based on the temperature, we can classify the air into warm air, cold air. Warm air, cold air. Warm air, cold air. Okay, warm air and cold air. Warm air means temperature is high. Cold air, temperature is low. Warm air means presence of heat. Presence of heat. Cold air is absence of heat. Absence of heat is cold air. Warm air is presence of heat. Cold air is absence. Okay. So we all know how the Earth's surface receives the energy from the sun. All of you notice this, please. Sun is the source of energy. It's the main source of energy. Correct? All our light and heat energy come from sun. All of you see the board now. Stop writing, please. The sun, say we get short wave radiation. We are getting short wave radiation that reaches the Earth. So Earth's surface heats up. The gas molecules, remember, they are transparent to the incoming short wave radiation. Okay. As a result, all the heat reaches the Earth's surface. Earth heats up. When the Earth heats up, what happens? It doesn't retain the heat. I told you, Earth is a bad conductor of heat. It doesn't conduct the heat down. It sends it out back. So that is called as long wave radiation. The energy that comes out is called as long wave radiation, outgoing radiation. What we receive is short wavelength radiation from the sun that reaches the Earth's surface. Then Earth heats up, starts sending out long wave radiation. Then the gas molecules we have here, greenhouse gases we have, that starts blocking that heat here. The greenhouse gases, let's say I'll use some other color for that. Here, greenhouse gases and all here. Carbon dioxide, methane, nitrous oxide. All these gases are here in large quantities. They are capable of stopping the outgoing radiation, long wave radiation. So our atmosphere is heated up from bottom up. So the air molecules tend to heat up here. When the air becomes warm, Earth is warm, air becomes warm. Warm air molecules, as soon as they get the energy, they start to move now like this. As soon as they get the energy, what happens? Kinetic energy increases now. Kinetic energy increases now. Temperature increases, the heat comes to the air, air molecules get the energy. As soon as they get the energy, they start to move. That energy of motion is called as kinetic energy. More the energy comes from the ground, faster they start to move. Faster they move. So air molecules collide with each other. They start to move apart. See here, they start to move apart. So the warm air expands. All of you understand this? Warm air tend to collide with each other and start to expand. Warm air tends to expand because of this. Why it expands? Increase in the Earth's surface temperature, air temperature increases, kinetic energy increases, that causes the warm air to expand. So density is equal to mass by volume. Density is equal to mass by volume. When the warm air expands, volume, density decreases. Try to understand this. One by one, stage 1, 2, 3, 4. When the volume increases, density decreases. So warm air is light. So the warm air tends to go up now, slowly. All of you understood this? The warm air expands and becomes light and starts to go up. That is the reason whenever you put fire somewhere, why does the smoke go up? This is the reason. अगर आग लगेगा नीचे ग्राउंड फ्लोर में, the smoke comes where? Upwards. You have to understand this physics. If you put a campfire, you are all sitting around the campfire. Sometimes, right, wood is burning. Remember, I have seen where this fire flame goes up upwards. Candle may, when you put a, let's say, flame, the flame always tends to move upwards. Why? This is the reason. Okay, the warm air expands and goes upwards, takes the fire up, smoke upwards. Understand this one by one. Okay. First stage is what? Temperature increases, Earth's surface from the sun. Then it sends the long wave radiation. that increases the kinetic energy of the air molecules. That makes them to move around, expand. When the warm air expands, volume increases, density comes down, making the air light. So warm air tends to go up like this. When all these warm air molecules start going up, the pressure decreases here, low pressure. See, so many points are connected. Here, क्या होगा? Low pressure हो जाएगा अब. Okay. Let's say you're all sitting on the chair. You get the energy, you stand up. So what happens? The weight of you on the chair will decrease. Just like that, warm air goes up, pressure decreases. See how the topics are connected. So the warm air, wherever it is going up, it causes low pressure on the surface. Whether it's land or water, same concept. Warm air goes up, pressure decreases. You got it? So on the contrary, here on the other side, let's say here it is receiving less sunlight, slant rays. What happens? Earth remains cooler. The places which receive slant rays, less sun rays, doesn't receive much energy because sun is the only source of energy. So slant rays means obviously less. So or if there are water bodies and all, so Earth remains cooler. So what happens? Air remains cooler. Air also remains cooler. Less energy transferred as a result. So kinetic energy will be low. Kinetic energy will be low. The particles don't move much. The particles, air molecules won't move. So they will be moving slowly. So since Earth is low at a lower temperature, kinetic energy is also lower. So molecules tend to be cold here. So they contract. Cold molecules contract. Air molecules contract when the air temperature is low. So molecules tend to come closer. When the temperature is low, air is cooler. So cold air molecules contract. Okay. Let's say Earth further cools. What happens? Kinetic energy further decreases. So the molecules further contract. Warm air gets more energy, expands. Cold air contracts. When the cold air molecules tend to contract, what happens? Air becomes dense. See here, density is equal to mass by volume here. When the cold air molecules contract, what happens to the volume? Volume कम हो जाएगा. Density increases. That is the reason cold air is heavy. So the cold air tends to move down. So I'll use other color, blue color I'll use. Cold air molecules tend to move down. Like this. Cold air molecules contract, become heavy, dense, comes down. What happens when the air molecules come down? Pressure increases, high pressure here. Becomes high pressure there. You got the understood the part here. That is the reason all this topic from the first day I was telling you short wave, long wave. Now I am applying it to the air temperature now. So when the earth heats up, any place, let's say we are in the early morning now, let's say 8 o'clock, 9 o'clock, we are getting less sun rays. So earth is cooler, air also is cooler now. Now, by the time you go to afternoon, 12 o'clock, 1 o'clock, earth becomes hot, expands, goes up, causing low pressure over this area. So temperature will be high on the surface here. Please remember this. That is the reason 12 o'clock, 1 o'clock we all feel warm or hot on a sunny day. Okay. So warm air goes up, cold air comes down. You got it? So this physics you understand, Allah, you will understand monsoon, you will understand cyclone. Very much linked with our topics. So any doubt should I repeat again? First, sunlight reaches the earth's surface. First step, temperature increases. Then when earth heats up, it doesn't retain, it sends it back. Long wave radiation. This second stage is long wave radiation. Third, that increases the kinetic energy. More energy comes from the ground, higher is the kinetic energy. So the warm air molecules tend to expand. They start to move faster. That increases the volume, density comes down. So the warm air is rarer. It expands and goes up slowly. Okay. As a result, pressure decreases, low pressure. LOW, low pressure. I'll write the same thing below this diagram now. Okay, if you want the theory, I will give you the theory also. But write this now. So how warm air tends to create a low pressure on the surface, you have to understand. This is the basis of cyclones, tornadoes, monsoon. Everything starts from this basics. Why sunlight can initiate wind movement. Now notice this, I'll tell you one interesting thing now. Okay, यहाँ देखो, यहाँ पे air is coming down. All of you notice this please. Here the air is coming down. Here the air is going up, correct? Like empty space is created here. Here the air is coming on the surface, here it is going up. So there is kind of a difference in pressure now. There is high pressure, low pressure. Pressure gradient is created now. As soon as this happens, this air is going up. In order to fill this place, the air from here starts moving like this. From high pressure to low pressure. That is called as wind. That is wind. Now you got it. What is wind? Air in motion. From high pressure to low pressure. You got it? So right now. This you don't have to write now. Wind part you don't have to write, but I'm telling you. So that I will remove. That is the reason I was telling you. So these topics seem to be very easy, but step by step you have to understand. So always remember, warm air expands. That is the reason. Okay, next time there is a fire accident somewhere. You are on third floor, fourth floor, just like we are in second floor now. Let's say in that building there is a fire below. Ground floor is on fire. What will you do? That is the question. Correct. Most of you think we'll go down or we'll jump. Can you jump out from the third floor, second floor? No, we can't. Only chances you have to go upwards to the top floor, balcony, where there is an open space, open air. That is the best thing you should do. Imagine that. Okay? You can't go down. Why? Because the smoke is also coming upwards through the staircase. If you go down, the smoke goes up, you inhale it, you die. You become unconscious. Because smoke contains carbon monoxide. It cuts off oxygen supply to your brain. You become unconscious there only. So it is not the fire that kills you. It is the smoke inhalation. Smoke inhalation is the biggest killer in the fire accidents. You remember that always. Any building you enter, first and foremost, look for the exits. How many exits they have? Any mall, any film theater you are going, any place you enter, first thing your eye should go towards the exits, emergency exit, because you are going there with your friends and loved ones. You don't want to lose them, nor get killed. Correct? That is a trauma you have to live with. You ask people like me, I'll tell you the incidences I have seen. Okay. So that will not, that will not let you sleep also in the night. If something like that happens, correct, I can't tell you that. So what you have to do, be careful wherever you go. Because these are some physics that we learn here. Disaster management. I'm linking these topics to disaster management. Why most of the disasters are related to geography, you understand now. You got it? So I was part of so many fire accidents also earlier. So in one of the places I rescued students. In Delhi there was a fire. I was working with NDRF back then as a ground staff. So the third floor is, the students are there, classes are going on, and the ground floor is a fire. First floor got gutted up, smoke is going up. So the teacher who was in the class suddenly went out, opened the door, the smoke started entering the classroom. The teacher suffocated there itself, he collapsed. The students were there, like this, same girls and boys in the classroom, third floor. No, they can't go out. Correct. So they're opening the windows and all, they're shouting from outside, like that. So by the time fire got there, you know how the traffic and all, by the time the fire reached there, it's almost half an hour. You see what they have done. All the boys who were there in the class, they removed their pants, they tied it up, tied the pant, put it on the pole. There was a pole pillar in the classroom. They tied it to the pole. They put it outside. First they sent all the girls down, then the boys got down. 3 of them collapsed, so they died. That is a different story, but most of them survived. You got it. The presence of mind there in the classroom, things will go sideways very quickly. You will not know what to do. Remember the last year's water accident? The water got logged into some library in Rouse Institute IAS. 3 students died there only. They were studying in the library in the evening hours. They got trapped. The electronic doors didn't let them go out. Water got in. They all got killed. Like that. So incidents can happen anytime, any moment. You don't know. So you have to understand what to do when in presence of mind. There you can't say I'm not going to remove my pant and all. You got it? How tough the situation can become. Either you save your life or you protect your dignity. That's it. So always, wherever you notice, fire always does this. So if there fire is entering the room, the best thing is you have to take some clothes, make it wet. Let's say a bottle of water you have to make it wet and cover your face first, so that the smoke doesn't pass through the wet towel. Correct. Water acts as a barrier, so the smoke can't inhale. Dry towel, it will allow the smoke. Wet towel, will always prevent your smoke from entering your nose. That is one thing. Then most of the smoke always goes up and then moves up in the ceiling level. So you have to bend down and walk, crawl out of the building. If you walk like this, what happens? The smoke is also rising in the same direction. You will inhale. So best thing is to crawl and pass through that building. Okay. So if chances of going upstairs, that is the best, because where the fire extinguishers can come, they can rescue you through a ladder. If you can cross over to the next building, that is again second choice. Not to go down at all in case if the ground floors are on fire. Okay, like this you should understand. Disaster management is linked with this topic. Everything we do connects to this. Any other topics of climatology? Okay, we'll come to know. Okay, so please remember this. So what happens? All of you wrote this. So if you want to write the theory, you write here. When Earth's surface heats up. Can I go to the next page? Can I? When the Earth's surface heats up due to insolation. I am writing the reason also. Insolation. Earth emits long wave radiation. Terrestrial radiation. What is terrestrial? From the Earth. Long wave terrestrial radiation, which warms the air molecules. When I say air molecules, greenhouse gases, which warms the air molecules near the surface. Okay, this is one paragraph. When the Earth's surface heats up due to the insolation, Earth emits long wave terrestrial radiation, which warms the air molecules near the Earth's surface. This warm air expands. And becomes rarer. All of you understand the word rarer? Becomes rarer. What is rarer? Means lower in density. This warm air expands and becomes rarer. As a result, rises up in the air, becomes rarer, and rises. Can I use the word ascend? Rises or ascends. Ascend means what? To go upwards. Ascends up in the air. I'll write that here. You continue here only. Okay. Rises or ascends up in the air. Why? Because warm air expands and goes up. Because of increase in the volume. Because warm air is expanding. You notice here. Warm air is expanding. So volume increases. Density decreases. So warm air molecules have lower density. Ascends up in the air, causing low pressure on the surface. Exerting low pressure or causing low pressure on the surface. This for this one, warm air. Okay. So why? Already I told you. Correct. Temperature increases, air becomes warm, kinetic energy increases, warm air expands, volume increases, density comes down, warm air goes up, causing low pressure. Clear? Physics behind it, all of you understood. Next slide, right. See, if Earth starts emitting radiation, what happens? After some time, Earth will cool. Next paragraph, right. When the Earth's surface cools down, here, this side you write, this side. On the cold air side. When the Earth's surface cools down, air molecules near the surface. When the Earth's surface cools down, air molecules near the surface cools and contracts. cools and contracts and becomes denser. And becomes denser. When the Earth's surface cools down, the air molecules near the surface cools and contracts and becomes denser. As a result, the cold air molecules descends down. In this case, ascends. In the colder case, descends down. DES, descends down. Exerting high pressure on the surface. Exerting high pressure on the surface. Exerting high pressure on the surface. Okay. Exerting high pressure on the surface. Be careful, huh? This one I am saying. What I am saying, when the Earth's surface cools down. Why it cools down, you might ask? By radiating the heat. Whatever heat it has received, it will radiate. It will cool. As it cools, air molecules near the surface cools, contracts, becomes dense. And this cold air comes down, exerting high pressure. Okay, please remember this. So that means when the temperature changes, the pressure also tends to change there in that area. Okay. Let's say I am on the surface here. See, I have a big basket here. Okay, I am standing inside that basket here. Okay, I also have a propane gas cylinder. I have 2 cylinders full of propane gas, flammable gas. Okay, I am carrying a gas cylinder with me. What I'll do, I'll turn on the knob, light the flame. Flame aa gaya, dekho. Flame. Okay, flame is there. Now I'll connect this to a balloon, like this, to a balloon. With ropes, I'll connect it to the balloon. What happens now? The air is getting warmed up by the flame. The flame is eating the air, so the air becomes hot. Normal air becomes hot air now. Why? Because I am giving heat supply. There I am. What happens when the air becomes hot? Expands. When hot air expands, it pushes the balloon up. Balloon also expands. All the warm air starts going up like this. So it lifts the balloon. The balloon goes up. When the balloon goes up, what happens? It is connected to the basket. Basket goes up. I am standing there, so I can also go up. Hot air balloon. That's how it works. Hot air balloon. So warm air expands and goes up. Takes the balloon also up. All of you have seen hot air balloon. Okay. So as the balloon goes up here, let's say it is going up now. So see the balloon. Let's say this is the balloon. So slowly the balloon has gone up like this from the Earth's surface. Here, see, from the Earth's surface it has gone up. Now if I have to come back, what will I do? I'll first turn off the flame. Because I don't have to warm it further. Because if I keep heating it, it keeps going up. Because this air is hotter than the surrounding air. You got it? So the hot air gets displaced upwards. The surrounding air is colder, it comes down, the warm air goes up like this. So the hot air balloon keeps going upwards. I can't go beyond a limit because oxygen supply also I have to take care. If I go very high, so people inside will die. Correct? Oxygen nahi rahega upar jate. So we can't go very far also. So I have turned off the flame now. This air will now, because of the surrounding environment, it will cool. Why? Because surrounding atmosphere also now starts interacting with the air molecules because there is no heat supply. The air becomes cold now. Slowly, the air inside will become cold. So it contracts now, starts contracting like this. So it pushes the air, which pushes the basket down now. So the balloon comes back. While going up, we use hot air. While coming down, we use the cold air. Okay. So please remember this. So like this, we can go up and come down. There will be a person who will be controlling the flame. He's called as a pilot of the hot air balloon. While coming down, if he doesn't control the flame or if he keeps it off, what happens? The cold air will push it down. So it will come down very quickly. The gravity also acts on it. So it can collapse and cause accident. So what he will do? He'll turn on the flame for a few minutes, turn off. Turn on, turn off. So that it keeps the air slightly warmer. So that the descent is slightly slower. Otherwise, if he doesn't do that, suddenly it will come down. Correct. So it might kill the people who are standing inside the hot air balloon. Okay, so please remember this. So simple physics. Okay, fire accidents you know now, hot air balloon part you know. Okay, let's say this is the large urban area. I'm taking urban now, urban areas. Okay, okay, I'll tell you one more application also here. So notice that in summer air becomes hot, correct? Summer the insolation is very high, air becomes hot. Hot air expands and goes up, right? It will take all the smoke also, dust also. In case if there is any vehicle smoke, fire accident, that smoke goes up. So ground level pollution is low if the air is warm. Okay, so that is in summer may we don't face pollution related problems. For example, Delhi in summer no pollution, but in winter earth surface temperature is very low, earth is cooler, air becomes cold. What happens when the air is cold? Cold air comes down Allah. It keeps all the smoke here only, all the vehicle smoke, industrial smoke, automobiles, everything remains there only. So it becomes a gas chamber in winter. In winter the air becomes cold and comes down, keeps the pollutant there only. Okay, as a result pollution levels are higher. That is the reason in winter November onwards you can't go there. All of you got it? October November temperature comes down. Entire northern India, Punjab, Haryana, UP, Bihar, West Bengal, Assam, so it will be cold. Earth surface is cooler, air becomes cold, cold air comes down. As a result in that time if you let's say vehicles are there, diesel vehicles, they'll all release pollutants. Farmers are burning husk, stubble burning, all that smoke will remain where? There only. Let's say we have Deepavali also, we burn lot of crackers, correct? So as a result that smoke also adds on to that. Where it will go? It will remain there only, as a gas chamber it will become. So pollution levels increase in winter because of this. You got it? All of you understood this? Why in summer Delhi doesn't suffer from pollution, but in winter it suffers from particulate matter pollution, smog and all. Why? Because of this. Because the cold air comes down, dense, it remains on the surface. So pollutants also remain there only. So that causes pollution. That is you should not burn wood that time. Stubble burning we should not do. We should not burn crackers. We should understand Deepavali is a festival of light, not sound. Correct? You have the entire year to burn crackers. Summer may you burn. Winter may you just light a candle or light. That's it. I'm not against the festival. I'm telling you how it is. Okay. Because the air quality is so low in Delhi. People don't understand that. And also we have this one. Cigarette smoke also along with that. All that adds up and causes severe pollution. Okay. So please remember this. Then industries, don't forget industries. Large number of industries also release a lot of smoke. That causes pollution. So what are the reasons and all? We'll discuss that. Before that, I'll cover one more topic. Let's take any urban area. In urban areas, we have secondary and tertiary activities, correct? Secondary means manufacturing. Tertiary means service sector. Urban areas are surrounded by rural, which are characterized by primary activities, villages, farms and all. Okay, here. Urban areas, because of secondary and tertiary activity, population density is very high. Population density is very high. You can see large number of people living in 1 square kilometer area. Number of persons per square kilometer is very high in urban area. In rural, it is less. So cities are congested. So everywhere you see buildings, correct? Roads, buildings. Green space is less. Everywhere you notice there will be roads, correct? Buildings, roads. Water bodies are less. Tree cover is also less. Tree cover, green cover is very low, correct? Automobile density very high. Automobile density, every day we add around thousands of vehicles. I don't know the statistics of Hyderabad, but almost every city is adding a lot of vehicles, bikes and cars every day. Hundreds and thousands of vehicles every day. Automobile density, industrial density is very high. Correct, industrial density is very high. So as a result, what happens? Everywhere you notice only buildings. You can see construction going on, trees they are cutting and building new trees, new buildings everywhere. So we all live in a concrete jungle. Cities have become a concrete jungle now. So cities are concrete jungle today. Everywhere you see, go in a metro and look around like this. Everywhere you see only buildings there. And what are the materials used? We use bricks for construction, stone, rocks we use, iron we use, correct? Cement, like this. All this material, they absorb lot of heat. They absorb lot of heat. And roads, tar road we have, cement roads and tar roads, correct? Either the tar road is there or the cement road is there. Bitumen roads and cement roads we have. So everywhere it is concretized. Even the footpath is concretized with slabs. So there is no space for the water to go also. And water bodies are encroached. Wherever the lakes are, slowly it is encroached and mall is built. Mall is built like that. So as a result, you can see urban areas are concrete jungle. So tree cover, farm, this one, like parks, gardens are less. Okay, so please remember this. What happens now when the sunlight falls on the cities? All this region heats up. Temperature increases. The city records higher temperature. The city records higher temperature. Higher temperature because of the insulation, because of the material used, because of no space for ventilation also. If you notice, everywhere you build buildings, each building of different height. What happens? The wind can't blow at a stretch also. It can't take away the heat of the city. So all the heat is trapped there itself. Because each building has different height. So wind can't also move from one place to another. As a result, all the heat is trapped here only. So temperature of the urban areas is many degrees higher than rural. In rural areas we have farms. Everywhere you go in rural areas we have farms. Temperature tends to be lower here. Temperature in the rural areas tends to be lower. But in the city, many degrees higher. 5-6 degrees higher than the rural. This is called as urban heat island. Urban heat island. Cities act as a heat island. Cities act as a heat island. Urban heat island. Urban heat island. What is heat island? This area is hot compared to the surrounding cooler. Cooler air. Okay. So please write down what is urban heat island. They'll ask. Every city is becoming urban heat island today. Okay. So cities are becoming increasingly warm than the surrounding rural areas. More we construct, more heat is trapped. You might have seen around 12 o'clock afternoon you walk on the road without the shoes. It will be so hot, correct? Or on top of the full building also, ceiling. ऊपर जाएंगे आप terrace we call it as. Without the shoes, if you start walking, you'll see it will be so hot. Correct? It will bake your feet. So as a result, the cities are absorbing a lot of heat. Cities also have poor albedo. Reflectivity is very low. That also I write. Cities have poor albedo. Reflectivity of the cities are low. I'll explain what is albedo. I'll explain. So urban areas are a concrete jungle now. Water bodies, decreasing water bodies, correct? Correct. Encroached. Lakes are encroached. As a result, there is no space for the water to go. Footpath is paved. Road is paved. Correct. Very few water bodies. See, very few lakes. Earlier we had hundreds of cities. Hundreds of lakes within the city limit, or in the surrounding side. We had large number of lakes. Now, because of urbanization, what is happening? So the cities are expanding. Correct. We are experiencing urban sprawl. What is urban sprawl? Physical expansion of the city. Physical Expansion of the city into the surrounding area is called as urban sprawl. City is growing slowly, surrounding villages are also part of the city now. Okay, so around Hyderabad you would have seen so many hallis, villages, palli we called as, all of them part of the city today. Okay. Huh. We can, when the heat is trapped, then we can call it as heat dome. Heat dome concept is different. It happens in US regularly in the month of June, July. When the surface heats up, hot air gets trapped there only on the surface. I'll show you next. Heat dome. Okay. So cities are becoming heat islands now. Global warming, one of the reason. We can't blame global warming for everything, for human activities. Correct. It is us we are doing this. Because who is creating urbanization? We are creating it. Buildings, new buildings, we are constructing it. Expansion of urban areas, we are creating. Within Hyderabad only, you see a lot of deforestation taking place. In the name of urban development, they are declassifying forest now. Once upon a time, a reserved forest is now called as a plantation. Within Hyderabad only, that's what they are doing. Allah. First, what they do, let's say there is a forest. It is a reserved forest initially. So, government can't do anything. What they'll do, they'll name it as a plantation. Reserved forest को क्या करेंगे? Plantation बना देंगे पहले. Once they do plantation, what happens? When the definition changes, then the government can utilize that land for any urban purpose, any development purpose. So that's what is happening here in many of the cities. So they change the definition of that area itself. Once upon a time a reserved forest, correct, now becomes a plantation for the government, or a scrub jungle. So they'll say there is nothing there and that. But they can't understand the diversity it supports. Even a scrub or grass or a plantation supports a lot of diversity. A lot of animals will be there, birds will be there, reptiles will be there, correct? Water bodies will be there. Thus open lands absorb water during heavy rain. You got it? You can't just go there, clear that and build buildings. Because such natural areas are very important for water to percolate. Improve our groundwater situation. You only notice our area only here. This area, Gandhinagar, Ashok Nagar and all. When it rains for half an hour only, you can see water logging everywhere. You know that. Notice the water here. It can't go either way. There is compound that side, this side also compound. Where will the water go? They will put cement also here. Cement roads hai, sabhi. Where will the water go? Our drains are already clogged with waste, plastic and all. So where will the water go? It will remain on the surface, causing flood. Urban flood. Urban flood. Even if there is a tree, around the tree they will put cement. Where will the water go now for the plant? That is the reason the roots become weak and the entire tree will collapse on a windy day. Whenever there is a lot of winds, the tree will collapse. Here only in Hyderabad only we have seen a lot of trees collapsing. Because around the tree there are not living space for the water to go down. So the tree is choked now. The plants are choked in the urban areas. Slowly the plants die. So urban areas, because of the water bodies here, you know, the small water bodies are there. Because of the heat, what happens? Evaporation is more. More evaporation. More cloud formation and rainfall. Cities receive more rainfall than rural areas today. Do you know that? Urban areas record higher temperature also, higher rainfall also because of convection. The heat, say, water evaporates, goes up, clouds form, come down. When it rains, there is no space for the water. Where will the water go? It will remain on the surface, causing flood, urban flood. That is the reason you see a lot of floods in cities like Mumbai. Have you seen the photos from the last 2 days? Floods in Mumbai, floods in Bangalore. Correct, everywhere on the surface there is water. Plus nowadays the construction activities are so poor. On the flyover also we have water. The water logging is there on the flyovers. In many of the flyovers I have seen, the water will accumulate without a proper drain for the water to come down, and water will be flowing, overflowing from the flyover. And you are going there and you are seeing the Niagara there, urban Niagara. Niagara Falls ho jayega urban areas mein. You got it? We call it as urban Niagara. Remember that, urban Niagara. All of you heard of Niagara Falls? Niagara Falls where? North America. U-shaped waterfalls. So as a result, from the flyovers, water starts coming down, causing urban Niagara. They'll ask, what is urban Niagara? They'll ask. Okay, urban floods, urban Niagara. Okay. So urban floods are the major problem for us because it will put a city on hold. It will pause the city's activities. Normal rain, pani aana chahiye, it should go. But since we are all encroaching the water bodies, cutting trees, deforestation everywhere, urbanization, as a result, the water has no space to go, resulting in accumulation over the city. Remember, for few days itself, we'll lose lot of revenue. Urban flood के वजह से you can't go to work. That day's income is gone. You will not be able to earn revenue. Tax also comes down. Correct. Income tax collected during that day. Commercial tax collected during that day. Correct. Lot of things goes down that day. Tax income for the government also goes down. For you also goes down. Our economic activities slow down. Because of urban floods, we are losing at least 2 to 3% of GDP every year. Otherwise, our country will grow faster. Now only we are growing at the rate of 6.4% now. It is said that if we all control urban floods properly, India will grow at the rate of 8%. So these kind of events are slowing us down. Correct. Overall GDP can increase by another 2% if we control floods, urban floods in the city. Because cities are the engines of urban growth or economic growth of the country. Cities are called as the engine of the economy. Engines of economy, Indian economy. So because lot of revenue gets generated from the cities. Do you know the amount of revenue cities like Mumbai, Hyderabad, Bangalore generate? It is equivalent to the GDPs of our neighboring countries. You got the point? The cities generate so much income, they are equivalent to the GDPs of the neighboring countries we have. So that much revenue cities generate. So you can't clog them like this. You have to manage it properly because sooner or later you get into civil service. After 10 years, 15 years of experience, you will be in urban development authority. Like Hyderabad Development Authority, some BDA, Bangalore Development Authority, you will be one of the MDs. So there you will be there looking at the same problem. Now you are reading it. There you will be facing the problem. So as a result, you understand this. What can be done? Protect the lakes. Prevent encroachment of lakes first. Because lakes absorb floods. They absorb water during the floods. So more lakes, better the city. Better for the city. It will keep the city cooler also. Control flood also. Then more plants everywhere. More trees and plants. That will prevent the water from logging on the surface. The trees will absorb the water. The water goes down. You got it? As a result, you should plan in such a way and drains should be cleaned. Every drain has to be cleaned before the rainy season starts in the month of April, May itself. So the floods can be avoided. So flyovers have to be cleaned up. Wherever the clogging is there, drains are blocked. Those things you have to clear it before the rainy season starts. Simple things. I'm not asking you to go and become UN head and all. I'm saying simple things. Already you're cleared civil service. Simple steps you have to take to prevent flood. So because of I already have given you the economics of it. We are losing 2% of the GDP annually because of floods. Urban floods, especially in urban areas. Okay. And because of waterlogging, what happens? Water goes into the low-lying areas, cellars, basements first. We have a basement, right? So the water goes in first. The people who are living in the basement will get affected first. That's what happened in Delhi last year. Same time, August, May, that incident happened. Like that. So a lot of innocent civilians will lose their life. Okay. And because of old buildings, what happens? If it is waterlogged for so many days, the structure becomes weak. It will collapse. In Mumbai, we are seeing that. Many old buildings in Mumbai are collapsing because of this. Urban flood causes a lot of structural collapse also. Okay. And a lot of people are killed during the collapse. So please remember this. So tree cover is decreasing, automobile density increasing, industrial density is increasing, water bodies are declining. As the city is slowly encroaching the surrounding villages, urban sprawl. Physical expansion of the city into the surrounding area is called as urban sprawl. What is urban heat island? Cities are higher than, temperature of the city is higher than rural areas. The temperature of the city is many degrees higher than the surrounding rural area. So it is called as urban heat island. Okay. Because of this heat, what happens? Pollution, oh right, environmental degradation, air pollution, water pollution. I didn't mention that. Cities are highly polluted, correct? Pollution. Pollution levels are very, very high. Air, water, radiation pollution, light pollution, correct? Cities, other name of the city is pollution, correct? City and pollution is synonyms now, because every city you go there is the same problem, pollution. As a result, people who are living now, come to the people. We are all urban dwellers. We are the residents of the city. Whether you like it or not, you have to live here because of economic reasons. Your earning comes from the city, so you live here. So it will affect your health. Every day living in such a polluted environment, it affects your health. I'll discuss albedo. Next word, please write albedo. Albedo comes from the Greek word albus. Albus, meaning white. Albedo means the reflectivity of an object or a surface. Reflectivity of an object or surface. Albedo means reflectivity. It is the amount of light heat reflected before it is being absorbed. Please write. It is the amount of heat. Albedo is the amount of heat reflected before it is absorbed. Okay, or before being absorbed. The amount of heat reflected by the surface before it is absorbed. Okay, or portion of heat reflected by an object before it is absorbed. I can say amount or portion of heat falling on the surface reflected by the surface before it is absorbed. Can I say albedo varies from 0 to 1? I'll tell you the range now. Albedo varies from 0 to 1. High albedo, high reflectivity for white surfaces. White surface have high albedo. Black has low albedo. Means it absorbs everything. Black, let's say I'm wearing black shirt, black pant. What happens? Black shirt, black pant, it absorbs heat. Albedo is very poor poor albedo. That is the reason road absorbs heat. Road, why it's so hot during afternoon? Correct. If you walk on it without the shoes or sandal, correct, your feet boils or it bakes your feet. Why? Because the black objects absorb heat. As a result, it becomes very hot. So black surfaces have very poor albedo. Whereas white surfaces like white paint, what happens? It reflects everything. Let's say I'm wearing white shirt, white pant. Whatever light falling on it will get reflected. So my body will not heat up. That is the reason on a hot day, summer, we should wear white clothes. That will reflect most of the heat. Okay? Most of the heat. So please remember this. White surfaces have very high albedo. High albedo. Write this. High albedo. What is white surfaces? Snow, glacier, clouds have very high albedo. That is the reason we should maintain snow cover, ice cover. We should protect our glaciers. Because more the ice, more the glaciers on the earth's surface, more they reflect the heat falling on it before it is absorbed. Earth remains cooler. Just like having white shirt, white pant. Why do you think our rural areas, villages, people wear white shirt, white dhoti, white topi, Gandhi topi? Have you seen? You go to most of Maharashtra, Madhya Pradesh, this belt. Correct. Even in rural Telangana also I have seen wearing white shirt, white lungi. That is their attire. Every day they go out like that. Okay. Why? Because it reflects the heat. It keeps them cooler. Okay. So please remember this. This blazer and all was introduced by the British to us. You got it? It's not for us. Tropical regions के लिए नहीं है वो सब. Correct. It might look good on some festivals or some occasion, but not the daily attire. Okay, because it warms you. Already you are in a hot country. You got a tropical country you are living in. So above that you are wearing a coat means what? you're working like a bakery or a oven inside. So as a result, you should know what type of clothes to wear when. Okay. So black surfaces absorb heat, retain heat. Like tar road, you write examples. Low albedo, this is poor albedo. Black surfaces have poor albedo. Examples you write here: snow, glaciers, clouds, clouds. All these are white. Why do you think we prefer white painting for the wall? Correct. It keeps the room bright. It makes the room bright. One. Plus, at the same time, it doesn't warm up, heat up. That is the reason outside the building we prefer to wear. Put what type of paint? White. You go to deserts. Go to deserts. They all prefer to put white paint. Like Morocco, Sahara region, mein almost all buildings have white paint. I have seen. Gulf countries, why do men wear the robe and women wear different colored burqas, white and other colors? Why? Because it reflects heat. White. Okay. Remember this. So high albedo, white surfaces. Black objects, black surfaces, like a rock, right? Roads, tar road, especially tar road, rocky surface. Wherever we are, like Golconda like rock, Guti, rock, we have a la. There. They all absorb heat. Polluted water bodies like you see Musi river. Have you seen the grey water? That is all grey water, polluted water. Grey, right, grey water. Polluted waters are also having poor albedo because they absorb heat. The water from our kitchen, washroom, all go to the drain nala. That all is what? Grey water. Polluted water bodies have poor albedo. Okay. High albedo is snow, glaciers, clouds. So that is the reason. If you notice our Earth surface, let's say this is Earth. So we can see polar regions, we have ice here in this part. Here also we have ice, glaciers. So when the sunlight falls on it, what happens? Most of the sunlight falling on it here get reflected out. Correct. It is not absorbed by the surface. It keeps the planet cooler. That is the reason the heat absorbed by the polar regions are very less compared to the tropics. Tropics on an average receive 340 watt absorbed is very high per square meter. Whereas the polar region is just 70 watt because most of the glaciers reflect the heat before it is absorbed. As a result, polar regions keep the planet cooler. So snow and glaciers and clouds have high albedo. Reflectivity is very high. Important. Earth's average albedo, please write. Earth's average albedo is 0.31 or 31% because the albedo ranges from 0 to 1. Earth's average albedo is how much? 0.31 or 31%. This is asked in the exam. What is the Earth's average albedo? Albedo means the reflectivity of the surface object. The portion of light that is reflected before it is absorbed. Okay, simple definition I am giving you. Albedo means what? The portion of light reflected. Portion of light reflected before it is absorbed. Please try to understand this topic, okay? Why do you think many places mein tar road they are removing? They are replacing it with cement road. White topping they call it as. White topping of urban roads. Old tar roads are being removed and they are replacing it with cement roads. So that it's like it increases the albedo of the city. As a result, the cities will become cooler. That is one of the reason. Okay. Please remember that. So right now, albedo of planets, of all planets, we'll see now quickly. All the planets have their own albedo. We'll see that quickly. Okay, notice this. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. All of you know the planets. So notice all the planets albedo. Earth I told you already, 0.31 or 31%. Okay. Notice among the inner planets, Venus has the highest albedo, 0.59 or 59%. Because when the sunlight falls on Venus, what happens? Almost around 59% of the light that is falling is reflected back. 59% of the light falling on Venus is reflected back into the solar system. As a result, Venus is the brightest object in the sky. Early morning star, evening star bolte हैं इसको. Morning star or evening star. It is not a star, it is a planet. But it appears very bright in the sky. Have you noticed Venus in the sky? Bright it appears. How do you distinguish stars twinkle? Stars twinkle because they have their own nuclear fusion taking place. But planets don't have that. Planets just reflect the light falling on it. The sunlight falls on these, gets reflected. So Venus is the closest to Earth. Venus and Earth are closest to each other. They are called as sister planets. These two. Twin planets bolte हैं इसको. So they are close to each other and also size wise they are almost similar. Almost. Earth is slightly bigger. Okay, notice this. Venus, if you notice carefully, okay, it appears early in the morning, late in the evening as a bright star. Morning star, evening star bolte हैं इसको because it has very high albedo, 59. Venus atmosphere also contains lot of carbon dioxide. Venus atmosphere contains sulfuric acid clouds. As a result, it retains the remaining. That is, then Venus is the hottest planet. It is not the Mercury which is hottest. It is the Venus because of its carbon dioxide atmosphere. So please remember, it has high albedo also. 59% is reflected back. The remaining 41 is absorbed in the Venus atmosphere because of the carbon dioxide. So Venus is the hottest planet. Clear? Now, coming to the outer planets, notice this. Among the outer planets, Uranus, Neptune have the highest albedo. Okay, you notice this also. Please write down this. Uranus and Neptune atmosphere contains methane. They contain a lot of methane. That is the reason they have high albedo. Okay, right now. So we know the portion of sunlight insolation reflected by the surface is called as albedo. All the planets, they might ask this question, albedo of planets compared to albedo of Earth. They can give one statement. Albedo of Venus, Jupiter, Saturn, Uranus, Neptune are higher than albedo of Earth. First statement. Be careful here. Even if you don't know one of them, you can't answer. Correct. Albedo of Venus, Jupiter, Saturn, Uranus, Neptune are higher than albedo of Earth. First statement. Albedo is the portion of sunlight reflected by the surface or by the planet before it is being absorbed. Yes. Earth's average albedo is 0.31. Correct. Or 31%. Venus is the hottest planet because of carbon dioxide and sulfuric acid clouds in its atmosphere. Correct. So like that, many statements they will give. Which of the following statements are correct? Only 3, only 4, only 2 statements like that. Done? Can I go back? Here. Now come to this. Any doubt in this, you please remember. Albedo of the earth, they will ask. One question on this I am expecting. What is albedo? Urban heat island, we know. Why cities like Delhi suffer from severe pollution, they will ask. The question was once in mains, Delhi, Mumbai, Chennai, Calcutta. Mumbai, Chennai, Calcutta are the major metropolitan cities of India. Correct. All these are metropolitan cities. All of them have same population, almost high population, population density, industries, automobile, everything. But why Delhi suffers from pollution? That was the question. All these are major metropolitan cities of India. Cities of India. But why Delhi suffers from severe Air pollution. That was the question asked in the mains. When they ask you such kind of question, it's like a comparative analysis they are asking with other cities. Okay, first and foremost, you should talk about the location. Notice all these cities in your atlas quickly. Check out the देखो Delhi is here. Delhi. Delhi. Mumbai is here. Chennai. Kolkata. This is Tropic of Cancer. Tropic of Cancer 23.5 degree north. And also we have water body. Arabian Sea. Bay of Bengal. Indian Ocean. India is a peninsula, correct? All of you know. We have water body on all these three sides here. And Mumbai, Chennai, Calcutta are, these three are coastal. Coastal. That is a very important point here. Notice that these cities are all tropical cities, correct? Tropical cities. All of them are in the coast. So they have maritime influence. They have maritime influence. The word maritime is related to the city. Sea. Related to the sea. Maritime is a word related to sea. Okay, please remember. So they have maritime influence. Influence from the ocean. I'll tell you what is that. Whereas city, Delhi, you notice, it is subtropical. Delhi is a subtropical city. Subtropics. Yes, 1 point. Second, it is away from the coast. Away from the water body. Continental climate. Continental climate it has. So the ocean influence is not there here. You got it. Whereas Mumbai, Chennai, Calcutta have maritime influence from the coastal areas, which is lacking in Delhi. Okay. These cities have small range of temperature. That means maximum minimum temperature is very low. Range of temperature means difference between maximum minus minimum. I'll tell you why. What happens here? When the temperature increases during the day, the sun's insolation falls on all these areas. Day temperature starts increasing. Because of the water body, what happens? The water body absorbs that heat. Let's say next to the city only there is a huge water body, ocean, Arabian Sea, Bay of Bengal, Indian Ocean. As soon as the land heats up, the water body absorbs the heat. Specific heat capacity of land is very low. Correct. Land will quickly heat up, quickly cools down. Whereas oceans have very high specific heat capacity. Water has very high specific heat capacity. That means it takes more time for the water to heat up. More energy it takes for the water to heat up and cool down. The specific heat capacity is the amount of heat required to increase the temperature of a substance of 1 gram by 1 degree Celsius. So specific heat capacity of land is low. Specific heat capacity of water is high. That also you should remember. Lot of physics is there. So specific heat capacity of land and water is different. Land ka specific heat capacity is low. Water specific heat capacity is high. So what happens? Land quickly heats up, quickly cools down. Water takes a lot of time to heat up and a lot of time to cool down. With this basics, you know, understand this. Land heats up right quickly, whereas water is heating up slowly. So during that time, what happens? Land becomes hot, water will be cooler. So conduction takes place. Conduction from land to water. Conduction is a heat transfer from warmer side to cooler side, colder side. So land गर्म होने से क्या होगा? The water will absorb that heat quickly. So keeping the land temperature low. You got it? That influence is what? Maritime influence. So water always makes sure it absorbs the heat from the land. So reduces the land temperature during the day. Let's say land cools now. Now water is warm. What does that do? Reverse conduction. The water will conduct the heat back to the land. So keeping the temperature of the city moderate. Neither too high nor too low. That is the reason city का temperature coastal areas में maximum temperature will not be very high. 40-50 नहीं जाएगा. In the coastal areas, maximum temperature will be 30-35. You see Visakhapatnam 30-35 होगा temperature. Lower temperature is around 20-22-25 like ऐसा रहेगा. The range is out 10. You got it? Simple. Land heats up, water absorbs the heat. When land cools, water returns the heat back to the land, keeping the land temperature moderate. The range of temperature is low. Coastal areas have low range of temperature. Coastal areas have low range of temperature. You got it? So water makes sure that land doesn't heat up. That is the reason more water bodies we have around the city, better it is. If you have hundreds of lakes around the city, the water will absorb the heat whenever the city heats up, keeping it cooler. Whenever the city cools down, land cools, the water will impart the heat back. So water has that capacity, correct, to moderate the temperature of the area. So water has a moderating influence over the land. So that is in you every day you might notice why does your mother put water in front of the house? Why does she keep a bowl of water in the front of the door, close to the door? Like many people would have seen a bowl of water with flowers, especially in the northeast section of the house. So that is a place where the first sunlight falls on that area itself, east facing houses may. So as a result, when the water evaporates, it takes the heat away, cooling the surface. Evaporative cooling, we call it as evaporative cooling. The water has evaporative cooling effect. More water you are surrounded by, water keeps evaporating. As a result, gives the cool breeze in the city. Evaporative cooling बोलते हैं उसको. So water bodies give that evaporative cooling effect. You got it? That might make you feel humid. थोड़ा humid रहेगा. Coastal areas will make you humid, but that evaporative cooling will keep the city cooler. Delhi doesn't have that. Delhi has very high range. You come to Delhi, I'll show you the maximum temperature 48, 49 जाएगा temperature. North Delhi recorded 52 degrees Celsius. Can you imagine 52 degrees Celsius? I'm not joking. You just Google highest temperature recorded. So 52, 53 जाएगा temperature. This belt, Rajasthan, Punjab, Haryana belt में maximum temperature, because it is away from the coast, the temperature, maximum temperature is around 55, 52, I'll write 50 average. Minimum temperature in winter goes to 0. See the temperature drop in winter. You got it? What is the range? Almost 50 degrees is the range. Do you have the Hindu newspaper? I told you to bring Hindu newspaper. Anyone? Hindu? Get the Hindu newspaper, na? Somebody get the paper. At least tomorrow. Okay. So I'll ask them. Wait. So write this down. Why Mumbai suffers from severe air pollution? So Delhi has a very high range of temperature. That is the next point. High range. All of you got it? High range. High range of temperature. So some of you might argue, sir, Delhi also has a river, Yamuna river. Yeah. Yamuna river is there, but it is polluted water body. Allah. It is a grey water. Okay. Yamuna river, you can see Delhi and surrounding areas, say pollution and all. They have destroyed the poor river there. Such a beautiful river it is. When it comes from the Uttarakhand region, it is crystal clear water. When it enters UP, it becomes greyish color. Grey water. Grey water also has very high, it can absorb a lot of heat. Okay, it absorbs a lot of heat. So as a result, poor albedo. Grey waters also have poor albedo. So winter temperatures are very low. That's what I am trying to share here. Winter temperature in Delhi is very, very low, close to 0, 1, 2, like that. So air becomes cold. Cold air means, already I told you basics. Cold air, that you have to write now. So in winter, first we spoke about situation, how it is. Now we are talking about in winter what happens. Cold air, high pressure, correct? All of you can understand high pressure across North India. Across North India, high pressure across North India here, this belt. Correct. Plus, around Delhi, surrounded by agricultural land. Delhi is surrounded by agricultural states, UP, Punjab, Haryana. As a result, lot of stubble burning in winter. Stubble burning increases the pollution. Second, like diesel vehicles. Then crackers also I'll add. Crackers. Fourth, Diesel generators, diesel vehicles here only I've added. Okay, we can write industries also contribute a lot of pollutants. Okay, all this will cause a lot of severe pollution in Delhi. Thank you. See, they have given Hyderabad today temperature. They have given in page number 3. You can see. Okay, 28 maximum. Minimum temperature is 22 because we are in monsoon season, raining now. Okay, 28, 22. Okay. Here, page number 5. You can see the satellite image here. Remember, I was telling you we have satellites today. INSAT 3DR. I told you in the first class. We have satellites which give us real-time information. You can see page number 5. There is a satellite image. This satellite image was taken by INSAT 3DR satellite of ISRO. It was taken yesterday. You can see here 1845, 6:45. Yesterday evening, 6:45. You can see here. Since it is taken from the sky, this satellite is at the height of 36,000 kilometers approximately. It is a geostationary satellite. All of you understand? Geostationary satellite, upar 36,000 kilometers above India. So this satellite, notice this. When it takes the picture from that height, it can cover all the clouds also. Correct? As a result, you can see this. You can see the clouds as well. Now, based on this, we can say where it is going to rain. Okay. So we can notice that range of temperature for many cities they have given here. Visakhapatnam maximum 31, 26.5 minimum. Okay. So 31 minus 26 approximately 5 degrees is the range. Okay. See Delhi. This is yesterday's data. 36 highest, lowest 25, 11 degree. Visakhapatnam and Delhi you compare now. Visakhapatnam 5 degrees range. Delhi high 11 degree is the range. All of you understood this? Range of temperature you understand. Very high range means very high difference. You have to see this once. Satellite image and this. Remember we discussed pollution. We discussed pollution in urban areas, National Air Quality Index, that also they have given here. All the 10 major cities of India they have given. I showed you all how to check National Air Quality Index, that they have given. Please see this. Make it a point to read page 5 today itself. See this data, satellite data. Notice the map of India. All of you know the states. See the statistics. Temperature, maximum, minimum. Calculate the range. Okay. So Delhi has a very high range of temperature, annual range. What is annual range per year, over the year? Summer maximum, winter minimum I have taken. Coastal area, Visakhapatnam or Calcutta or Chennai, maximum 35, summer temperature, minimum 25. Because of the water body, because of the maritime influence. Okay. What did I mention? When the land heats up, water absorbs the heat, conduction takes place. When the land cools, the water returns the heat back, keeping the land warm always. That is a maritime influence from the water body. And there is evaporative cooling also. When there is excess heat, water evaporates, cooling the surface. That causes evaporative cooling effect to the city. That is required. That makes the city moderate temperature. Delhi doesn't have that advantage. Okay. So as a result, in winter we have severe pollution. Automobile pollution. Automobile side, diesel vehicles I have written mostly. Crackers also we have written. Stubble burning we have written. Industries we have written. Okay. So Delhi suffers from severe air pollution. So most of the exams they are asking questions like this. Applied topics. So all of you remember this air temperature we have discussed. Now check the atlas now. Go to page number weather data. India's weather data. Page number temperature. I am talking about January notice here. Cold air, high pressure. High, written dekho, high. January you देखो January. There is a map of India, 4 map they have given here, 34 or 30 page number. The top map you see. Next page. That one. All of you see the temperature graph. There are 4 maps. One is January, other one is April, other one is July, other one is October. First you see January. These are all thermal images. Okay, many of you don't have atlas. What to do now? You have to bring atlas. Correct. Geography is not over yet, and you have not become IAS yet. Till you clear, you keep the atlas. Don't sell the atlas now itself. World geography हो गया तो बेच देंगे. Don't do that. Okay, bring the atlas to the class. So notice January map. North India, notice the North Indian part. Cold air, high pressure. South India remains warmer because South India, Kerala, Tamil Nadu, close to equator Allah. It receives insolation from the sun. Okay, North India receives slant rays. South India receives almost vertical. As a result, tropical regions of India remains warm in winter also. North India is very cold. Notice North India, January. High pressure. They would have given something HIGH, high pressure. That word high is, that is entire North India is high pressure. You can see some lines also. Isobar given there. Line joining places of same pressure is called as isobar. Isobar. You notice isobar over North India. These lines. These are all isobar. Like this. 1018. Correct? 1018. There are high pressure here. Okay? Temperature and pressure also you can see. All of you are able to notice that? Isobar, 1018. Isobar. Line joining places of same pressure. So you can see there is an index also. For high temperature they have given some colors. Low temperature they have given one color. You can see that index. Sorry. Is this clear, friends? So that you should know how to see this map also. Learn that. Okay. Next, air temperature we have covered. Air pressure. Air pressure. When I say air, first word all of you know. Mixture of gases. Mixture of gases, dust and vapor. What is pressure? It is the weight of the overlying air. Okay. The weight exerted by the air column. Weight exerted by the air column on the Earth's surface. Air column on the Earth's surface. You will understand. Please write. Please write. Weight exerted by the air column is called as air pressure. We'll start with a very simple topic. Okay. I'll give you a simple example. In your room, most of you have this water drum. Pani ka drum hai. Where you get the water from, and there's a cap also on top, and there's a tap here. Correct? Tap bhi hai yahan pe. Tap. Many of you use this in your rooms to keep water. Have you noticed that? So just say there is a water here, almost full hai, pani pura hai. And notice this, there is a cap also on top. Okay. So now you notice many times you are there in the room and you turn on the tap and notice the water is not coming. There is water inside. Water is not coming. You will be wondering what is this? My room might have done something, might have stuck something, and you will be wondering. But what has happened there? That upper cap is too tight. So there is vacuum here. As a result, no air inside this side. So as a result, it's not coming out. You have to loosen the cap. As soon as you remove the cap there, upper part, the air goes in. Air exerts pressure. Water comes out. Air pressure. The weight of the air column on the surface causes the water to flow. You got it? Your pen, you're writing, ballpoint pen with a refill inside. The upper part of the refill is open. Have you noticed? You can remove the refill also. You can see the small dot is there on top and the air can go inside. Exert the pressure on the fluid there, ink, and ink comes out this side. You will write. Put something there. Put some paper or something, block it, seal it. After 1 minute, it will stop writing. whether you do like this or do like this, it will not work because the upper part is closed. You have sealed it. Why? The air can't exert its load on the fluid. So the fluid movement stops. You can check that. Many times it has happened, correct? The upper part cap is too tight. Air can't go inside. It stops writing. So air pressure exerts on all of us. Air exerts its load on all of us. And it exerts on Earth's surface also. So it is a weight exerted by the air column on the Earth's surface. Okay, I'll remove this. I don't need this now. So air pressure is measured using an instrument called barometer. Barometer. And unit is millibar. Okay, or Pascal. All of you might have heard of a person by the name, scientist by the name Pascal. Pascal is the name of a scientist. Pressure is measured using unit Pascal or millibar. Millibar. MILLI. Be careful, don't write minibar anta. Okay. Millibar hai. Let's say this is the Earth's surface. All of you notice this? This is a sea level. Sea level. Which is the first layer of the atmosphere? Troposphere. Troposphere is the first layer of the atmosphere. All of us here, please. This is tropopause. 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 This is the Earth's surface here. This is the troposphere we are talking about. Majority of the air molecules are in which layer? Troposphere. Majority of the gases, dust, vapor is in first layer. First layer. Gravity is where? Here on the surface. As we go up, gravity decreases. So air molecules also decrease as we go up. Here we have large number of molecules, gases, dust particles, vapor and all. Here. Because Earth's gravity is pulling it down. So gas molecules will be large quantity here on the surface. But as I go up, the gravity decreases, air density decreases. You can see. You can notice this. Air density decreases with height. So you have to know, when I am standing here, the gravity is acting downwards. So the entire air column exerts its load where? Here. Entire air column will exert on the surface like this. So this all the air molecules will be acting downwards. The weight of this entire air column will be acting downwards on a person standing here. So that is reason near the sea level, we have the entire load of the troposphere acting down. Entire load of the troposphere, gas molecules, dust, vapor acting downwards. As a result, air pressure experienced near the sea level is higher, nearly 1013 millibar. Near here. As I go up in the surface, let's say higher elevation if I travel. As I go upwards towards the Mount Everest, let's say this is Mount Everest. As I travel towards higher altitude, as I move towards higher altitude, what happens? So the elevation increases. As a result, the length of the air column, decreases. Length of the air column decreases. On top of the Mount Everest, only this much of air is acting on it. So weight of the air column on the Mount Everest is less compared to here. There will be very few molecules here. There will be few molecules here acting on it. As a result, the air pressure on Mount Everest is comparatively low compared to the sea level. So sea level the entire column of air is exerting its load. So high pressure here. As I move upwards, the height of the air column starts decreasing. On top of the Mount Everest, the pressure is around 330 millibar. That's it. There are very few air molecules. Air becomes very thin. As a result, no oxygen levels will be low. Nitrogen levels will be low here. Correct. Gases will be very, very low here on top of the Mount Everest. So air weight is low. So air pressure is low here. Okay. So air pressure on the sea level is higher because the entire column of air is exerting load. As we go higher, air pressure decreases. So this you will experience when you are traveling from sea level towards up, your ear gets blocked. Have you noticed? Whether you are traveling from high elevation to low to high, suddenly your ear gets blocked because of the changes in the pressure. For few minutes you will not be able to hear anything properly. Correct. So you will be wondering what happened to your ear. Suddenly you are not able to hear the other person. You will be doing like this. So if you swallow your saliva, it will pop up. So ear gets cleared. You will be able to hear that person. You got it? So that you notice. that is one thing. Suddenly, let's say you're in higher altitude here. Suddenly, I come to the coast. Today, because of high speed transportation, we can go to any place now. As I suddenly move towards the coast, what happens? Here, the pressure was less. Suddenly, the pressure increases on me. So that causes what? Bleeding, nose bleeding from many for many people. They've experienced that. Okay. So because of sudden increase in the air pressure. So that is the reason whenever we travel, we see the elevation also. Suddenly when we go to different places of different elevation, temperature changes, air pressure changes. Suddenly you fall sick the next day after the travel. Why? Because of change in the air pressure and air temperature. So that is the reason the first day of traveling you should rest. You should not do too much physical activity. Any physical activity, correct, it will be too much of stress for you. So your body will get sick on the first day. So as a result, you should know how when you travel from one place to another, elevation if it is same or not, how you are traveling. That also matters here. In planes, for example, let's say I am traveling from Hyderabad here. So the as soon as I board the plane, within the plane, what happens? It will be sealed. Allah. Windows are all sealed. Door is also sealed. So within the plane, they maintain cabin pressure. बोलते हैं उसको cabin pressure. So they maintain cabin pressure. Since we are all boarding from Hyderabad, same air pressure they have to maintain within the plane. Because our body will be acclimatized to this city first. You are boarding the plane from here. So they have to maintain the cabin pressure inside the plane, same as the Hyderabad city. What happens if they fluctuate? The people who are sitting inside, suddenly they'll get ear pain here. It will start hurting here. And many of them might get killed also. I'll tell you one of the recent incident. Indigo plane from Tirupati took off. Correct. So it was coming to Hyderabad. Let's say 15 minutes, first 15 minutes people started complaining there is no air, oxygen, we can't breathe. Air pressure also was decreasing. Everybody started shouting. They had acute ear pain. We got it. Another 15 minutes into the plane, then pilot decided we can't proceed further. He came back and landed back in Tirupati. Last month incident like this. Another plane took off from Mumbai, okay, to Jaipur. Same incident. So almost 3 people died in that incident. So by the time the plane came back and the people were taken to the hospital, almost 3 dead, and 7 of them were hospitalized because of sudden drop in cabin pressure. We call it as. Okay, so as a result, that is also very important here. What is air pressure? You know, weight of the overlying air on the Earth's surface, weight of the air column exerted on the Earth's surface. I'll show you this. Barometric pressure or air pressure. See here on the surface you can see a lot of molecules here. Correct. Most of the load is exerted downwards. It will be very high here. But as I go up, the entire air column start decreasing. Number of air molecules also less. As a result, as I go up, air pressure decreases. This is a column of air we are talking about. See here, Mount Everest and the sea level they have taken. So slowly as you go up, the air pressure tends to decrease. Okay, as you go higher. Air pressure tends to decrease as we go higher. Okay, please remember this. I'll take one more image. You notice this. On top of the mountain and the sea level, you take here. You can see more air molecules, dense air. Pressure also, the weight of the overlying air is also high. Weight of the air column is very high, acting downwards like this because of the gravity. So more weight is exerted by the air on the surface. Okay, because more air molecules. Here lesser air molecules. Okay, you can notice air pressure and density are lower at the higher altitude. Because of this, the column is shorter. So pressure is low. Here you can see. Clear? So simple physics you have to understand here. Air pressure. Next time you travel, you notice sudden changes in the altitude, how it affects you. Okay. This is the diagram I was trying to write on the board. You can write the one I have written or this one. Write fast. You can see here. the air column exerts higher load, whereas there the air column exerts lower load. Weight of the air column on the Earth's surface. See that happens. What happens is space may. I'll tell you. Especially when astronauts are in space outside the International Space Station and all. Correct. So any small crack on their suit, because let's say if you are regularly here, there is certain air pressure on you, and certain levels of oxygen you are getting. You are breathing properly here. But as you go higher, what happens? I say, especially around the International Space Station and all, if you're outside repairing something and all, what happens? Your suit, space suit, will help you to maintain that same pressure on you, plus same levels of oxygen is supplied to you. Correct. Suddenly, if there is a crack or some rupture, correct. What happens? That all that air starts escaping. Whatever pressure that was maintained within the suit, will start to escape, causing you to suddenly what the blood vessels will freeze, because outside temperature is very low, whereas the space suit is maintaining your body temperature at a temperature of 20 to 24 25. Surrounding temperature is very very low, so as a result any small rupture on the suit causes sudden drop in temperature, and the cold air goes in, causes your vessels to freeze. That causes the, I'll show you the space suit. So the space suit monitors pressure as well as oxygen levels. So that is very important. So that is, and many times you have seen that in the movie and all. So that is to be maintained properly. So all of you remember this, okay? The amount of moisture present in the air. Amount of moisture present in the air. Amount of moisture present in the air is called as humidity. Measured using hygrometer or sling psychrometer. Sling psychrometer or hygrometer is the instrument for measuring humidity. Unit is gram per cubic meter or percentage. Unit is gram per cubic meter. That means the weight of moisture in grams per cubic meter of air. All of you understand, cubic meter means volume we are taking. 1 cubic meter of air में 1 cubic meter of air के अंदर how much moisture is present in grams? The weight of moisture in grams per cubic meter of air. 1 cubic meter of air is this much. Inside 1 unit volume of air, what is the weight of the moisture? In grams. Grams. So gram per cubic meter is a unit. So humidity is nothing but the amount of moisture present in the air. How does the moisture come into our atmosphere? Remember I told you, evaporation. Right? Notice the first class notes, water cycle. Evaporation is the process from liquid state to vapor from the water bodies like lake, rivers, ocean, seas. Say, whenever the temperature increases, the water changes its state from liquid to vapor. That is called as evaporation. Correct? Normally what happens? Sunlight heats the surface. Water bodies we have on the surface. When the water bodies heat up, they will change the state from liquid to vapor. The minimum heat required to change the state from liquid to vapor is called as latent heat of vaporization. Latent of vaporization. As soon as they get that energy, they will change the state from liquid to vapor. Vapor. And that goes up. That is called as evaporation. Evaporation from leaves of the plants are called as transpiration. You know that. Correct. Then I told you sublimation from the ice directly solid to vapor. Then perspiration. Perspiration from our body. That when is sweat. Correct. When our body temperature increases, sweat comes on our body. There are 600 sweat glands, I told you, on our body. All the sweat comes on the surface, absorbs the body heat, evaporates, cooling our skin. So that is reason when the sweat evaporates, we feel nice, like cool. Suddenly our body temperature comes down. So perspiration is our body's mechanism to regulate its temperature. Okay. So please remember, these are the 4 processes which supply moisture to the atmosphere. So let's say you are living in the coastal area, you are living in close to the water bodies. During the day, what happens? The water evaporates. That is then the air becomes humid air, warm and humid. So humidity is the amount of moisture present in the air. First, 3 types we have. First one, absolute humidity, AH. Second, relative humidity, RH. Third one, specific humidity, SH. Absolute humidity, relative humidity, specific humidity. Absolute means total humidity of the air, total moisture present in the air. First you write down this one, I'll tell you one by one. Okay. Total moisture present in the air is absolute. Can I continue? First one, absolute humidity. Absolute humidity is the total moisture present in the air. Right? Absolute humidity, first one. Absolute humidity is the total moisture present in the air. Total moisture present in the air. That means how many grams of moisture is present in cubic meter of air. Means unit volume of air. Present in unit volume of air, or 1 cubic meter of air. How many grams of moisture is present in 1 cubic meter of air? It is measured in, absolute humidity is measured in grams per cubic meter. Per cubic meter of air, how much moisture is present in grams? Absolute humidity. Okay. Next is relative humidity. This you will understand. For now you have to wait. Relative humidity. Relative humidity is the amount of moisture present in the air please write is the amount of moisture present in the air. It is a, okay, one second. Relative humidity is the ratio. Please add this word, ratio of the amount of moisture present in the air to the total moisture holding capacity of the air, to the total moisture holding capacity of the air, Please try to understand this. The ratio of the amount of moisture present to the total moisture it can hold. I'll explain this, don't worry. It is a ratio of amount of moisture present in the air to the total moisture holding capacity of the air. So you'll understand this quickly. So all of you know warm air, cold air, 2 types of air we discussed today's class. I told you warm air expands. When the warm air expands, what happens? Intermolecular space increases. What is intermolecular? Let's say you're all sitting close to each other. If you all move apart, what happens? More space will be there in between. So when the warm air molecules expand, intermolecular space increases. So if there is evaporation, right, temperature ज़्यादा है. If there is evaporation from the water body, like lakes, rivers से evaporation होगा, so the warm air can hold moisture. ये देखो. I'm not saying warm air will be moist. I'm saying warm air can hold moisture because intermolecular space is high. Since the warm air expands, it can accommodate more moisture. Let's say you're all moving apart. So there is more space in between. So that you can accommodate another person there. Like that. So warm air expands and moisture holding capacity increases. Warm air has higher moisture holding capacity. Moisture holding capacity of warm air is higher. Why? Because warm air molecules expand. Steam. Steam is what? That only. Hot, moist it is. Steam from the pressure cooker, have you noticed? It will be very hot also. It is a hot air with moisture. Okay. Because when the warm air expands, it can accommodate that moisture. So moisture holding capacity is high. You add this point please. Whereas the cold air molecules contract. So intermolecular space decreases. Space between, let's say you get closer to each other, what happens? Space in between is less. So moisture holding capacity decreases. Moisture holding capacity of cold air is low. Moisture holding capacity. I am not saying moisture is not there in cold air. I am saying moisture holding capacity is low. That is the reason cold air tends to be dry. How many of you agree? Cold air tends to be drier. Warm air tends to be humid, moist. Try to understand this. Now you will understand why coastal areas become humid. Because there is water body next. It is warm also. Warm air expands. Water evaporating from the ocean gets in between the air molecules. So air molecules will be warm, moist. Coastal areas will be humid because of this. Because coastal area, it will be hot. Air expand there. Evaporation also taking place from the surrounding water body. So it can accommodate the moisture and becomes humid. So all coastal areas tends to be a bit humid. Okay. Dry, cold, winter mein, cold molecules contract. Become drier. So moisture will be less. So cold air tends to be dry. That is then cold air, winter mein, your skin cracks, your lips crack. Have you noticed? You apply what? Moisturizer, lip guard and all you apply to moisten it. All of you got the concept now? Why in winter we all try to apply moisturizer to our skin? Because skin becomes dry, because air is dry. You got it? So you understand this. Warm air expands, so it can accommodate more moisture if there is evaporation process. Okay, some of you might now say, sir, in Rajasthan it is so hot. In Rajasthan it is so hot. Sahara desert is so hot. But why it is not humid then? Because there is no water body. Water bodies nahi hai wahan pe. Lakes and rivers are less for evaporation to take place. So hot dry rahega. Rajasthan will be hot dry. Sahara will be hot dry. You got it? Coastal areas will be hot, humid. Humid, moist rahega. So now coming back to this, where is that? Relative humidity. This relative humidity is the ratio of moisture present to the holding capacity. Now you will understand this. All of you see here. Quickly we will finish this. Let's say we have a air parcel now. Air parcel here outside. At the temperature around 26 degrees Celsius now. Outside temperature. So it can hold, let's say, warm air. Warm air can hold up to 100 grams. I am saying warm air expands, it can hold a lot of moisture. So warm air can hold 100 grams per cubic meter of air. But as of now, it can hold this much. Capacity is this much. Now, because of evaporation and all, the humidity present here in Hyderabad is around, let's say, 70. 70 grams per cubic meter is there. So notice the ratio now. The moisture present in the air to the total moisture holding capacity. What is the capacity? 100. Let's say we have 100 chairs in the class. All the 100 chairs are full? No. Only 70 is full now. Like that. What is the capacity? 100. The class capacity. But there are 70 now students. 70 students now. Like that. So moisture present to the moisture holding capacity. Into 100. Relative humidity is always measured in percentage. Relative humidity is always measured in percentage. All of you notice this. This is now. Now, by afternoon it becomes hot. Again, the air expands. It can accommodate more moisture from the surrounding water body, there will be more evaporation. So moisture content will increase. It will become 75, let's say. This also will change, this also will change. 75 hoga. This also becomes 75%. This remains same because capacity remains same. After some time, some students will come and sit, so it will become 75. Strength. Like that, I am saying. Now what happens is air parcel is warm, moist. Warm air always goes up. Warm air always goes up. When the air goes up, temperature decreases a lapse rate at the rate of 6.5 degrees Celsius. For every kilometer, the air starts cooling. Correct. It will not remain 26 only. As the air goes up, temperature starts decreasing at the rate of 6.5 degrees Celsius for every kilometer. So as a result, when the air goes up, the air parcel cools. When the air parcel cools, it contracts. When the air parcel contracts, see, notice this. 75 will be same. It will become 90. Because when the air molecules contract, the air parcel also contracts. When the air parcel contracts, moisture holding capacity will not be remains same. Because cold air molecules it can hold less moisture. Cold air can hold less moisture. So parcel is decreasing, notice this. Into 100, you can do this. 75 by 90 into 100. So again the air parcel goes up. Again the entire air parcel contracts. At one height, the moisture present will be same as the moisture holding capacity of the air. Because as the air parcel goes up, it contracts. The moisture holding capacity comes down. The numerator remains same. Moisture remains same. What is changing? Moisture holding capacity is changing. Because here it is warm air. As it goes up, contracts. Please remember this. Moisture present is same as the moisture holding capacity. Into 100 now you do. Relative humidity is 100% now. What is the relative humidity? 100%. That means air is completely moist. All of you please see this. We'll finish this. Air is completely moist. Air is saturated anta. Air is saturated with water, with moisture. It's like a steam. It looks like a steam. As a result, the condensation begins. When relative humidity becomes 100%, air is completely saturated with moisture. Then the moisture starts condensing on the dust particles, forming clouds. So for clouds to form, what is the first condition? Relative humidity should become 100%. That is the reason it takes time for the clouds to form. By afternoon, the clouds will form. Now, it will not form. Ground heats up, air heats up, expands, accommodates the moisture, evaporation, say the air parcel goes up 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock. As a result, the air parcel contracts. So at one point, the moisture present will be same as the moisture holding capacity. So as a result, it becomes 100%. Then the condensation takes place on the dust particle. Remember I told you moisture condenses on the dust particles, forming clouds. Here there will be a lot of dust particles here. So the moisture condenses on them, forming clouds. You got it? The level at which the condensation takes place is called as level of condensation. Level of condensation, LOC. That is the reason all clouds have a common base. Above that level only the clouds will form. If you notice, the bottom of the clouds will have flat base. You notice, upper part they look like this, lower part will be always flat. That indicates the level of condensation. The temperature at which the condensation begins is called as dew point temperature. Dew point temperature. Very interesting concept. Why are we using mathematics to understand this? Because water vapor is not visible. Water vapor that is going up, you can see water in solid form, liquid form, you can see water in liquid form, you can see water in solid form, you can see in gaseous form, you can't, because it's in vapor form. So when it goes up, we are trying to use mathematics to show that how the moisture is going up. How much is the maximum holding capacity? 100. Moisture present is 75. Here air is 75% moist, 25% dry. As you go up, what happens? Air molecules contract. So holding capacity decreases. 95, 90, 85, 75. At one point of time, moisture present will be same as the moisture holding capacity. Then air is completely saturated. Relative humidity is 100%. Then condensation will begin, forming clouds. The level of condensation is the level at which the condensation takes place in the atmosphere. And the temperature at which the condensation takes place is called as dew point temperature. Tomorrow also I'll repeat this. Okay. We'll stop. This you can copy. Again tomorrow I'll repeat this. Humidity, clouds tomorrow we'll discuss, and rainfall, precipitation. So relative humidity is the ratio of moisture present to the moisture holding capacity. Let's say I have conducted the exam for 100 marks and your score is 75, like that. So you have scored 75 marks, 25 have not. Please don't miss the class tomorrow. Again, I am telling you all. Again, what happens tomorrow? You'll miss again. Day after tomorrow, it will be a continuation. Today I have stopped here, right? Tomorrow I am going to continue from same topic. I am not going to do new topic. The same topic will continue. And all the topics are going in order. If you notice, air temperature, pressure, humidity, clouds, in that order only we have to study. If I change the order, nobody will understand. Okay, we'll stop now. Thank you. Revise, please revise and come. Okay. Also notice, very interesting. Now we are in rainy season, right? Rainy season, what happens? It is raining all the time, means what? Humidity will be there. So that is the reason when you wash your clothes and put it to dry, it won't dry fast. Have you noticed? You will be wondering, clothes are not drying, and you will be complaining. Because outside when you put, it's already raining. So you have to put somewhere which is very shade. And also there is, sun is not coming out, you notice. Cloudy weather we have, raining for the last 1 week. So humid conditions hai. So as a result, most of the clothes won't dry because already there is moisture in the air. Clothes won't dry. For clothes to dry faster, it should be dry air. Warm dry air hona chahiye. Quickly it will dry. Earlier, remember last week and all, you wash something and put it outside, by the time you turn it will be dry. Hyderabad weather. Half an hour it is required. Humidity is the amount of moisture present in the air. How much moisture is present? Okay. Sometimes you would have noticed air is dry. Sometimes you would see air is moist or humid. Correct? Have you noticed that? Have you experienced this? Sometimes the air is moist, sometimes air is dry. Okay. So air can have large amount of moisture sometimes very less. The amount of moisture present in the air is called as humidity. Simple as that. It is measured using instrument called hygrometer. Okay, we have discussed that in yesterday's class. It is measured using instrument called hygrometer or sling psychrometer. Why am I covering instruments also? Because one question is asked in the state service exam. Small exams like excise, police, correct, all that exams, they are asking one question on the instruments for measuring different elements of weather and climate. As a result, one question will get easily. Okay. So unit is gram per cubic meter. How much grams of moisture is present in 1 cubic meter of air, or is measured in percentage. Two units we use for measuring absolute humidity and also relative humidity. We use different units. Okay, 3 types of humidity I told you: absolute humidity, relative humidity, specific humidity. Okay, EH, RH, SH. How does moisture come into our atmosphere? Also we have discussed. Moisture enters our atmosphere in the form of vapor through evaporation. Evaporation of water from lakes, rivers, oceans, seas. Then transpiration from the leaves. That is the second source of moisture. Every day, I am talking about every day, the moisture enters our atmosphere through evaporation, transpiration process, sublimation process from the ice. Wherever there is volcano erupting, correct, in Rockies, Andes, Antarctica, we have volcanoes there. Directly the magma comes in contact with ice. Thousands of degrees of heat. What happens to the ice? Sublimates. Solid directly to vapor. That is sublimation. Last one is perspiration from our body. We also contribute small amount of moisture. That sweat that comes on our body evaporates, absorbing the body heat. When the sweat evaporates, our skin temperature comes down. Surface temperature of the body comes down. Perspiration is our body's mechanism to regulate heat. Just like how we regulate heat, Earth also regulates heat through these 3 processes. Earth also tries to cool every day. Whenever the insolation hits the surface, evaporation is a process that cools the Earth's surface. every day Earth tries to balance the heat it receives through the process of evaporation, transpiration and sublimation. You got it? Just like how our body reacts to heat, Earth also tries to react to heat. Okay, that is the reason more water bodies, more evaporation, cooler the surface. Okay, so that is the reason we should maintain a lot of water bodies, protect lakes, rivers. Okay, so Udaipur, you might have heard of Udaipur. In Udaipur, what happens? It is so hot normally. Everybody thinks Udaipur is Rajasthan, it will be very hot. It's almost like you notice South Rajasthan hai, Tropic of Cancer is passing there only, close to Udaipur. Udaipur is just north of Tropic of Cancer. Check, please check in the atlas. But if you go there, you will be feeling like so many lakes are there. Correct. There are so many small palaces across, so many small lakes. It's called as wetland city today. Udaipur is called as wetland city. So many lakes, and Udaipur, when they built, they made a lot of ponds also. Sandstone, beautiful structures they have created. So what happens? Always there is water. So because of the heat, what happens? The water evaporates, cooling the entire city. So as a result, so that is the best example for us. More the cities, more the lakes, cooler the cities tend to be. So today we are facing urban heat. Remember yesterday's class we were discussing urban heat island. We have discussed urban heat island concept. We have discussed urban flood. We have discussed. So for solution for both is lakes. More lakes you protect, lesser the heat. And also when the rain comes, all the water goes to the lake. Flood also not there. So we have a solution. Nature has a lot of solution for us. But what we are doing is we are destroying lakes, encroaching lakes. So as a result, we are facing most of the problem. Okay. So please remember this. So all of you locate Udaipur. It's called as a wetland city. Udaipur, Rajasthan, southern Rajasthan. Tropic of Cancer also notice, very close to it. You can know, okay, June, May, sun rays will be vertical over the city. Got it? So they designed in such a way, so water evaporates. Okay. Even Bhopal also has large lake, Boj Lake for example, big lake they have. Bhopal is also almost below Tropic of Cancer, you notice? Just below the Tropic of Cancer. Okay. Just around 60 kilometers from there is Tropic of Cancer from Bhopal. So as a result, so there also big lakes they have maintained. So it's cool most of the time. Okay. So try to understand this. So we were discussing absolute and relative humidity in the yesterday's class. Application wise, I was telling you something. Let's say this is the Earth's surface, and on the Earth's surface, let's say we have a air parcel. Let's say here, air parcel. Now the temperature, let's say will take 25 degrees Celsius. Let's say the warm air can hold more moisture. I told you warm air expands. As a result, it can accommodate more moisture. So we have nearly, it can hold up to 100 grams. Let's say per cubic meter of air, it can hold 100 grams. But as of now, the moisture present here is, let's say 70. 70 is the moisture present now. 70 gram per cubic meter. Into 100 if I do, I'll get 70%. Humidity 70%. Relative humidity 70. That means moisture present to the total moisture holding capacity. Total moisture holding capacity is 100. So remember this. So as of now, the air is 70% moist, 30% dry. It means, this means 70% moist air, moisture is there. 30% air is dry. Okay. So this air parcel will go up now slowly. Let's say the air parcel will go up. As we go up, what happens? Temperature decreases. When the temperature decreases, what happens to the air parcel? Air parcel will cool. So it will contract. Warm air expands. Cold air contracts. Remember. So the air parcel is now, you can notice, slowly it is contracting. So moisture present is 70. But since the air parcel is contracting, the moisture holding capacity decreases to 90 now. Warm air expands. Cold air contracts. So moisture holding capacity decreases. Now further it goes up. So here 70 by 80 here. See, the air parcel is contracting because as the air goes up in the atmosphere, because of lapse rate 6.5 degrees Celsius for every kilometer, the temperature drops. As a result, air parcel starts contracting. At one height, at some level, you see here, all of you see here. So the moisture present is same as the moisture holding capacity. It can hold how much? 70. What is the moisture present? 70. Into 100 you do now. How much? 100%. The relative humidity is 100%. That means air is completely saturated. The air is full of moisture. Air is full of moisture like this. Air is full of moisture. Air is saturated now. So when the air is completely saturated, we call it as air is saturated with moisture. So as a result, all the moisture starts condensing on dust particle. Remember I told you a lot of dust particles in the sky from the smoke soot, pollens. Correct, we have a lot of dust particles in the atmosphere. So the moisture will condense on it. All the moisture will condense on it like this. All the moisture will condense on the cloud. This is called as condensation. When the moisture sits on the dust particle, okay, that process, moisture cools and condenses on the dust particle, forming clouds. So this is called as clouds. Okay, clouds. Okay. So clouds, how they form? First, I'll tell you here. First, what is happening? One dust particle was there. All of you notice one dust particle was there. I'll take some dust particles, and water vapor first condensed on it like this. One. Again, another moisture condensed on it like this. Another moisture here. Another moisture here. Starts condensing on the dust particle. Slowly they will collide. One drop, water drop will collide with another water drop. So they will collide and join. Correct? That is called as collision. Collision. When they join, combine, coalescence. See the spelling. Collision, when they collide and they join and become one drop. Means they grow in size like this. Small drops join. So like this, collision coalescence theory, it's called as collision coalescence theory, is the first theory which explains the formation of clouds. Please remember this. Collision coalescence theory. So like this, slowly the water drops will join each other like this and become larger in size slowly. The level at which this takes place is called as level of condensation. Level of condensation. Level of condensation. The temperature at which it takes place, plus or minus, correct? Here the temperature can be in minus also, -2, -3, -4 भी हो सकता है, plus भी हो सकता है. So temperature at which this takes place is called as dew point temperature. Dew point temperature. If the dew point temperature is plus, water drops is there here, water drops. If the dew point temperature is minus, ice crystals will be there in the clouds. So clouds are floating mass of water droplets or ice crystals. So write a definition now. What are clouds? Clouds are floating mass. Yesterday's class I couldn't complete this topic because yesterday almost it was time 10:30. So I stopped here. So I am continuing now. And remember, I explained it again so that you shouldn't have doubt. I didn't skip this topic. I have repeated this. Okay? Clear? This concept is clear? The clouds are floating mass of water droplets or ice crystals or ice crystals. Take your time now, write this diagram, complete this. What is level of condensation? The level at which condensation takes place. Simple. Dew point temperature is the temperature at which condensation begins in the atmosphere. Shall I continue? Dew point temperature is very important. That's what the topic is now. Now from humidity I am explaining clouds. How clouds are formed anta. Okay. So first we had a air parcel which contained 70 grams, but it can hold up to 100. But as of now evaporation had taken place and only that much was the moisture. That warm air is light, so it goes up. When the warm air goes up, it starts cooling as it goes up in the atmosphere, so it contracts. So moisture holding capacity of cold air is less, so it starts contracting. When it gets smaller, you notice the moisture holding capacity becomes 90, 80, 70. At one point where exactly in the some height, the moisture holding capacity becomes same as the moisture present. Then the air is saturated. 100% relative humidity. Then the condensation starts. The first process is this. Where the small water droplets join each other and become a mass, slowly accumulate and become a mass. So it's called as collision coalescence theory. First theory. That explains the formation of clouds. Especially in tropical regions, this is the case. We call it as warm clouds. This first case we are discussing, this is the case in most of the tropical regions. Tropical regions में we get to see this. Warm clouds बोलते हैं इसको. Tropical regions में most of the clouds are formed like this. We have noticed one more process. Second process. All of you notice. When the dew point temperature is very low, in minus, all of you listen to this please. When the dew point temperature is very low, what happens? Around the dust particle there will be ice crystal. Ice crystal रहेगा, ice crystal. Around the dust particle, what happens? Ice crystals are formed. Water will freeze above the ice, above the dust particle, water will freeze, forming ice crystals. Ice crystals are formed. These ice crystals, correct, are very low in temperature. Temperature will be very, very low. We call it as super cooled ice crystal. Super cooled ice crystals. Super cooled ice crystals बोलते हैं इसको, because the temperature is in minus 20 like that in the sky. So as a result, super cooled ice crystals are formed. So now these will be floating. Next, when the water vapor goes up, like this water vapor comes in contact with the super cooled ice crystal. When the water vapor comes in contact with the super cooled ice crystal, what happens? This water will freeze over it. This water molecule, because it's coming in contact with cold surface, it will condense, forming extra layer of ice around it. Like this, keeps growing like this. The super cooled ice crystal grows in size. That is the reason hail is formed. Hail, remember hail? Ice cubes fall. Sometimes, many of you might have experienced that. Ice crystals fall sometimes during the rain. This is formed here like this. Super cooled ice crystals will form first within the cloud, and suddenly the moisture going up will come in contact with the cold surface. Suddenly it will freeze, forming an extra layer of ice. It starts growing like this. It grows. So moisture keeps coming up through evaporation. It keeps coming up. That moisture comes in contact, so it will freeze over it, forming an extra layer of ice. So this happens in huge clouds like cumulonimbus clouds. I'll explain that cloud later. For now, you remember a huge cloud called cumulonimbus clouds में we have a large number of hail particles like this. Okay, so this happens in this cloud, cumulonimbus cloud. Cumulonimbus clouds have this. Okay, or in temperate areas, this is very common. This is very common in temperate regions. Small ice crystals and hail keeps forming. In our case, tropical case, this cloud, cumulonimbus clouds के अंदर form होगा ऐसा. So super cooled ice crystal theory बोलते हैं इसको. Super cooled ice crystal theory. So this is simple process where first ice crystal is formed because of very low dew point temperature. The next vapor goes up, comes in contact with it, forming a concentric layers of ice. Okay, I'll show you this first because I want you to see this. Can you see this? This is a cross section of the hailstone. When the hail particles come and like fall on the earth's surface, some of them get shattered because of the velocity at which it's falling is very high. So as a result, they break. So that is the reason many of you can't pick it up and see how it looks. But what if it falls on the soft surface like tarpal and all? So we can go and collect and we can see this. ये देखो, ये है concentric ice crystal, first one in the center. Super cooled ice crystal in the center and all the other concentric layers of ice around it. Hope you notice this. Okay. So like this both there, you can see. See this? Concentric layers, you know, you can see like onion. Layers of onion, you can see. Okay. If you want, you can just type this. Hailstone cross section, you'll get this. So like this, we have ice crystals formed inside the cloud. This will also comes down. When it comes down, obviously when it comes down, it starts melting, and sometimes it will melt completely, becomes water drop. or it will fall as ice, depending upon the surface temperature here. Okay, so many times the ice will fall directly, sometimes it will melt. So most of the water drops have 2 mm to 6 mm size, water drop size, 2 mm to 6 mm, or 0.5 to, it will range to 6 mm tak. Okay, so this will fall. So this process was first explained by scientist Bergeron, Wegener. Remember Alfred Wegener? Alfred Wegener was a climatologist. Okay, Feinstein process. Bergeron-Wegener-Feinstein process. It is called a second theory. These two theories we explain in geography optionals. But UPSC Prelims also they asked. Earlier we were discussing this process where? In the optional geography classes. Because it was important for optional students. Once Prelims they asked. So that means you have to discuss in Prelims also now. So what are the two theories that explain the formation of clouds? One is the simple process that takes place, collision coalescence theory. What is collision means? To collide. Coalescence means to combine, to join. See the word coalescence. Coalesce means to combine. Collision coalescence. Okay. There was a scientist by the name Mason, George and Mason. So they gave this. Not important, but you just remember this. Cumulonimbus. Cumulo means fluffy, large fluffy cloud. Nimbus means rain bearing cloud. So super cooled ice crystal theory, and other one is collision coalescence theory. These are the two theories that explain the formation of clouds. Can I clear the board, or can I go to the next page? Right first. Hope all of you know why we use these numbers to explain this process, because water vapor is not visible to us as it goes up. Correct? Vapor is gaseous form. So I am representing the moisture in form of numbers. Okay, maths helps us to do that. Correct? Whatever something that is not visible to us, how will you explain? We use maths. Okay, that's where maths come into picture. Because next I have to explain types of clouds and all. There I need this concept, how the clouds are formed. So that quickly I can finish that topic. Otherwise we will keep doing the same topic again and again. So this is clear. Now imagine the same process is happening where, like in this atmosphere. This happens in summer. On any hot day, summer outside, the water vapor goes up like this, air parcel goes up, the clouds form in the sky. So this I'll write an arrow mark saying summer months, or wherever it is hot, on a hot day, that side. Okay. Now I'm going to modify this diagram. All of you see here. Let's say in winter, we are in winter now. Summer case is over. Let's say we have in winter. In winter what happens? Winter nights are very cold. Winter days are short, nights are long. Correct. Days are short, nights are long, and nights are very cold. Cold nights. Correct. Cold, long nights we have in winter. Now, November, December, January, February is winter for us. So this air parcel don't go up now because the days are short. As a result, this air parcel will remain here because it doesn't get sufficient warmth to go up. As a result, this air parcel remains on the surface. Please, all of you see the board, please. Okay. All eyes on the board. This air parcel will start cooling now after sunset. Correct. 6 p.m. let's say. Then 7, 8, 9. It starts cooling here. So when the air cools here, it contracts. It becomes 70 by 90. Correct. 10 o'clock in the night, 70 by 80. 12 o'clock in the night, it becomes 70 by 70. The moisture present at night, moisture holding capacity and moisture present is same. What is the relative humidity now? 100%. 100% is the relative humidity, RH. Air is saturated now. Air is saturated 100% now. The same process that is happening in the sky will happen on the ground at night. So somewhere in midnight, what happens? This air is completely saturated, right? Will condense on the ground itself. On the ground means road ke upar, farms ke upar. There are dust particles there already. In the air we have dust. All the moisture will condense on the dust in the lower atmosphere, forming fog. This is how fog is formed. So that is in winter, fog is formed. Very interesting, correct? If the condensation takes place in the sky, clouds. If the same process condensation takes place on the ground, fog. That's it. That is then in winter, as soon as it becomes evening, night 8, 9, 10, 11, fog starts forming. Fog starts forming on the ground. If you are in Delhi, you will know what I am saying. Like entire northern Indian belt, night around 10, 11 itself, the fog appears. It will remain on the surface till morning, next day morning, till the sun comes out. So fog is condensation of moisture on the ground. Cloud is condensation of moisture in the sky. That's the difference. All of you got it? Winter nights, why we have fog? This is the reason. I'll clear this. I don't need this. Can I clear this name also? I'll clear this. Now I can explain this part. Fog. All of you know now how the fog is formed. Fog is formed. On the ground, already we have industrial smoke, automobile smoke, correct? Automobile smoke, industrial smoke, pollution from the crackers, all that already there. Stubble burning, people burn a lot of husk around Delhi, in North India. All that will mix and become smog. Smoke plus fog, smog. So it contains more carbon monoxide. Smog is very dangerous because it contains carbon monoxide, oxides of sulfur, oxides of nitrogen, okay, PM10, PM2.5. All these are very high in smog. As a result, very dangerous, causes a lot of accidents, breathing discomfort, okay. So that is the reason smog is dangerous. Entire North India, even Hyderabad also we have fog in winter. November, December, you have seen peak winter May. We have fog early in the morning in the surrounding areas and all. Many of you would have noticed. Fog appears somewhere in the midnight till next day. 10, 11, it disappears because sun comes out. As a result, all the fog disappears. Then again next night, same. The moisture in the ground level condenses on the dust, forming fog. There are a lot of dust in the air here, so it will condense. So if you are traveling to any hilly areas and all during rainy season, notice that during rainy season the wind goes like this, wind, moisture laden wind. What happens when the wind comes? It goes up over the mountain, correct? All of you notice this. The wind blowing will move up over the mountain slope because of the orographic barrier. All the moisture goes up, condenses. As it cools, because as we go up over the mountain slope, temperature decreases. As you go up over the mountains, what happens? The temperature starts decreasing. All the moisture starts condensing there itself. Mountains, tall mountains with steep slope and all the moisture condenses here only on the surface. If the temperature is very low, it will freeze also, forming small ice crystals. So all the moisture will condense here, forming mist on the slope. Mist reduces the visibility further. Mist is very dense, so you can't see anything at all. Let's say you are going in a plane. You know YSR Reddy, helicopter crash in Nalamala range. It happened during monsoon only, somewhere August only, I think, August month. Okay, August September में हुआ है incident. Because what, monsoon season में there is a lot of wind going up over the mountain slopes. Moisture condenses to form mist. Accidents are very common. You remember our Bipin Singh Rawat, Chief of Staff, correct, in Wellington. His wife and his colleagues were there. So all of them were involved in a air crash. So like that, mist is very dense. Mist can cause a lot of air accidents, flight accidents. Okay, so mist reduces the visibility further. Clear? Mist. What is mist? Condensation of moisture on the mountain slope. If the condensation takes place on the ground, fog. If the condensation takes place on the mountain slope, mist. But today the words are used interchangeably. Whenever the fog is very dense, thick, people use word mist. Okay. Fog is less than 1 kilometer visibility. Mist is less than 1 meter. Okay, remember this. Typically what we use, less than 1 meter visibility hai to we use the word mist. Agar you can't see anything, correct, even for 1 meter also you can't see anything, then we say mist, very dense. Up to 1 kilometer you are able to see, but visibility is less than 1 kilometer. Normally when you are standing on a flat surface, you can see up to almost like 1.5 kilometers on a flat surface. Means not clearly, but your sight can reach up to that. But if there is fog in the middle, less than 1 kilometer, visibility comes less than 1 kilometer. This causes a lot of flight accidents. Many times like planes come, they can't land, so they get diverted to other airports. Okay. So very dense condition mein smog and fog causes flight delays. Flight delays also, because pilot will not be able to see the runway. So that also is a problem. Okay. What is mist? What is fog? All of you know. So normally mist is formed on the mountain slope. First point. Okay, visibility is less than 1 meter. Fog is on the ground. Visibility is less than 1 kilometer. But whenever the fog is very dense and visibility is very low, then we also use the word mist. So be careful. So in winter it is very cold. Air temperature is very low. Okay. So the moisture present, when it comes in contact with cold surface is what? Stone, leaves, correct, the gate, metal gate, bike seat, correct. The moisture comes in contact with the cold surface and condenses on it, forming small drops of water. Have you noticed? Dew. That is called as dew. Next word is dew. Dew is condensation of moisture on cold surface. Have you noticed this? Dew on leaves. Small drops of water form on the leaves. That is dew. On gate, metal gate, bike seat also you would have seen. You would notice small drops in a pattern. They'll all sit on a pattern. You'll be wondering who did this, Santa. It's an art by itself. The moisture condensing on it. Okay, dew. Sometimes the temperature is so low, air temperature, all the moisture freezes, becomes frost. If the moisture condenses in liquid form, dew. If the moisture condenses and freezes, solid form mein, frost. Moisture condensing on cold surface is dew. It appears small droplet, liquid form. If the same moisture freezes because of very low temperature, it is called as frost. F-R-O-S-T. See the word frost. F-R-O-S-T. I'll repeat again. If the moisture condenses on cold surface, it is dew. If it freezes over the cold surface, it is called as frost. So many of you would have noticed nursery or a greenhouse around the city. Around Hyderabad there are so many polyhouse. Greenhouse. Why do they have greenhouse? Because small plants are kept inside the greenhouse. Because early morning temperatures may frost forms and many of the plants die. You can see xylem tissues carry water, correct? Plants may xylem tissues carry water. So when the temperature drops, what happens? So the water freezes inside the xylem tissues, causing it to freeze. Damages the tissue. You are able to understand? Damages the xylem tissue. That is the reason small plants are always kept inside the greenhouse, in the polyhouse. It is grown in warmth, humid condition. So once it grows, they plant it outside. So that is the reason we need greenhouses, polyhouses to grow certain crops. And also the polyhouse, greenhouse also protects the plant from insects also, pests also. Okay, so remember this. So most of the plants are kept inside the polyhouse, greenhouse to protect from frostbite, especially early in the morning. You might have seen flowers and all we are growing now. Rose, tulips, correct, we grow and we export to different countries. Okay, that itself is a big business. Floriculture. Floriculture. If you visit some of the floricultures around Hyderabad, Bangalore and all, you will be shocked. They run it like an industry. Where there is a weather station also. They have their own weather station. So you don't have to go inside and do anything. Everything is monitored digitally. Temperature, humidity. If humidity is less, they'll spray water from the sprinklers say. So everything is done nowadays like that. It is automated now. Okay. Number of labors are very less. Okay. So understand this. So many words. First is cloud. That is clear. Fog. Smog. Smog is a pollutant. Fog is condensation of moisture. If it mixes with smoke, becomes smog. Then mist. On top of the mountain slopes, we have mist. Then frost and dew. Too many words. Clear? Try to remember this. Okay, when to use what? Sometimes you are taking a cold shower or a hot water shower. Let's say we'll talk about a hot water shower first. When you pour hot water, what happens? Hot water, when it comes down, it has a lot of moisture. That there will be entire washroom will be full of moisture. Moisture comes in contact with the mirror. Mirror is a cold surface in the bathroom. Correct? Mirror, all of you know, cold surface. So moisture sits on the cold surface. Suddenly, entire mirror will be fogged. Have you noticed? You'll be looking at your face. Nothing can see. You have to wipe, correct, or put water on it. So that moisture condensing on cold surface, you notice. Or you're driving on a rainy day. You're driving a car in a rainy day, so it is raining outside. So moisture increases. Correct. Humidity increases. So the moisture start depositing from inside the glass. Notice that. Correct. So you will not be able to see the glass. Outside there is wiper blade like this. Inside the fog develops on the glass. If you turn on the AC, it will go. Correct. But earlier we didn't have the AC and all. Remember, you are driving, the other person sitting on the left. He used to have a cloth and he keeps wiping the glass. Correct. All that we have seen when we were like driving on a rainy day. So that is how the moisture comes in contact with cold surface and deposits on the glass. So observe this next time. Or sometimes people with glasses will understand what I am saying. People with glasses, when we pour hot something, milk or glass inside a glass, the moisture that rises fogs our glass. We will be like doing like this. Correct. We will not be able to see that clearly. Correct. So because moisture comes in contact with the cold surface, like watch, sometimes the water goes inside and deposits. Correct. You might have seen that. Or on the glass, we have that very commonly. So remember this, okay? Moisture, that is when you can notice that moisture. Otherwise, you can't see water vapor. You can feel it, but you can't see. So remember this. Smog, they'll ask. What does smog contain? They'll ask. Smog contains PM10, PM2.5, nitrogen dioxide, sulfur dioxide, and carbon monoxide. Please remember this, okay? So we have discussed the humidity and various aspects of humidity we have discussed here. How the clouds are formed. Next heading, types of clouds. Types of clouds. Oh, 1 second. Let me add one more topic. In that only you can write. Heading if you have written, no problem. I'll tell you one more aspect now. In urban areas, what is happening? Let's say there is a lot of nitrogen compounds in the air. Nitrogen compounds is NOx. Nitrous oxide, nitrogen dioxide. Okay. Like this I have written. Plus we have ozone also. Ground level also there is ozone. Remember I told you bad ozone. Good ozone, bad ozone. Good ozone is in stratosphere. Bad ozone is here outside. So bad ozone is formed in the atmosphere, lower atmosphere as well. Nitrogen compounds we have. Plus we have let's say unburnt hydrocarbons from the automobiles. Unburnt hydrocarbons from the diesel vehicles, especially diesel. Okay, from diesel vehicles, unburnt hydrocarbon comes out. Diesel engines are not efficient because diesel doesn't burn completely inside the combustion chamber. So a lot of unburnt hydrocarbon comes out. Okay, carbon elements, hydrocarbon comes out. Petrol and CNG are better. CNG burns completely, so less waste. Petrol also burns completely, less waste. But diesel, inefficient fuel. It doesn't burn completely, so a lot of unburned hydrocarbons comes out of the exhaust. So it is a main pollutant in the urban areas. I am talking about urban. In urban air environment, we have lot of industries, say lot of pollutants are there, and that too during the day. During the day means there is sunlight. All of these chemicals here will react in the presence of sunlight. In the presence of sunlight, they will react. They will become C2H3NO5. This is called as peroxyacetyl nitrite. Any chemistry students in the class? BSc chemistry. Peroxyacetyl nitrite. You don't have to remember this. I am just telling you. You don't have to remember this and all. Just remember PAN, peroxyacetyl nitrite. These are primary pollutants which are created by us from the source. When they react in the atmosphere, become secondary pollutant. Understand? All those pollutants directly released by us are primary pollutants. Primary pollutants. Once they react in the atmosphere, these primary pollutants react with each other in the atmosphere. They become secondary pollutant. Acid rain is a secondary pollutant because we are releasing what? Sulfur dioxide, nitrogen dioxide. It reacts with water, becomes sulfuric acid, nitric acid. It is a reaction taking place in our atmosphere, so it is a secondary pollutant. Acid rain. Here, this also. These are the released from us primary pollutants which react in the atmosphere on their own and form another chemical which is dangerous for us. This is called as photochemical smog. Photo because it happens in the presence of sunlight. Chemical because it is a chemical reaction. And this is a major pollutant in urban area, smog, during the day. They'll ask, what is photochemical smog? They'll ask. Correct. So you don't have to become a chemist here to understand this. Simple understand. Primary pollutants react and become secondary pollutants. And photochemical smog is the resultant. Simple words, remember peroxyacetyl nitrite. Even if you can't remember this, no problem. Okay. You don't have to remember. Instead of this, you can write this. Peroxyacetyl nitrite is formed. Because you are writing general studies. The paper invigilator will understand. You don't have to be specific. If you can remember, fine, good. So this is the secondary pollutant. These are primary pollutants. Okay, primary pollutants are those pollutants which are directly released from the source, from human activities. From human activities. So primary pollutants react. Pollutants react and becomes secondary pollutant. What is photochemical smog? They will ask. Big cities. This is seen in big cities like Beijing, New Delhi, Sydney, New York. So during the day itself, there is some visibility issues are there. Okay, very commonly seen near the airports also. As a result, this becomes a problem for urban dwellers. See, we are all in urban areas. In future, secondary pollutants are going to increase. Many chemicals we are releasing will react on their own and become different chemicals in the air. And knowingly, unknowingly, we are all inhaling it. So we are asking for trouble. We are inhaling slow poison, which will kill us. We will reduce our life expectancy. Okay, so that is the biggest problem we are facing. So it is good for medical industry. Correct. You might say, sir, health sector will be flourishing because of that. Doctors will make money, hospitals will make money. But health is health. Correct. You can't compromise your health to make others rich. So you have to understand from that angle as well. Because in cities, this has become a business now. Can I go to the next page? Done. This is done. I'll mention that Bergeron process also now. There's space here. Okay. Types of clouds. Next topic. Types of clouds. Types of clouds. Clouds can be classified based on shape and height. Clouds are classified based on shape and height. All of you have seen clouds. Is there anyone in the class who has not seen clouds? So, if you notice clouds, do you agree they all come in different shape? At different height. See here, most of the clouds form very close to the surface. This is the Earth's surface because we have water bodies where? On the surface. Lakes are the source of moisture, river is the source of moisture, correct? Seas and oceans are the source of moisture. As a result, on the Earth's surface, we have water. All this water goes up, clouds form. Up to the height of 2 kilometers, we have most of the clouds. These are called as low clouds. Low clouds. Low clouds. From 2 to 4 kilometers, it is called as mid-altitude clouds. Mid-altitude clouds. Up to tropopause. All of you know tropopause? Up to that is high-altitude clouds. High. So, the clouds are classified based on shape and height. Low, mid, high. First one. So, don't write anything. I'll give you time because you need full page for this. From bottom to top. As a result, don't write anything. Wait. Notice this, please, all of you. From over lakes and rivers, what happens? The air parcel. My hand is the air parcel here. See my hand. It's on the Earth's surface. Earth heats up. Air heats up. There is moisture also. The moisture goes up. Notice this. Moisture goes up. Air parcel and moisture goes up. As it goes up, what happens? Temperature decreases. So all the moisture will cool, forming a low cloud like this, which is flat, just like my hand here. All the moisture will cool at the same time. As it reaches the level of condensation, all the moisture will cool, condense to form clouds called stratus. Stratus. See the word strata. Means layer. Layer. It appears white in color because whatever sunlight is falling is scattered in all direction. Okay, scattered in all direction. So it appears white color and also it has low density. Low density cloud. So it is floating like this. Okay. So slowly it becomes dense. Condensation continues and become dense. When it becomes dense, same cloud will become like this. I'll write here like this. Become grayish color. Because of higher density, what happens? The clouds become denser, more and more moisture condensing, become dense cloud. So then the light entering the cloud will not be able to escape. So it become dark. Dense clouds can trap heat and light. Dense clouds can trap the heat and light. White clouds, rarer clouds can reflect both light and heat. Okay, this has very high albedo. This has low albedo. Remember yesterday's class, albedo, reflectivity. Stratus clouds have high albedo. Whereas nimbostratus cloud, this one has low albedo. These clouds are called as nimbostratus. 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 Stratum is flat, nimbus means varsha, rain. Okay, try to understand this. Stratus clouds are low density clouds. So they scatter both light and heat. Okay, reflectivity is very high. Okay, when the condensation continues, it becomes dense. When it becomes dense, more molecules will be there, water molecules. So it can trap that light as well as heat. So it appears darker. So nimbostratus clouds appear dark. Notice before rainfall, when it is about to rain, the entire sky would have become dark, kind of. Correct? And also, the color of the cloud is grey color or dark color. Next time you notice. That is indicating it is nimbostratus cloud. Correct? 3 days before we had this nimbostratus clouds around Hyderabad. Across Hyderabad we received good rain because of this cloud. Nimbostratus cloud. Remember, even the afternoon was almost looking like evening. When the nimbostratus cloud appear, the entire day will become like dull. Correct? Many of us will be feeling sleepy. Correct? It's a very kind of a cool weather with regular drizzle, slight rainfall across the city. You would have noticed that 3 days ago it was like that. Okay, that is because of this cloud, nimbostratus cloud. Okay, so please remember this. Stratus, nimbostratus. Nimbostratus can bring good rainfall. Same, next is about the lake. Above the lake, sometimes small clouds are formed like this, which are fluffy in shape, which appear like tortoise. Okay, these are called as cumulus. Cumulus means like a cotton bunch of cotton. Cumulus cloud, fluffy clouds. These clouds sometimes they join. Stratus, cumulus, they join like this. They join. Half flat, half fluffy. they call as stratocumulus. Stratocumulus. This stratocumulus. The rest. You write one word. Stratocumulus. So stratus, nimbostratus, cumulus, stratocumulus. These are the 4 clouds which are considered as low clouds. All of you pay attention now. These are 4 clouds called as low clouds. What happens? Sometimes the wind is blowing like this, sometimes it is going like this, air currents. So the clouds, stratus and cumulus, both are light, low density cloud. These two are low density clouds. So they go up, slowly they go up. Then here they called as altostratus. Here it is called as altocumulus. Like this. Alto. What is alto? Because mid altitude. Cumulus. Alto stratus. Same clouds. They form here. They get lifted up. Further they go up. So here it becomes ice clouds. Temperature is in minus -. So it becomes ice. White blanket जैसा हो जाएगा यहाँ पे. This is called as cirrostratus. Cirrus means ice crystals. Okay. Cumulus comes here. Becomes like this. Small ice crystals freeze. They'll become like this. Like they look like scales of the fish. If you've seen a fish, mackerel fish के ऊपर scales है ना ऐसा. It looks like that. Scales of the fish. So it's called as cirrocumulus. I'll show you all this in the photo. Please wait. Cirrocumulus clouds. So it's called as mackerel sky. Mackerel sky. Okay, mackerel sky. Please remember this. Sometimes only moisture comes up. That moisture will freeze, forming like feather of the bird, like this. Like this. This is called as cirrus clouds. Means ice crystals. Sometimes it look like feather, wispy, like a horse tail. Have you seen horse tail? Like that. It looks like a horse tail. Okay, horse tail. They'll ask, which of the following clouds appear like mackerel scales? This one. Which of the following clouds appear like a horse tail? Wispy, feathery, cirrus. Which appears like a white blanket? Cirrostratus. Like that. They are asking so many questions. Last year itself, there was a question, 2024 paper. This was there, 2024. Okay, why they are asking, I don't know, but they are asking one question on this. Clouds के ऊपर. So these are the bunch of clouds that are formed normally. But certain cases, on a hot day, summer afternoons or summer days, it will be so hot, temperature will be very, very high. Earth heats up, correct? Because of the sunlight. What happens when the earth heats up? Air heats up. There is a lot of evaporation also. Hot air goes up. All of you see the board now, please. Hot air goes up. Hot air goes up like this, in convection, like this. It goes up and diverges here, near the tropopause. Near the tropopause. This is tropopause. Because the tropopause is 2 kilometers thick. Okay. It's a transition zone between troposphere and stratosphere. So as the air goes up here, warm, moist air goes up, moisture goes up, all the moisture starts condensing, form a huge cumulonimbus cloud here. Cumulonimbus. Wherever there is vertical rays from the sun, this happens. Where? Equator. Near equator every day. What type of cloud is formed? Cumulonimbus. On a hot day, summer, wherever we have summer, this happens. Okay. Or let's say cyclones may we have this. Okay. So wherever we have summer or near equator or near cyclones, we have cumulonimbus clouds form. Cumulo means what? Fluffy. Nimbus means rain, varsha. Wherever I am using the word nimbus, you remember that. The word nimbus means rain bearing or varsha. Okay, means rain. Nimbus. So these are the types of clouds we have. Okay, in the first round, all of you should remember this much. Inside this cumulonimbus cloud, what happens? I'll tell you now. See here. Moisture going up. Most of the moisture will condense to form water droplets first. Water droplets here. Water droplets. As you go up, temperature will be in. Correct? Minus. As a result, all the water vapor will freeze to form ice crystals. Ice crystals. Here. Ice crystals. ice crystals. Further, it will go up. The moisture will freeze on the ice crystals, forming hail like this. Remember, I told you that already how it is formed. Anta. Super cooled ice crystals. So within the cloud, we have three types of matter. One, water drops, ice crystals, hail. So cumulonimbus clouds ke andar bhi we have this. So we have water droplets, ice crystals, and hail. Please remember this. I can't write all that here because entire cloud will contain this. All this. Every time the air goes up, all of you notice this, please. There is friction between them. Collision between water droplets, ice. Ice will collide with hail. Like that, they keep colliding with each other. They get brushed with each other. Friction hoga, friction, like this. Let's say if I run, obviously I might brush across many bench here. Friction will be there. So just like that, when the air passes through the cloud, all this will collide. Water droplets here, please. Water droplets will collide with this. Ice crystals form, frictional charges will develop here. Again, ice crystals will collide with hail. Frictional charges will develop like this. Here, in between this, charges will develop because of the collision. Notice this. Opposite charges attract. Like charges repel. Positive charges will repel. Correct, here also. But opposite charges will attract. So positive charges come down. Negative charges go up like this. So I am talking about billions of charges inside the cloud. So a lot of frictional charges develop and they come align with each other. Positive, negative. So billions of charges, when they align a lot, temperature in this column will go up to 15,000 degree Fahrenheit. You can imagine that, to 20,000 Fahrenheit. Can you imagine this temperature? Very high temperature. Such a high temperature is created here. That comes out as a spark of light called lightning. This is what we call as the lightning. The spark of light. Lightning is a flash of light. Just like we have a camera flash. Correct. In the night sky, when you take a photo, your camera automatically turns on a flash. That flash comes and falls on you, comes back, the image is captured. So just like that, the charges here, when they align, sudden increase in temperature creates a flash. Understand the physics behind. So that is called as a lightning. See the spelling. T-N-I-N-G, lightning. Okay. Since the temperature is so high, 15,000 degree Fahrenheit, air expands. Temperature suddenly increases, surrounded by cold air. In the middle is hot air, surrounded by cold air. Air expands, causes the sound, thunder. Correct? Thunder. Now you got it. Have you noticed the lightning, whenever it occurs, there is a sound, huge sound that comes. This is the one. So lightning is a flash of light because of this opposite charges aligning with each other due to a sudden increase in temperature. The expansion of air is called as thunder. You got it? Like this. So understand the physics. So normally what happens when you say lightning and thunder? So when I was a kid, I used to ask my parent, what is this happening? Anta? Why this formed? Correct. Suddenly all of a sudden lightning occurs. We get shocked. Correct. So they used to say it's like the clouds are fighting. You do your homework. Anta. Correct. Or you sleep. Anta. Something like that they used to say, because even they don't know what is happening. And even if they explain also, we wouldn't know. Correct. So I had a lot of questions like this. So I used to ask one of my uncles. He used to say, eyes are in the front, so we see the light first. Ears are slightly behind, so we hear the sound. Anta. Like that my parents used to fool me. Speed of light is faster than the speed of sound. You have to understand that physics behind. So you see the light first. Lightning mein pehle aap light dekhoge. Then after some time you hear the sound. Speed of sound is lower. You got it. That is reason in a lightning, first you see the light flash आएगा पहले. उसके बाद few seconds के बाद the sound expansion of air के वजह से sound आएगा. But here it happens together. Flash and sound comes back to back. But by the time it reaches us, light reaches us first because of the speed of light is faster. After few seconds, sound. Remember this. Okay. Now right. So all types of clouds in one image. I'll show you the image also, so that you will understand what we are discussing. Types of clouds. Can you all see this? low, middle, high. You can see stratus, nimbostratus, cumulus, stratocumulus. Then altocumulus, altostratus. Cirrostratus, cirrus, cirrocumulus. This is cumulonimbus. See this. इतना बड़ा है. These cumulonimbus clouds go up to 10 kilometers, 12, 13, 14 like that. Pura troposphere. From the ground till the top of the tropopause. Can you imagine 14 kilometers clouds है ये. Okay. So remember this. Cumulonimbus. How it looks. This looks like, you notice the shape of the cumulonimbus cloud, all of you. See this shape. ऐसा है. Have you seen a cobbler? Cobbler, he keeps us iron anvil बोलते हैं उसको, anvil for stitching the shoes, or iron smith while beating the metal. He keeps the equipment. Have you noticed that it's called as anvil? Anvil बोलते हैं उसको. Anvil is the metal instrument kept by a cobbler or a iron smith or a jeweler for working on many aspects. Correct. This is called as the anvil. So they'll ask, anvil cloud बोलते हैं इसको. Cumulonimbus clouds are also called as anvil clouds. Like this, UPSC are asking a lot of questions on this. So if I don't tell you, in exam if they ask, you will be in trouble. Simply 2 marks will go. Okay. Because if you know it is easy. See, I told you mackerel. It appears like a mackerel scales. This appears like a horse tail. Okay. This appears like a tortoise. Or somebody's head also you can imagine like this. Or some shape it appears. Cumulus comes in different imaginary shapes. The word oro means barrier. Remember we have used this word orogenesis in geomorphology class. What do you mean by orogenesis? Formation of mountain. The process of formation of mountain is called as orogenesis. The oro means barrier. The oro means barrier. So whenever any mountain, hill act as a barrier. So all of you know, hills and mountains act as a barrier. Barrier for what? Barrier for wind. So please notice this. Let's say a hill is there, like Golconda. Okay. Now let's say the wind is blowing across. What happens when the wind blows across the plain? Here, it comes across the hill. What will happen to the wind? Let's say this is moist laden wind. Moist wind. It is carrying moisture. As soon as it comes toward the hill acts as a barrier. What will happen to the wind? The wind has no other way. It has to go up. So this is called as lift, orographic lift, like an escalator. It has to go up like this. The wind goes up. As it goes up, temperature decreases. We all know that. As we go up over the hill, mountain, what happens? The temperature decreases. So all the moisture here will start to cool. All the moisture starts to condense. When it condenses, it forms a cloud here. A cumulonimbus cloud is formed. Where? This side. On the windward side of the mountain. Windward side of the mountain, the wind goes up. All the moisture cools and condenses because of decreasing temperature. The clouds are formed. And that side, you can see here, the wind becomes dry. This is dry winds here. Dry wind or dry air here. No moisture. Because all the moisture has condensed here to form a cloud. This side will be dry. Now what will happen? The cloud is here already formed. All the moisture has condensed to form a cloud. So it will start raining now. Where? Here. On the windward side, it will get more rain. This is back side. Leeward side. This remains dry. Leeward side receives less rainfall. As you come this side, no rainfall at all. It will be completely rain shadow. Rain shadow. Means rain occurs here. The shadow of the rain will be there. Something like that. No rain. Simple words. No rain. Rain shadow here. Okay? No rain. So over the hill, this side, windward side, we get rain. But the other side, less rain or no rain. So please remember this. Orographic rainfall. So that is the reason hills and mountains have to be protected. We should not go for irregular, illegal mining, quarry and all. What happens when I go for quarry? Rocks are removed. So the height of the hill will come down. Then the wind will not stop. Wind will go like this. Will it rain? No. So the hills and mountains are actually very important. They help us in regular precipitation. That is the reason every afternoon you see some clouds will be there. On top of the hill, small clouds will be there. They will give rain. So every hill in the country is source of streams, small streams. Those streams join to become rivers. Nandi Hills in Bangalore is source of 6 rivers. 6 rivers, can you imagine? So as a result, all that small streams go and join and become big rivers eventually. So we need to protect hills and mountains. Orographic rain. I'll write the map now. Next we'll discuss this impact of orographic rain in India. Shall I continue? Now notice the physical map of India. Where all do we have hills and mountains, you notice? Please notice Aravalli is here, Western Ghats here, okay, Vindhya, Satpura, Maikala here, Himalayas. All of you know the mountains. Already we have done physical geography of India. Middle Himalayas here, Shivaliks here. Okay, these are the hills and mountains of India. Eastern Ghats. Correct. Please notice we are surrounded by water on 3 sides. Bay of Bengal, Indian Ocean and Arabian Sea here. Imagine I am Western Ghats. Okay, this is Arabian Sea. When the wind comes from the Arabian Sea, what happens? I am acting as a barrier. So the wind has to go up like this. Because these mountains are close to the coast. So what happens? The wind goes up. Moisture condenses to form clouds and comes down as rain. So Western Ghats receive very high rainfall. This side is backside, leeward side. This side. So here rainfall is less. What is that? Hyderabad, Karnataka, no rain. Telangana, less rain. Marathwada, Vidarbha, less rain. You got it? So leeward sides receive rainfall, windward side receive more rainfall. This side more rainfall here, coastal areas here. Let's say the wind comes from this side. What happens? Eastern Ghats act as a barrier. No, northeast monsoon aega aisa. Northeast monsoon. So this side will get rainfall here. Again this side becomes, Telangana becomes leeward again. You got it? Certain parts of India becomes leeward from both the sides because of Western Ghats, Eastern Ghats. So this is Telangana, Hyderabad, Karnataka part. Okay. Marathwada and Vidarbha part here. Rayalaseema gets rainfall when the wind comes from this side. Tamil Nadu also gets rainfall when the wind comes from northeast. When the winds come from this side, Kerala will get rainfall. Tamil Nadu will not get rainfall. Correct. Whenever the wind is coming from this direction, southwest direction, Western Ghats, Kerala part will receive rainfall because of Anamalai range. Remember Anamalai, which is the highest range. Anamalai here in the Western Ghats, height is very high here. So Tamil Nadu becomes leeward. Leeward during southwest monsoon. Please remember this. That is reason Tamil Nadu doesn't get much rain during the southwest monsoon season when the wind comes from this direction. Again, when the wind comes from this direction, then they'll get rainfall. So please remember this, okay? This part, if you notice here. Again, Aravalli is here. When the wind comes here in this direction, notice all of you, the wind goes to Meghalaya here. Meghalaya gets good rainfall. Northeast gets good rainfall. Please notice this. The wind comes towards Rajasthan here. Because when the wind goes towards Arunachal Pradesh, these mountains are very tall mountains. The winds get deflected towards Bihar, Assam, Bihar, UP ki taraf because of the Himalayas here in Arunachal Pradesh. Okay. So when the wind comes here, you can notice Aravalli act as a barrier. Here Amarkantak acts as a barrier. All these places will get very good rainfall. This side becomes leeward. Leeward. Wherever I put X, that is leeward sides of India. Rajasthan is leeward, Thar Desert. This part. Telangana, Hyderabad, Karnataka. Leeward. This is leeward. Marathwada, Vidarbha. Leeward. Okay. Then finally the wind goes up to Himachal Pradesh, Uttarakhand here. This side becomes leeward. Himalayas, Ladakh. Ladakh becomes leeward because the greater Himalaya is very tall. Behind that the rainfall will not take place. Wind won't reach here. So Ladakh becomes dry. Ladakh. Ladakh is high altitude. So temperature is low but dry. Cold dry desert. Cold desert. Rajasthan is hot. Temperature is high. Dry. Hot dry desert. All of you are able to understand. There are two types of deserts in India. Hot dry, cold dry. Hot desert, cold desert. Both are leeward sides. Here because of Himalayas, this is because of Aravallis. Extremely dry conditions in both the places cause them to become rain shadow, deserts. Okay. Here also you notice parts of this area between Western Ghats, Eastern Ghats, Karnataka, Hyderabad, Karnataka, Telangana, Vidarbha, Marathwada. Here also bit of dry conditions here. Low rainfall. So what happens when the rainfall is low? Think about this please, all of you understand rainfall is low. Less than 50 centimeter rainfall, let's say. Or let's say 75. We'll take 75 as a criteria because in agriculture also I'll be using this. All those places which receive less than 75 centimeter rainfall per year, annual, are considered dry areas. Okay. If you can take the entire country, 68% of the country comes under dry land. That is the shocking part for us. Majority of our country is a dry land. So as a result, majority of the population are living here. Livestock, cattle, sheep, goat live in this area. No water, no rain means no drinking water. Think about this situation please, all of you, for a while. No drinking water. I mean, simple words, drinking water scarcity. No irrigation. No irrigation means what? No agriculture. Dryland crops we have to grow. Ragi, bajra, jowar, horse gram. Like that we have to grow dry crops. Dry crops only. Wet crops we can't grow. Paddy we can't grow. Sugarcane we can't grow. Okay. Dry crops. No agriculture. Or I can't say no agriculture. I should say only dry crops. Okay. Low moisture crops we have to grow. So hunger high. Very high instances of hunger. Malnutrition means people don't get sufficient nutrition. Malnutrition, hunger, malnutrition. Okay. No agriculture because no raw materials, no industries. If sufficient food is not grown, no agro-based industries. Correct. Agro-based industries are less. Unemployment is very high because of this. Okay. Hunger, malnutrition, famine. Many people die out of hunger. Socio-economically backward. Highest farmer suicide rates here. These areas what I have marked across here has the highest farmer suicide rate in the country. Telangana, Hyderabad, Karnataka, Marathwada, Vidarbha. Okay. Highest farmer suicide rates is found in this part. Socio-economic backwardness. All of you understood the word socio-economic backwardness. So what I am doing is I am linking rain to our situation here. Our economic situation, our social situation, what happens because of lack of rain. So that is the reason the construction of dams in this belt becomes the lifeline. Nagarjun Sagar, Almaty, Narayanpura. Correct. All these projects we are doing, hydropower projects on Godavari, Krishna, Kaveri and all, becomes the lifeline of this region. Otherwise, water scarcity will cause a lot of problem. That is the reason these places have special status in the Constitution, 371, subclause, all of you know. In the Constitution also we have special status for these areas. Ladakh has special status, Rajasthan has special status. These areas have special status in our Constitution because of this. So when you address any question, take from geography, address socio-economic situation, then political situation, how we are addressing this. So geography, economics, society, polity, everything should come in the answer. You should not address the solution, situation only from geographical perspective. You have to take in to the political level as well. Farmer suicide also you should mention. How the situation has worsened here. All of you are from this part only, so you understand. I don't have to say. Okay. So orographic rain occurs only in those places where there are hills and mountains acting as a barrier. So this side we get good rainfall. The other side won't get rainfall. That is the reason, if you notice carefully, in our Western Ghats only you notice, this side we have wet evergreen forest. All of you understand the word? Wet evergreen, wet evergreen. On top of the mountain, semi evergreen. This side dry evergreen. Mountain से इस तरफ आते आते wet evergreen, semi evergreen, dry evergreen. Then become deciduous forest here. Dry deciduous. Okay. Vegetation changes according to rainfall. Vegetation changes as per the rainfall. So more rainfall, evergreen forest. Less semi-evergreen, dry evergreen, then deciduous. Okay, we'll discuss that in vegetation class. Environment class, I will tell you the link between. Already we have discussed geography. It's easy to understand environment. Okay, if you understand this, I can discuss Köppen's climatic classification also by the end of climatology. That is the last topic. Köppen's climatic classification for the world and for India. Many of the state service exams, they are asking that. Like your state exams. UPSC has never asked till now in prelims. Okay, but state services, they have asked. Köppen climatic classification. So is it clear? Orographic rainfall, all of you know. So now see the map, last one. Same 31 page number, I think. What is the page number? See this one. 31 page number. Rainfall map. Bottom left. The red arrow marks are all wind. You see this one. The map you have to see is rainfall and winds, July. All of you see rainfall and map July, this one. Red arrow indicates rainfall. You notice, when the wind comes towards India, you see Western Ghats, they have given some different color. Heavy rainfall, Western Ghats. Northeastern Himalayas also. Northeastern Himalayas also, here. Western Ghats, Northeastern Himalayas. Most part of the country. But low rainfall is given in some other color, you can see. This is low rainfall. Ladakh, low rainfall. Rajasthan, low rainfall. Rayalaseema, Tamil Nadu. That map. There. Yeah, that one. You can see. So remember the page number also. Which map you have to see. Whenever you are reading a topic, let's say orographic rainfall, you write Atlas page number in the notebook itself. What is the page number? 31? So I'll write 31 like this. So what will happen when you are reading the notes? Because it's your Atlas, you know the page number. So you go to that page anta. Refer, you write. Refer Atlas page number in every topic you do. So that you will integrate your notes with Atlas. Okay. So we have done with the second one. Frontal, third one. Frontal precipitation. Frontal precipitation. Under this, give the heading as air mass. Air mass. Frontal precipitation. Under this, air mass. Subheading. When I say air mass, it's a large body of air with a uniform characteristic, with the same characteristic of temperature and humidity. Please write a large body of air. Large body of air with a homogeneous. What do you mean by homogeneous? Same. Homogeneous characteristics in terms of temperature and humidity. So notice that in this classroom, as of now, we have ACs turned on, correct? So this particular air after half an hour will have some quality, air temperature, humidity and all. Suddenly you go out of this class, what will you feel? Because outside temperature will be different. Outside this room, you can see the difference there. Or suddenly you go to another room, next room, there the air conditions will be different. So there you will feel different, warm temperature will be there, or like changes in the air you can witness. You got it? So air mass is the large body of air. I'm not talking about this classroom. Now I'm talking about the continental scale, large body of air with a homogeneous characteristic in terms of temperature and humidity. Okay. The place where the air mass develop is called a source. Source means where they develop. They usually acquire the characteristic of the source. If they are over continent, they'll acquire the characteristic of the continent. If they are over ocean, they'll acquire the characteristic of the ocean. So air mass mainly depend upon the source where they grow, where they develop, where they are located. Air mass usually acquire the characteristic of the source. Air mass, the place where the air mass develop is called as source. They usually acquire the characteristic of the source. Let's say they are in tropical region, it's called as tropical air mass. If it is in polar air mass, like that. Capital T, capital P. Let's say their location is over the continent. So continental air mass. If it is over ocean, maritime. Maritime is a word related to sea. Small letter C, small letter M. Continental C, maritime M. If it is over ocean, let's say Pacific Ocean, it will acquire the characteristic of the ocean. It will be moist. If it is over the continent, it will be dry, something like that, depending upon where it is comparatively. If it is over Antarctica, cold. If it is over Africa, hot, like that, based on the characteristics. Based on temperature also, we can classify warm air mass W, cold air mass K. Why I am taking K? Because C is already taken here for continental, small c. So I am taking cold air mass ke liye K. Universal, everywhere we are using the same. Done? Till now, all of you know what is tropical, polar. Okay? Now, I'll use different combinations now. Capital T, capital P. Wait, all of you notice this. Tropical region, we have both land and water, correct? So, continental tropical, maritime tropical. Indian Ocean is empty. India, land, CT. Africa, CT. Correct? Ocean, Pacific Ocean, empty. Like that. Again, it will be warm, continental tropical, warm, continental tropical, cold based on the season. Summer, it will be warm, winter it becomes cold. Correct? So, maritime tropical, warm, maritime tropical, cold. See? Tropical mein. Similarly, polar mein. Continental polar, maritime polar. What is maritime polar? Arctic Ocean. Continental polar, Antarctica. All of you know, Antarctica is a continent. Arctic Ocean is the, yes. So I am classifying air mass now. Classifying air mass. Again see, polar regions experience 6 months day, 6 months night, remember? So continental polar warm, continental polar cold. Maritime polar warm. Okay. Maritime polar cold. Like this. Classification of air mass. Right, first 60 north, 60 south, two different air masses, opposite air masses, contrasting air masses meet. Since one of them is different from the other, one of them displaces the other. Warm air mass goes up, cold air mass remains there. What if both of are cold? They would have joined. Both are warm, then also they would have joined. Since they are contrasting in nature, the warm air mass goes up. All the moisture condenses to form clouds and it will give rain. Where? Here. It will rain here 60, 60. This boundary between two air mass, all of you notice this. This boundary between two contrasting air mass is called as front. 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 What is front? Now you know. The boundary between two contrasting air masses is called as front. Or a transition zone between two air masses is called as front. So what happens? This front is close to polar region or equator? Russia. European countries and Russia. Please notice 60-degree belt, 60-degree north. Across this belt, all of you got it? 60-degree north. Every day, warm air mass, cold air mass meet. Warm air mass goes up, condenses and comes down as rain. Imagine every day. It's not a very heavy rainfall, torrential rainfall, but it will be raining always. What happens if it is raining always? Soil moisture increases. Surface water increases. Groundwater increases. So vegetation, dense vegetation. But here the sunlight is less. So temperate coniferous forest. Cone bearing plants. Gymnosperms grow here. Here. Cone bearing plants here. Okay. So here we have temperate coniferous vegetation here. This across Alaska, Canada, then Greenland, shores of Greenland, ice completely glacier. Leave those two. Europe, Siberia, entire we get temperate coniferous forest because of this frontal precipitation. Same. Notice this southern hemisphere, 60 south. But problem here is we have no land. 60 south, there is absence of land here. देखो 60 south देखो. 60 south में land ही नहीं है. Only water. What happens if it rains over the water? Correct. No. Rainfall will take place. But it's taking place over the water. Antarctic Ocean. See, 60 south is what? Antarctic Ocean. No land. So I said, no vegetation here. Only small parts of Chile, Argentina here. Chile, Argentina gets some vegetation here. New Zealand ke paas. Otherwise, completely ocean. Okay, clear to all? So no land, as a result only water here. So frontal precipitation takes place along which latitude? Approximately 60 north, 60 south. Temperate polar region. Temperate and polar region. So now you know why Russia has such a large area under forest cover. Because Russia is a very large country. They are receiving very good rain also. So as a result, Russia has the largest area under forest cover. Then comes Canada. Then comes Brazil. All of you got it? If you have to calculate the area of forest cover, world, first country with the largest area, Russia hai. Because Russia ke paas bahut land hai. Then comes Canada. Second largest country, Canada. When it comes to forest, dense forest, then comes Brazil. Dense forest. Okay, Brazil. So majority of the area of Russia and Canada are under forest cover because of this rainfall. Don't you think there is a link between our climate and vegetation? That you have to understand. What is front? I'll write here. Front is a transition zone or boundary between two contrasting air mass. What is contrasting means? Different. Between two contrasting air mass. Imagine two armies marching towards one another. Indian army, Pakistan army, just like that. In the front of these two armies is a area called war front. Have you heard of the word war front? Yes. This is air front. Just like that. Warm front, air front. How this leads to cyclone, I'll explain next. This topic, what we are discussing now, will be continued in temperate cyclone class. I'll write that also. You also write this. To be continued in temperate cyclone class. Because this is related to this. To be continued there. But I'll add one more topic now. Okay, before we take a break. Let's complete that, Let's complete the topic and we'll take a break. This I have to show. What happens here? Warm air mass, cold air mass jab milega. What will happen to them? That I have to show now. Can I go to the next page? Okay, small diagram is there. Let me complete that. Please wait, all of you. See, this is the Earth's surface. Warm air mass, I am taking yellow. Cold air mass, I am taking blue. Okay, orange and yellow, orange and blue color I am taking. Okay. In this case, let's say warm air mass is moving towards cold. In this case, we'll take cold air mass is moving towards warm. So we are considering two cases here. Notice this. Let's see what happens now. We all know warm air mass temperature is high. It is moist also. It has more moisture. Correct? Warm air mass. It is light, not heavy. Correct? Whereas cold air mass is temperature is low, dry. It doesn't have moisture. Cold air mass doesn't have moisture, and also it is dense. Correct? Cold air mass is dense. Cold air is always dense because cold air molecules contract. Dry also, no moisture. Temperature is low. Whereas warm air expands. It can accommodate more moisture and it is rarer compared to cold. So when the warm air mass goes and collides with cold air mass, all of us here, cold air mass is heavy, dense, so it remains on the ground. Cold air mass will not move at all. It will remain in its place. What happens to the warm air? The warm air goes up. Because warm air mass is light, so it goes up. Rarer. Warm air mass is rarer compared to that, density wise. So warm air mass goes up. This boundary between warm and cold is called as front. Symbol is this. This symbol is called as warm front. Internationally used symbol, warm front. Warm front symbol है, semicircle. Between two air mass, the boundary is called as front. And this symbol is warm front. because warm air mass is moving here. Okay, please remember this. Warm air mass goes up means what happens? Moisture also goes up. Temperature decreases, so moisture will condense to form a cloud. यहाँ पे cloud बनेगा यहाँ पे. This is a cloud here. Nimbostratus cloud will be there. Flat cloud. What cloud? Nimbostratus cloud. Remember, we have discussed different types of clouds. Flat cloud is formed. Nimbostratus cloud. Okay, types of clouds you can discuss. You can check in your notes. Let's take, in this case, cold air mass is moving towards warm. Please notice that the cold air mass is heavy and it is moving towards warm. What will happen now? Forcefully it will come and collide with the warm. So cold air mass is heavy, so it remains on the ground, but displacing the warm air upwards. In both the case, which is going up? Warm. In both the case, which is on the ground? Cold. Remember that always, because cold air mass is heavy. It will take the ground, pushing this up, vertically up. What happens when the warm air mass goes up vertically like this? All the moisture will go up, condense to form a cumulonimbus cloud. It all depends upon how the air mass is going. If it's going slowly upwards, nimbostratus. Vertically upwards, cumulonimbus. That's it. So this is called as a cold front, because the cold air mass is moving. Symbol is triangle. Cold front. Please remember, whichever air mass is moving, that front you have to take. Warm air mass is moving towards cold, warm front. Cold air mass is moving towards warm air mass, cold front. Whichever air mass is moving, that air mass name you have to give for the front. Please write now. So both the cases clouds are formed. I'll use white color for the clouds. This topic will be continued again in temperate cyclone class, because this is not over yet. I'm just talking about rain. I'm just concentrating on the rain part. Okay, cyclone we'll discuss. Post break, we'll be discussing winds, cyclones, formation of cyclones, types of winds, local winds, global winds we'll discuss today. Okay, tomorrow's class we'll finish cyclones, we'll finish the topics monsoon and all. So cold front symbol is triangle, warm front symbol is semicircle. Please remember that. Okay, across the world we use the same symbol. There are two more fronts, stationary front, occluded front, that comes in temperate cyclone. Okay. See how it looks. What we have discussed. What is semicircle indicates? Warm front, given in red color. Triangle, cold front, given in triangle. On the map, our climatologists, scientists use this kind of maps to show them. Okay. So in temperate cyclone class, you'll understand what this means. You'll understand. You have to wait, because the topics I'm not completing in a hurry. We are going slowly, step by step. Okay. In climatology, that order is very important. If I miss this order, you will also not understand. Okay. So don't worry. We'll continue this in the temperate cyclone topic. Next is cyclones and winds. Okay. Any doubt in this? Just remember, warm air is lighter than the cold air. Warm air goes up, cold air comes down. Warm air contains moisture, so moisture condenses to form clouds. The way it goes up is important. If it goes up slowly, nimbostratus. If it goes up vertically upwards, cumulonimbus. Question, Prelims Mains. They're asking, which of the following front is formed when the cold air mass is moving towards warm air mass? Then cold front. Which cloud is associated with cold front? Cumulonimbus cloud. See, like this they're asking. Which cloud is associated with warm front? Nimbostratus. So which front is formed when the warm air mass is moving towards cold? Warm front. So please remember, topics are very easy. Questions are very easy. Only thing you should know the concept properly. One by one, step by step, you should understand. Okay, because cyclones are initiated by the winds. We have to understand certain concepts like Coriolis force and all. So we are doing this. Give the heading as winds now. In simple words, winds are nothing but air in motion. Okay, air in motion. And winds always move from high pressure to low pressure. Yes, that you have to remember. Air in motion from high pressure to low pressure is called as wind. So all of you know, on the Earth's surface, some places receive very high insolation than the other. Wherever the insolation is very high, land heats up, air heats up, the hot air goes up in convection, causing low pressure here. See, there is low pressure here. On the other side, let's say here the insolation is less, temperatures are less. What happens when the temperature is less? Earth temperature, air is also cooler. When the air is cooler, what happens? Dense. Cold air is dense. High pressure. So on the Earth's surface, so there are certain places with high pressure, certain places with low pressure. This air is going up. In order to occupy this, air from high pressure starts moving like this. From high pressure to low pressure. This is called as wind. This is called as wind. Simple words. Okay. So what about this going up and down? These are called as air current. Whenever the air is moving vertical, up and down, they are called as air currents. Air currents. That is the difference. Vertical movement of air is called as current. Horizontal air motion is called as wind. Please understand the difference. This air current going up and down can cause turbulence in the planes. Let's say your plane is going like this, suddenly the air comes. So that causes shivering of the plane. Again, shivering of the plane. So your pilot will say, please wear the seat belts. We are expecting turbulence. Turbulence is caused by vertical air currents. Okay. Turbulence is sudden vibration in the plane. So air currents initiate turbulence. Whereas horizontal motion from high pressure to low pressure is called as winds. Okay. Before going into the basics, first you will understand the wind speed. Speed of the wind is measured using anemometer. This is asked in some small exams. Police sub-inspector, excise sub-inspector exam, PDO, FDA, correct, those exams, your government exams they'll ask. Speed of the wind is measured using anemometer. Unit, kilometer per hour, miles per hour, or knot. This also was asked once. Knot mein K is silent. K is silent. They have asked. Knot is a unit for measuring which of the following. Like that they have asked. Sometimes the questions are very simple, and those simple basics you don't know also, you are not going to clear those exams, simple exams. Okay. Some exams questions are very easy. Only thing is your basics should be strong. At the basic level they will play. Okay. Wind speed. Then direction of the wind. Wind direction is measured using wind vane. Wind vane. Wind vane is an instrument that shows the wind direction, which direction the wind is blowing as of now. Okay. Wind vane. I'll show you all this. Photo I'll show you. Wind vane, wind speed and all. Okay. These two should be first basics. Then Beaufort scale. Beaufort scale. It is named after Admiral Beaufort. So British Admiral. Who is Admiral? Admiral is the head of the Navy. Navy head is called as Admiral. Admiral Beaufort was in Royal Navy, British Navy. So during his tenure in Navy, he noticed wind speed and its impact. Wind speed and its impact. And he has created a scale called Beaufort scale or Beaufort chart. Beaufort scale or Beaufort chart. And this chart ranges from 0 to 12. 0 to 12. 0 means calm. He calls this as calm. No wind sometimes. Have you noticed? Even the leaves will not be moving. The trees, leaves will not be moving. So you'll be able to completely calm condition. No wind at all. That is 0. Sometimes the wind speed is so high, it will uproot the tree. That is 12. Hurricane. He used the word hurricane for that. For the first time. Hurricane is a high speed wind. Hurricane is a high speed wind. 12. So Beaufort was a head of the Navy, British Navy, Admiral Beaufort, Royal Navy. So Beaufort's chart gives us wind speed and its impact. Wind speed and its impact. So they'll ask, which of the following scale is used to understand wind speed and its impact? Beaufort scale. Okay, let's see this first, then continue. All of you understood 0 to 12. Okay. All of you see this. I'm going to save this first. Better. No, it's not opening like that. Nah. See, there is no option for this. Open with. Let me check. 0 means calm. So they have started after 0, 1. They have started 1, 2, 3, so on. You can see a tree, okay, house and a flag. You can see. Okay. When the wind speed is slow, nothing will happen. Okay, notice this. You can see the house chimney and all. You can see wind speed is increasing. Wind speed is increasing. You can see in miles per hour they were given. Slowly the wind speed is increasing. You can see here 47 to 54 miles per hour. You can see the tree is now uprooted, house, flag and all. Correct. Slowly the wind speed increases. See here. See here. Where is the house here? Tree is also not there. House is also not there. Flag is also not there. This 12 hurricane. 73 miles per hour speed mein what wind can do they are showing. So it created a simple chart. Wind speed and its impact. You can do one thing. 73 miles per hour converted into kilometer. 1 mile is 1.6 kilometers. What is 1 mile? 1.6 kilometers. So 73 into 1.6 you will do. You will get around 118 kilometer per hour. That is 118, 120 kilometer per hour is what the car speed we go on a highway. I'm saying general speed normally. At that speed wind can do this much damage. Imagine cyclone, the wind speed goes up to 200 kilometer per hour. You can imagine what will wind do now on that. So you might have heard of this. Your parents telling you, fire, don't play with fire, don't play with water. Add wind also to the list. Because wind can aggravate fire. It can spread fire from here to there within seconds. It can aggravate rain. It can aggravate waves, sea waves. Wind is so dangerous. As a result, wind scale, Beaufort scale they'll ask. Beaufort scale shows wind speed and its impact. Clear to all? Admiral Beaufort. Okay, remember that. So now this much basics all of you have understood. One more thing I'll show you. These are called as wind socks. Many of you might have seen this wind socks like this. Like a pole and red white bands on just like the socks we are wearing, but both the sides it will be open. So these kind of wind socks will be next to the runway, airport runway, next to that it will be there, because the plane is a very large surface area. Planes have large surface area, right? When the plane takes off or lands, when the plane lands or takes off, the wind can push the plane away from the runway, drift the plane away from the runway, and it can cause accidents also. So the pilot who is landing the plane, he has to know the wind speed on the ground level, on the runway. So runway ke paas ye rahega. So each band indicates miles per hour, 3 miles per hour, then 6, 9, 12, so on. So the pilot will understand as soon as he see the runway ke paas, as he sees, okay, he'll know, okay, wind speed is less, he can safely land. If the wind speed is very high, he'll not be able to land the plane, because by the time he touches the ground, the plane can drift away from the runway and crash. That is also there. So this is very important, especially in aviation. Wind socks. They'll ask, what is wind socks? Where it is used? Next to the runways in the airports. Next time you go to an airport, you just look for this. Okay. Surface wind speed is very important for the planes to either take off or land. Especially landing, this is very crucial. Okay. Each of this indicates the speed. Wind socks, all of you know now. Application topics they'll ask. So where are we using winds for? Like what all we have seen winds application wise. If you notice applications of wind, right from the days we started using kite, remember kite, flying a kite? As a kid you would have done flying a kite. You will hold like this, your friend will hold on the other side. Correct. So you will flying a kite. So you can see kite. Kite flying. We have used wind for that. We have used wind for energy, wind energy. Today also we produce power using wind energy, correct? Converting wind energy into electrical energy, that's what we do using turbines, wind turbines. We have used winds for application of winds, I'm saying, okay? In many countries earlier, they used to use wind energy to pump water from the ground. Water pump, wind pump they call it as. wind pumps were used to pull water out from the ground. Okay. In many countries, windmills were used. Wind energy was used to cut wood, to grind corn, and all. They were using windmills in Netherlands. Amsterdam ke paas around, if you go, so you get to see a lot of windmills. So they were using wind energy to convert wind energy to electricity, one, plus using that energy to cut wood also. They were using. Okay. Then fifth one, sailing. Sailboats to sail over the water. To sail over the water. I'll show you these two now. Windmills and sailboats I'll show you. You should understand where all we are using this application of winds. Okay. Quickly we'll see sailboats. So these are called as sailboats. You can see this is a sea or ocean. You can see a ship and a central mast like a pillar. Attached to it is a thick fabric material, you can see. Earlier we didn't had turbines, engines, diesel engines, petrol engines were not there. How did they sail over the water? These kind of boats. You might have seen Christopher Columbus, Vasco da Gama, Cholas. Our Cholas used these kind of boats to navigate the sea. Okay. So what they do is when they turn on this mast and release the fabric, the wind blows. As the wind blows, what happens? It will push the canvas here, thick fabric here. So in the same direction. So it will push the ship also in the same direction. So it's called as sailboats. Using the wind, they sail over the water. Using the wind, they sail over the water. You can see a lot of images online like this. So earlier all the boats were like this, sailboats we were using to sail across the ship. Okay, winds were used for sailing over the water. I know it is slow, but at least you can move over long stretch. So that is one. So windmills in Netherlands, I'll show you. But anyhow, the image picked up. See here, the Dutch windmill, how it looks. Ancient windmills. Okay, very popular windmills. You can see this wind energy is used for cutting wood, grinding corn, and all, various purpose. So at least now you know, okay, where the wind is used now. Okay, let's come to the physics behind this now. What happens? Let's see. Let's say this is Earth's surface again. I told you insolation over a particular area heats up the Earth's surface. Land heats up, air heats up. The air heats up because of the terrestrial radiation from the Earth's surface. Once the air heats up, air expands and goes up. Air expands and goes up. You can see hot air going up. So this causes low pressure over the place. So this is clear to all. In another place, let's say the temperatures are comparatively low. Comparatively, I'm using the word comparatively low. What happens? Earth is cooler, air is cooler. So cold air is dense, contracts, it comes down. Like this. Here the pressure is high. So this much is clear. So the wind starts blowing from high pressure to low pressure. I'll use different colors so that wind starts blowing from high pressure to low pressure here. So difference in pressure between two places is called as pressure gradient. Please remember. Let's say here is 1010 millibar pressure. Here it is 910 millibar. What is the difference? 100 millibar. The difference in pressure is called as pressure gradient. Pressure gradient. Pressure gradient. Higher the difference, faster is the speed. If the speed is very high, that means pressure gradient is very high. Please remember, the difference in pressure, let's say this place and this place. I am taking example A minus B or B minus A. How much? 100 millibar is the difference. Higher the difference, faster is the speed. The force with which the wind blows from high pressure to low pressure is called as pressure gradient force. Means at what force the wind is blowing from high pressure to low pressure is called as PGF. Pressure gradient force. Okay, now I am discussing the physics of wind. Please remember this. The difference in pressure is called as pressure gradient. What is gradient means? Difference. Higher the difference, faster is the speed. The force with which the wind is blowing from high pressure to low pressure is called as PGF. Okay, this much is clear now. When the wind is blowing over the Earth's surface, the PGF is very strong, you can notice here, from high pressure to low pressure. The wind is subjected to other forces. Other forces such as, first one, friction from the ground. The friction is because of the uneven Earth surface. The frictional force is always acting opposite to the wind. Always opposite to the wind. Friction is caused because of the uneven earth surface, hills, mountains, trees, buildings. We have buildings, different height of the buildings, trees, uneven earth surface. So because of that we have friction. Friction always acts opposite to the wind. Second, gravity, Earth's gravity. Gravity acts downwards. Earth's gravity acts downwards. Gravitational force. Gravitational force. This force acts downwards. So if the wind is moving from high pressure to low pressure, there will be other forces opposing it. Which is that? First one, friction. Friction of the ground. Let's say if I am running, obviously the bag you have kept, the chairs will cause friction. Friction, that is friction. Gravity is acting downwards. It will slow me down. Gravity also. Third, because of the earth rotation, Coriolis force. Coriolis force. This is because of the earth rotation. Remember, earth is rotating, spinning on its axis. The earth rotation also causes the impact on the wind. So, if the wind is blowing from high pressure to low pressure on the earth's surface, there will be a lot of other forces acting against it. Against this wind. Which are those? Friction, gravity and Coriolis. Please write. So wind is subjected to various other forces. These are air currents. Air going up and down is air current. I am not worried about this and this today. I am worried about this. Okay. The difference in pressure between two places is called as pressure gradient. I'll write that here. The point that you need to remember. Difference in pressure between two places. Higher the difference, faster is the speed. Higher the difference, faster is the speed. So they'll ask, the wind speed on earth depends upon what? Answer is pressure gradient. Pressure gradient force mainly. Okay. Next point, the force with which the wind blows from high pressure to low pressure is known as, yes please, PGF, pressure gradient force. Now all of you know what is PGF. Where is the globe? We had a globe. Globe. So please write this also. Difference in pressure between two places is known as pressure gradient. Higher the difference, faster is the speed of the wind. The force with which the wind blows from high pressure to low pressure is known as pressure gradient force. Easy. What are the other forces which oppose the wind? Friction. Always in opposite. Remember this. You also write like this. Okay. I'll explain this one by one. Coriolis force I'll explain. Friction is because of the trees, buildings, uneven earth surface, relief. You travel from here back to Indranagar and Tank Bund. Don't you think the land elevation changes? Buildings also are there, trees are there today. That is friction. So wind speed reduces because of that. That is the reason I have written opposite. Okay. Gravity is acting downwards. It's a force of attraction of the earth. It tries to slow down the wind. Then third force is Coriolis. The word Coriolis is the name of a scientist actually. Jasper Gustave de Coriolis was a French mathematician in 1835. He was a mathematician. Okay. In 1835, he said, because of earth rotation, any moving object on the earth rotation will have an impact. Earth is rotating, spinning. Because of which, any other object on the earth which is moving freely will be affected. He said only that much. Since he gave the concept of that, so the name Coriolis was used. Coriolis force is because of the earth rotation. He suggested because of the earth rotation, every other moving object on the earth will have an impact. Okay. So that was given by him. I'll explain now one by one once I get the globe. Can I go to the next page? Wind I am calling it as PGF because it depends upon the pressure gradient. So wind is nothing but PGF, pressure gradient force. Faster the speed, higher the difference, faster is the speed. So for wind I am using PGF. Now I am going to the next page now. See here now. Earth I am taking here. First, we all know Earth spins from west to east. West to east. Because of the momentum. Earth's momentum ki wajah se Earth is spinning west to east. All of you know. Okay. Let's say we look at the Earth from North Pole. You look at the Earth from North Pole. When Earth is rotating, you look at the Earth from North Pole and then you look at the Earth from South Pole. Right, this much now. Let the globe come. We'll see. Because I need a globe to show you how it spins. West to east rotation, North Pole, South Pole. This is South Pole. This is North Pole. You are looking at the Earth from two different poles. See here, please, all of you. This is the axis. Earth is spinning around its axis from west to east. All your eyes on the globe, please. Okay, west to east, ghum raha hai, dekho. Okay. Now, west to east rotation, I am showing you the North Pole. All of you see here, North Pole. See here how it rotates. Notice this. West to east only. North Pole, say it appears that Earth is spinning anti-clockwise, correct? Clear? South Pole, say? That's what. That's called a perspective. So, South Pole, say, if you look at the Earth appears to rotate clockwise. Clockwise, ghum raha hai Earth. From North Pole, if you notice from above, Earth appears to rotate anti-clockwise. First, you all understand this. Clear? Try to notice this again. Earth is spinning from west to east. North Pole, dekho. Correct. Like this. South Pole, you notice. After the class, you can just check the globe if you want. Okay. North Pole and South Pole, Earth appears like this. First. Now, think about this as a merry-go-round. In a park, if you go to any public park, there will be a round circular plate like merry-go-round bolte hain usko, where the kids can sit on it and you can rotate it clockwise or anti-clockwise. Let's take that kind of a board like this. Okay. So let's say it is stationary. As of now stationary, let's say I have a round circular plate here in the classroom, and from here from board to the door I have to run on it like this, straight. Now notice that I am running on this plate. As of now it is stationary. What is stationary? It is not moving. It is not rotating. Since it is not rotating, if I run on it like this, nothing will happen to me because the plate is stationary. I can reach here. Again I can run back. Imagine now I am running like this in this direction and you start rotating the plate like this. Anti-clockwise ghuma rahe ho usko. What happens now? As soon as I step on the rotating plate, the plate is rotating. As soon as I step on it, what will happen? Either I will fall back, correct? Or my running direction will change. Instead of going like this, I'll get deflected like this. Because of the rotation. Because of its rotation like this, anti-clockwise, I'll get deflected in this direction. Instead of going straight, I'll get deflected like this. Towards my right, I'll get deflected. Towards my right, I'll get deflected. Imagine I'm running from this side now. Again, same. It is rotating anti-clockwise. So again, instead of running straight, I'll get deflected like this. Towards my right again. Notice this. So, moving surfaces, any object which is rotating, on which another object is trying to move, will get deflected obviously. Like a moving bus. Let's say you are in a bus, moving bus, and you are trying to walk inside the bus. Correct. They have given railings for you to hold. Otherwise, you might fall. Correct. If already the bus is moving, and inside that you are trying to move, means obviously the change of deflection will be there. So the earth is spinning, and on that spinning object you are trying to move. So what will happen? Deflection will be there. This applies to all those objects which are in uncontrolled motion. What is uncontrolled motion? Who is not, let's say for example a jet, fighter jet or a plane. Pilot is there. He is controlling the speed, direction with the help of a joystick. So it will not apply in those objects. It will apply to those objects which are in uncontrolled motion, like an arrow released, bullet fired, correct, sniper bullet, or the missiles launched on the earth. Once it is launched, it is the mercy of the nature. So on those objects, it will apply. So Coriolis force applies to those objects which are in uncontrolled motion on a rotating earth surface. On the rotating earth surface, all those objects like wind, ocean currents, which are in uncontrolled motion, they are affected by the Coriolis force because of the rotation. So any moving object in the northern hemisphere will get deflected towards its right here. I'll remove excess arrow marks I have written, I have removed that. Here you can see if the person is moving like this, he'll get deflected towards right. Here also you can notice. I'm just showing you. Now I'm running on this, I'll get deflected like this. What about here? If it is stationary, nothing will happen. I'll run straight. But if I am running now and you're rotating it clockwise, imagine you're rotating it clockwise now. What will happen? Instead of running straight, I'll get deflected towards my left like this. Like here also. If I'm running back now, see here, my intention is to run straight, but because of the rotation, I'll get deflected towards left. You got it? So same is with the earth also. Any object which is in uncontrolled motion gets deflected. This was given by Ferrel, William Ferrel. Ferrel's law. William Ferrel. So this is called as Ferrel's law. Ferrel's law. So Ferrel's law states that because of the earth rotation, there exists a force called Coriolis force. I'll write, you copy it. Is this visible or should I write in the next page? Visible? Because Ferrel's law states that because of the earth's rotation. If you can't see, I'll dictate. Given by William Ferrel in 1865. 1865. Years are important for optional students. Okay. William Ferrel. Ferrel's law states that because of the earth's rotation, there exists a force called Coriolis force, due to which any object in an uncontrolled motion, what is uncontrolled, you know, which is not controlled by anyone, which is at the mercy of the nature, once released, okay, which is moving in the air, okay, or on the earth's surface, uncontrolled motion, will get deflected towards its right in northern hemisphere and towards its left. Please remember, वो जो object move हो रहा है ना, उसका right और उसका left, not towards your right. Be careful, many students will confuse like that. Towards the object's right or towards left. So whenever you release an arrow, correct, you might have seen a bow and arrow. Arrow will have a feather at the end. Have you seen? They have placed the feather. It will rotate. Have you noticed? It's spinning actually when it goes. Okay. So if the arrow is released over a long distance, what happens? Obviously, it goes through the wind like this. Okay. So it can be affected by the Coriolis force also. I'll explain that. So there is another force. First you understand this Coriolis force. The Coriolis force was explained by William Ferrel. So the name Ferrel's law. Okay, the concept was given by Coriolis. Application was given by Ferrel. So if you notice rockets also, you have seen PSLV, GSLV rocket launched from the earth. Have you noticed the rocket doesn't go straight? It is going up. As it goes up, it slightly get deflected towards its right in northern hemisphere, towards its left in southern hemisphere. You got it? That is the reason we launch rockets from the east coast. In case if it falls back also, it will fall into the Bay of Bengal water. You got it? Let's say if I launch the rocket from Mangalore instead of from Sriharikota, the chances are very high the rocket while taking off, it goes up and falls back over the country, India, Bangalore ke upar. You got it? So that is the reason all rocket launching stations in the northern hemisphere and the east coast. All rocket launching station. Whether it is NASA's rocket launching station, Cape Canaveral, Kourou space station, China's Hainan Island, Okinawa, Japan, Tanegashima, India's Sriharikota, all these are what? East coast. Okay, please remember that. In southern hemisphere, rocket launching stations on the west coast. Okay, because southern hemisphere left deflection, northern hemisphere right deflection. So all of you know what is Coriolis force, given by Jasper Gustave de Coriolis is a scientist, mathematician, who said because of Earth rotation there is a force. That force was applied by Ferrel, and he discussed Ferrel's law. Done with this theory? Can I go to the next page? So one is Coriolis effect we are discussing on any object in an uncontrolled motion. Okay. Another one is Magnus effect in physics. Magnus effect was first given by a German scientist, Heinrich Magnus. This applies to spinning objects. Any spinning object in a fluid medium, air or water. Fluid means any air or water. Spinning objects. Okay, it applies to spinning objects like a bullet or an arrow or a football. Okay, let's say a football match also you would have seen sometime. There is a goal post and a person kicking the ball. He doesn't kick the ball straight. He kicks the ball in one direction. The ball curves like this. Have you noticed that? That is banana effect. We call it as in football. So what is happening when the person is like kicking a ball? He'll be kicking the ball like this, giving it a spin. When the ball goes in the air like this, it spins like this. So one side there will be high pressure, other side there will be low pressure. Create होगा. ऐसे spin हो रहा है ना. So one side high pressure, one side low pressure. So what happens from high pressure towards low pressure? What happens? The ball tries to curve like this, from high to low. Again, high to low की तरफ. So the ball curves and goes like this. It doesn't reach straight. So spinning objects, any spinning object through a fluid medium. Fluid can be air or water. When it spins, one side there will be high pressure, other side low pressure. Depending upon that, the bullet or the arrow curves. In case of a bullet, sniper, a person with a rifle and a scope is called as a sniper. Used for long shots. Long shots, all of you understand long shots? A kilometer long shots. Sniper mein. So what happens? So bullet is also spinning. Once it comes out of the barrel, you could have seen it spinning like this through the barrel and then goes through the long distance, right? Then also this happens. Over a long distance, winds also take over. Wind, high pressure to low pressure. So slight curve is there. The bullet curves like this. Chances are very high if there are two people, one friendly, one enemy. Instead of hitting an enemy, your bullet might hit a friendly. Crossfire hoga. So that is the reason sniper taking a shot is very difficult. Many times it has happened. So spinning objects. Let's say next time you play volleyball, the person who serves the ball, it doesn't just hit, it gives the spin. You notice, slice the ball. So the other side, by the time the ball comes like this, like a curve. Same thing is with the table tennis. Table tennis mein certain shots you hold the racket and then slice the ball like this. What happens? The ball goes, curves, hits the other side's opponent's bench and then spins in some other direction. You notice that. So this applies to all spinning objects. In cricket also. Correct. So in cricket also this happens when a bowler spins the ball. Okay, swings the ball. Swing we call it as. Volleyball, basketball, throw ball. Not the basketball. Okay. Okay, spinning objects. Remember that. They'll ask what is the difference between that. So this applies to all those objects which are just moving in an uncontrolled motion. Okay. Objects moving in an uncontrolled motion over a long distance. Over a long distance. So the objects tend to deflect towards right in northern hemisphere, towards left in southern hemisphere. So that is the reason whenever you release an arrow or sports mein, archery is an Olympic sport. So it is held in a closed arena. Closed arena means what? Either side there will be walls. The target will be there. Person will be standing like this. They try to cut down wind effect. Otherwise, the arrow will be going in a different, altogether new direction. Even the shooting competition also. Next time you see Olympic shooting competition, so they will be standing and taking a shot. All these sports are held where? within a enclosed place, not in open ground, to minimize the wind effect. Okay, so please remember this is going to come. Magnus effect and Coriolis effect, two statements they are going to make. One for the spinning object, one for the objects which are in uncontrolled motion. So now let's apply Coriolis effect. Now, I was telling you theory, will apply now, practical. On the Earth's surface, let's say this is equator, northern hemisphere, southern hemisphere. Northern hemisphere, southern hemisphere. All of you notice this. On the Earth's surface, we have closed isobars, circular isobars like this. Isobar, line joining places of same pressure. This isobar, 930 millibar, another isobar, 950 millibar. Like this, we have circular isobars. Line joining places of same pressure is called as isobar. Okay. Closed circular isobars on the Earth's surface can be noticed like this. Pay attention, please. This is 910. This is 930. 950. Means 20 millibars, it is increasing outwards. So here there is a low pressure increasing to high pressure. Correct? Here all we have high pressure. Here we have low pressure. Clear to all? Okay, please be careful now. This can be written simplified as like this. So every low pressure area will be surrounded by high pressure like this. We can write. So wind always move from high pressure to low pressure. See here. Wind always move from high pressure to low pressure. Can I write like this? Arrow mark. Arrow mark is inwards in a low pressure area. High pressure to low pressure. The difference in pressure between these two places is called as pressure gradient force. All of you know. What is PGF? All of you know. Difference in pressure is called as pressure gradient. Higher the difference, faster is the speed. The force with which the wind blows from high pressure to low pressure is called as PGF. Can I say PGF is perpendicular to isobar? PGFs are perpendicular to, these are isobars, white color line. PGF is yellow. So PGF is perpendicular to isobar. This is a statement given in NCERT. In order to understand that, you have to listen to this. Otherwise, you will not. In NCERT, they have given this statement. PGF, pressure gradient force, are perpendicular to the isobar. I am showing you that. Whatever they are given in theory, I am showing you in practical here. Okay, now you see what is happening. Like this, high pressure to low pressure, the wind is blowing. Now apply Coriolis force, please. Same thing. If you want, sir, what about southern hemisphere? Here also I can write the same. Here also same. Here also, see, low pressure here, high pressure here. Here, high pressure to low pressure. Same concept here also. Always remember, whenever you write low pressure, you should show inward wind movement like this. High pressure to low. Always remember this. All your eyes on the board, please. Stop writing now. Coriolis force. Apply Coriolis force. I'll use blue color for Coriolis force. In northern hemisphere, Coriolis force is to the right. All your eyes on the board. Stop writing, please. Now, right. Whenever you do this, please start from here. Right of this wind. Wind is going like this, PGF. The Coriolis force is acting like this, right. Here also, right. Right. This is right. Southern hemisphere left. See here, left. Left of this. You write this first. Okay. You see this first. Done? Is it clear to all? Till now? Now, whenever the two forces are acting perpendicular to each other, one force like this, another force like this, the resultant is, resultant kahan rahega? Beech mein. Resultant wind, final wind is not like this, because other force is pulling in this direction, right? The resultant wind will be in the middle. Wind will not go to low pressure, it will go like this. Here also. What is the resultant? Here. What is the resultant? Here. What is the resultant? Here. Resultant, whenever the two forces are perpendicular, the resultant wind is in the middle. Here also, dekho, yahan pe resultant wind. Please understand the physics behind this. Now finally, around the low pressure, take only the resultant wind. The wind is like this. The wind starts rotating around the low pressure in the northern hemisphere. In southern hemisphere, like this. You got it? Resultant. You take only the resultant now. So finally, if you join all this, the winds are anti-clockwise around the low pressure here. Here, winds are clockwise over the low pressure here. You notice. This system is called a cyclone. This is a cyclone. Got it? So what is a cyclone? Cyclones are low pressure system, L, with spiraling wind circulation, anti-clockwise in north, clockwise in south. So in order to explain that, I have to start from here. Last half an hour I have spent to explain this. So cyclones are low pressure system. Cyclones are low pressure system with spiraling wind circulation. What is spiraling? Like this, spiraling wind circulation. They are anti-clockwise in northern hemisphere. Here, they go. Clockwise in southern hemisphere. I'll show you the application. Wait, quickly, before you start writing. I made a documentary on this. You keep writing, I'll show. Please try to understand this, because what happens is, directly everywhere they have given cyclones are anti-clockwise in northern hemisphere, clockwise in southern hemisphere. That's it in NCERT. They are not given all this. So you have to understand the physics behind the cyclone formation. First, like this, low pressure surrounded by high pressure will be there on the earth. Then slowly the wind start going from high to low. First you have to write yellow line. Then blue. Blue is what? Coriolis force. Then final resulted in some other color. I'll mention what is what Coriolis force in blue color. Yellow in PGF. All of you understand PGF? Pressure gradient force. Final wind is orange. Resultant wind. Sir, you can see here Coriolis force. Can you also say PGF is perpendicular to Coriolis force? Pressure gradient force is perpendicular to Coriolis force. Okay, PGF is perpendicular to Coriolis force on the Earth's surface. Okay, where the isobars are like this, circular isobars. Circular isobar. PGF is pressure gradient force, CF is Coriolis force. Write in such a way all this should come one next to another so that it looks good. So one line only should come. Cyclones are low pressure system with spiraling wind circulation. They are anti-clockwise in northern hemisphere, clockwise in southern hemisphere. So on the Earth's surface, usually the isobars are like this, circular. Line joining places of same pressure will have this circular pattern. Okay. I'll just mention the circular isobar here. Isobars. Circular isobars on the Earth's surface. Just in case, if they ask you the question, circular isobars are found where? On the Earth's surface. Because uneven pattern of low and high on the Earth's surface. We'll watch the video quickly, then we'll come back again. So you can see a person by the name Henry Paddington. Here. Henry Paddington. He is the one who gave the term cyclone. Henry Paddington. Okay. He is known as father of cyclones. He is the one who coined the term cyclone. Means coil of snake. He was a climatologist, meteorologist who visited India. Madras he was located. From Madras he was going to Bengal in a ship. So during that journey he noticed there was a cyclone in Bay of Bengal. And the ship was stranded in Madras for many days. So during that he noticed the cyclone moving like this. So then he equated a cyclone to a snake. You know snake? What happens when you see a snake? That fear comes in, correct? And it rotates like this in a coil. So he called it as coil of snake. Henry Paddington. He has published nearly 40 papers on this, cyclones. He wrote an article which came in Bengal Gazetteer. Governor General of Bengal noticed and asked him to do more research. That's how he started research in cyclones. Please remember Henry Paddington. So during the cyclone, the wind speed is very high. See here. The wind speed will be 150, 200 km per hour. These are coconut trees, you can notice. Normally coconut trees branches are so strong. You can see it is blowing as if somebody's hair is blowing. Correct? You will see this is a tree. Trees usually have large surface areas, are easily to be blown out. Why? Because more surface area means what? More wind impact. It can pull the tree out. You can see this is Bay of Bengal, Sri Lanka, India, then Burma. This is Bay of Bengal you are noticing. This is a huge cyclone. Can you note? Okay, I'll go back. Video is playing too fast. See here now. So notice from India's east coast up to Burma here. What is the distance? Can you imagine the distance? Nearly 1200 kilometer distance. And notice this cyclone is occupying that entire space. 1200 kilometer diameter hai cyclone ka. Why do you think we are so scared of cyclone? There is a reason. Because cyclones, once they form, they can cover very large area over the water, impacting many countries at a time. Okay. 1200 kilometers in diameter and going up to 14-15 kilometers in height. That is the height of the cyclone. The center of the cyclone is called as the eye of the cyclone. Okay, here is a cumulonimbus cloud. Rest is all nimbostratus clouds. Here at the periphery is the nimbostratus cloud. Center is the cumulonimbus cloud around the eye. You got it. So entire Bay of Bengal it is covering. You can imagine that. And I'll play it now. You notice in the northern hemisphere how it is rotating, southern hemisphere how it is rotating. You notice the entire system will be rotating like this. See here, cyclones are anti-clockwise. I'll play again. See, anti-clockwise in northern hemisphere. You saw that concept, na? This is what I was trying to explain. If I show the video, you'll say okay. But how is it formed? I showed you that. All of you got it? Why it is rotating? Anti-clockwise. The wind is rotating like this means what? Even the cloud, the moisture, everything goes like this. Anti-clockwise in northern hemisphere. This is cloud. Below, imagine what happens below on the ground level. Wind speed is so high. 150, 200 km per hour. The ships will topple. Ships will sink in the ocean. The reason cyclones are called as ship killers. Tropical cyclones are called as ship killers. So it can cause a lot of damage to the coastal areas across the coast. Infrastructure damage, loss of life and property. We have seen deaths as much as like 10,000 people died in Orissa once. Cyclone Falin mein. We were picking up bodies here in Odisha. Like that. Cyclones can cause a lot of damage. In northern hemisphere, you saw anti-clockwise. Okay. Southern hemisphere, clockwise. You see, southern hemisphere, Madagascar ke paas, you can see clockwise circulation. Like this. These are satellite footage, what I have taken. So satellite footage will help us to understand how it looks. Different parts of the world, different names. In Atlantic Ocean, they use hurricane. Remember I told you Admiral Beaufort, Royal Navy, he coined the word hurricane. So that is used, hurricane, everywhere. Okay, hurricane. In Indian Ocean, cyclone. South China Sea, typhoon. Australia ke paas, Willy Willies. North Australia here, Willy Willies they use. Okay. Near Philippines, they use the word Baguio. B-A-G-U-I-O. I'll write Baguio. Next. Okay. Typhoon near South Japan. Different places, different names. When we discuss tropical cyclones, we'll continue. For now, all of you got to know how the cyclone was formed. Only that is the intention of this topic. Application of Coriolis force I wanted to show. What this means in real life, I have shown you. Okay. Because in books directly they have given cyclones are anti-clockwise in north, clockwise in south. That's it. So now I can say cyclones are atmospheric disturbance. They are meteorological hazard, hydrometeorological hazard, because they are related to water also. Since they are related to water, I am saying hydrometeorological hazard. I am linking everything to disaster management. Because in geography, whatever we read, conclusion we have to give in disaster management or in environment. You got it? So that's how you have to read. So complete this. If you have not completed, make sure you complete it. First I started with isobar. I told you, line joining place of same pressure. Then I wrote low, high. Because this is low, this is high. Wind moving from high pressure to low pressure. Then I wrote this yellow arrow mark. Correct? Then I applied Coriolis force. Then I showed the resultant. In northern hemisphere to the right, southern hemisphere to the left. Always start from these two, bottom. Then you write the rest, to the right, to the left. Then resultant will come naturally. You all have to practice this without seeing. Once or twice you see, but without seeing you should be able to write. In exam, questions are coming on these two now. Is it clear? So what is wind, Coriolis force, how the cyclones formed, all of you know now. To understand cyclones, we need to understand other winds first. Types of winds first. First one, local winds, global winds, variable winds, seasonal winds. Local, global, variable, seasonal. 4 types of winds we categorize. Local winds are those winds which are created due to local pressure gradient. Don't worry about definition, I'll write. You just copy this first. Such as we have valley breeze, mountain breeze, these are also called as katabatic, these are called as anabatic, sea breeze, land breeze. So these are local, first set of winds. Global winds are at global scale, like trade winds, westerlies, polar easterlies. Variable winds are cyclones, anticyclones. Cyclones and anticyclones are variable winds. Seasonal wind is monsoon. Monsoon is a seasonal wind, like southwest monsoon, northeast monsoon, northwest monsoon. All these are seasonal winds. Monsoon is a seasonal wind that occurs during certain season. Southwest monsoon, northeast monsoon. First set of category here. These two occurs in India. Southwest and northeast. Northwest monsoon in Australia. This is Australia. This is India. These two are in India. I am writing India in bracket. IND. Done. First heading, local winds. I'll start from that side. Local winds. Hope all of you understood that wind cyclone part. Do you want me to repeat again? I'll repeat. I don't mind. Because that is very important. Again, we'll discuss. Once we cover local winds, again I'll repeat that. If anyone have any doubt, I'll repeat that part. Cyclone. How the cyclones are formed. Because that is the basis of tornadoes also. You have to understand. You have to know that. Coriolis force, if you all understand, topics will become very easy. First heading, local winds. Local winds are the winds which are created due to local pressure gradient. Local pressure gradient. What is local pressure gradient? Means local difference, pressure difference. High pressure, low pressure. Local winds are the winds which are generated or created due to local pressure gradient. Which are generated or created due to local pressure gradient. Local pressure gradient. Okay. So let's explain one by one. We'll take a rocky hill like Golconda. I have taken this hill twice. I have written so that one during the day. This is day. This is night. Same place at night. Okay. Please notice this. During the day, think about the Golconda here, rocky hill. So when I say a rocky hill or a mountain, the mountains have 5 sides. 5 sides, when you see, if you notice this, if this is the rocky hill, 1, 2, 3, 4 and 5, top 5. So mountains are exposed to the surrounding environment on 5 sides. Okay, please remember this. Here on the board it appears like 1, 2, 3. This is 4 and that side 5. So mountains have 5 faces. Okay, one top and 4 on all sides. They are exposed to sunlight. Sunlight can reach from all directions, from all sides. All sides. So what happens? The rock surface heats up. Temperature increases here during the day. Rocky hill alla, it absorbs the energy, heat energy, and heats up, heats up. When the rock heats up, air heats up, the hot air starts going up. When the hot air goes up, what happens? Low pressure is created on the hill, on top of the hill or the slopes. Whereas the valley is exposed to only one side. Mountains have 5 sides, but valley have only one side, which is exposed to sunlight. So valley takes time to heat, so it is still cooler. Valley is still cooler. Plus valley has water bodies also, lakes, streams and all. So it takes time to heat up. So notice this now. Valley is cooler, so air is cooler, high pressure here. Valley is cooler, so cold air, high pressure. I'll remove this white line, I don't need now. So this is high pressure here. Okay, just in case. Okay, see here, high pressure this side. Notice. What happens now? Here, low pressure, this is high pressure here. Because valley is exposed on only one side, the sunlight has to reach only one direction. So it is still cooler. So cold air is high pressure. Please notice this, all of you, don't write anything. So high pressure here, low pressure here. What happens by around 12 o'clock? The wind starts blowing like this. High pressure to low pressure. See here. From the valley, the wind starts moving up toward the low pressure. Like this. Like this. Upwards. This is going from the valley up. It is going up. Upslope wind. Upslope. The wind is going upslope. Anabatic. Greek mein. Anabatic wind. We call it as. It is going from the valley. So valley breeze. Valley breeze during the day. So during the day we have the valley breeze. Wind going upwards. So this wind goes up, takes the moisture also. From the valley, lake, water bodies, small moisture also goes up. All the moisture goes up here. Clouds are found. That is the reason by around 3 o'clock, 4 o'clock you can see small clouds found in the sky. Chota chota clouds rahega aisa. This cloud will give rain. Slight rain over the hill. Every afternoon hill top will get a small drizzle. Slight rainfall hoga. Okay. So please remember this. This can be seen during the day. I'm not interested in the cloud. I'm not interested in the rain also. I'm interested in this wind pattern here. Local wind I'm discussing now. Okay. So what we can do? We can set up wind turbines. Everywhere we have rocky hills, people have set up wind turbines now on top here. So wind turbine with a blade. Remember 3 blades just like fan. The wind blows up. What happens? The blades rotate. It is connected to turbine and a generator. It will produce power, wind energy. So that is the reason if you go on top of any hill, you will get to see a lot of wind turbines. Wind turbines. You go to Tirupati, you notice many places you have seen wind turbines now placed on top of the hill. So same thing at night, same hill at night. What happens at night? No sunlight. That is first thing. Correct? The hill is exposed on 5 sides, means it will cool faster. During the day, it heats up faster. At night, since it is surrounded by 5 sides, it will radiate heat in all direction. The hill will radiate heat in all direction and cools down quickly. By 8 o'clock, 9, 10 at night, the entire temperature of the hill will come down. Temperature comes down. Air becomes cold, dense. High pressure. High pressure on top. Whereas the valley is exposed to only one side. During the day, it has received the light, heat, one side. At night, heat from the hill also. So the valley will be warm now. The valley will become warm. Evening it will be warm. Because the valley is exposed to only one side. During the day, it has received heat. Now after sunset, it received heat from the hill also. As a result, valley is warm. The valley warm air will be going up. Low pressure here. The warm air will be going up, low pressure. So I'll change the color, 1 second. Warm air going up, low pressure. So see this now, high pressure here, low pressure here. The wind starts blowing from high pressure to low pressure now here. The concept remains same, high pressure to low pressure. This is wind is coming down slope. Down slope. Katabatic. Katabatic. Remember this. Down, katabatic slope. Here also. Batic slope. Ana up. Okay. downslope. This is coming from the mountain. So mountain breeze. Mountain breeze. Okay. Mountain breeze. Again, if we have placed wind turbines here, the wind will come down again rotates the blade. Power is produced at night also. So wind energy can be harnessed during day and night, whereas solar energy can be harnessed only during the day. That was a statement given in the exam. Wind energy can be harnessed during day and night, whereas solar energy is harnessed only during the day. Correct. So notice the wind, local winds, anabatic, katabatic, during the day and night. If you are living in a hilly area, you will understand what I am saying. Because hilly areas experience this on a daily basis. During the day, valley breeze. Next time you go for a hike or a trek, correct, you notice this when you are hiking a hill, you notice the wind blowing upwards. Same place at night, downslope. Same topic will come in temperature inversion class. We have a topic called temperature inversion. There also I'll explain this. Have you noticed adventure sports like paragliding? Paragliding in hilly areas, what they do, they go on top of the hill. Here they stand, they'll attach them to a parachute and they run and jump. Correct. And they open the parachute, it'll the air is going upwards, wind is going up, right? So it will cause resistance for them. So slowly they'll come down. Paragliding. Paragliding is an adventure sport practiced in hilly areas like this during the day, not at night. Especially during the warmer part of the day when the wind is moving upwards. Remember that always. So many accidents have occurred across the country, especially in Himachal Pradesh, Bir Biling. में 2-3 लोग मर गए. Correct. हिमाचल प्रदेश में. What happens? The wind speed is so strong sometimes that can also affect them. Sometimes the temperature gradient is not much. So then there will be a sudden drop of the paraglider down to the valley. Then they'll die. Hard landing hoga, hard landing. Because see what is happening during the day, you're jumping from the cliff, right? So the wind is moving upwards, so acts as a resistance for the parachute. So the parachute comes slowly down and you can land softly on the ground. Soft landing hoga. You got it? So at night if you jump down, the wind is also moving in the same direction. Resistance is not there. So what happens? The parachute comes down. The person who is coming down also comes and hits the land at a very high speed. Hard landing. It breaks your spine. That is enough to kill a person. Okay, so many accidents occurred this year because of this. So you have to understand the physics behind. Nowadays the bat suit jump is very popular. Bat suit is a kind of a jumpsuit. Nowadays it's coming up. So where your arms are connected to your thigh with a thick fabric material. People who jump from the cliff, they open up that like this. They glide in the air. It's very popular nowadays. So this kind of local winds help us in, practicing those adventure sports. Wind energy also we can produce like this using the wind turbines across the hills. So notice this, at night this air is coming down from the mountain. It's cold air hai. Temperature dekho, it is low. This cold air comes to the valley. That is then valley becomes very cold at night. Hilly areas, valleys are very, very cold. That is then most of the settlements are built here on the upper slope of the hill, not in the valley. Go to Manali, Mussoorie, Darjeeling. The houses are constructed in the upper slope of the valley, not in the lower part. Because night all the cold air descends down. Air drainage bolte hain, air drainage. All the cold air accumulates here. Warm air goes up. So cold air comes down. As a result, valley becomes very, very cold. We'll discuss this. There is a topic called temperature inversion. In that I'll explain. For now, you just remember. First, you should understand local winds. My concept is about local winds. A lot of application is there related to this. Can I go to the next page? Okay. Notice land and water now. Land and water. A coastal area or a large lake, like our Hussain Sagar lake. Okay. Lake or a sea. I'll take C first. I have taken two places. Same place, two situation. One is at night. One is during the day. During the day. Land and water. Land is what? Rocks and minerals. Land is made up of. Correct? Whereas water is in liquid state. Land is solid, water is in liquid state. So all of you notice this land, water situation. We all know that the specific heat capacity of land, okay, specific heat capacity, the amount of energy required to increase the temperature of a substance of 1 gram by 1 degree Celsius is specific heat capacity. The specific heat capacity of land and water is different. Specific heat capacity of land is low, whereas specific heat capacity of water is high. So all of you remember this, specific heat capacity of land and water. That means land quickly heats up, quickly cools down. Land. Water takes long time to heat up, long time to cool down. Okay. So please remember, specific heat capacity is the amount of heat required to increase the temperature of 1 gram by 1 degree. So land quickly heats up, quickly cools down, doesn't require much. Whereas water takes a lot of time to heat up, a lot of time to cool down. So first is this. Notice this, during the day, all of you notice please, the sun insolation will fall equally on land as well as water. But what happens? Land quickly heats up, whereas water takes long time, because in liquid form the heat is distributed across everywhere. Water is there, it will distribute the heat in all direction. As a result, so water takes long time, so water is still cooler. During the day, land heats up, water takes time. Now what happens? Here the air becomes warm air goes up, low pressure here, whereas air is cooler here, cold air, dense, high pressure. See this now all of you, one side high pressure, one side low pressure. The wind starts blowing from high to low. During the day, the wind is blowing from sea to land, sea breeze. Sea breeze. So this sea breeze brings moisture. That is when coastal areas get humid. Coastal areas become humid. Okay, sea breeze. All this sea breeze comes in, bringing the moisture. So sea breeze is onshore wind. What is onshore? Wind is coming from sea to land on the shore. This shore. This area is called a shore. Okay, so onshore wind. Okay, please see this. Moisture comes in. All the moisture goes up. Clouds are formed here. Clouds. So that is when the coastal areas experience a drizzle, slight rainfall every afternoon. Because of this, moisture goes up, condenses to form clouds and come down as rain. Light rainfall occurs every afternoon, evening in the coastal areas. So this is how the coastal areas moderate the temperature of the land. Land doesn't heat up. Temperature of the land doesn't heat up much because of this rain. So that is when the coastal areas maximum temperature is 30, 32, 35, that's it. Not more than that. It never crosses 35. Why? Because of the light rainfall every afternoon. Because of the moderating influence of the sea. Because the water body absorbs the heat from the land. Temperature never crosses 35. Remember I was showing you Climatology of Calcutta in the morning session. I was showing you Calcutta's highest temperature never crossed 35 because of the moderating influence of the coast. Okay, so remember this. Sea breeze is very important here. At night, what happens here? At night, land cools rapidly. We all know that conduction takes place from warmer side to cooler side. So land will conduct the heat back to the water here. Okay, so land will cool now. At night, what happens? Land cools rapidly. Please remember this. Okay, conduction takes place from land to water. So water absorbs the heat. Water now is warmer. Why? Because during the day it received the heat from the sun. Directly from the sun. Now after sunset it received heat from the land. So as a result now water is warmer. And specific heat capacity of water is high. As a result water can hold heat for longer time. Okay. Water can hold the heat for longer time. So this is warm. So warm air goes up. Here. Warm air goes up. Low pressure. Here air becomes cold. Cold air comes down. High pressure. Now this is high pressure, low pressure now. Wind will go from where to where? Like this. High to low. This is called as land breeze. Why land breeze? Because it's going from land. Land breeze. It is offshore wind. What is offshore? OWF. Because it's going from the land. Offshore. OWF. So land breeze is offshore wind. All the wind will go like this. Moisture will also go like this. You can see this. So land breeze. Please write now. So this also write. Day, night, sun, moon. You also write sun. So land heats up quickly, cools down quickly. That also I'll write. Heats up and cools down quickly. Whereas water heats up and cools down slowly. Please see, both I have written. Land heats up and cools down quickly, whereas water heats up and cools down slowly. Specific heat capacity. Done. So sea breeze and land breeze, all of you please remember. I showed you the boat, remember sail boats and all. Those boats you notice. In coastal areas and all, fishermen rely on this. Sea breeze and land breeze. Across the world, majority of the fishermen are poor fishermen. Not everybody has big ships, big boats, big motor boats and all to go and catch fish. Majority of the fishermen are very, very poor fishermen. All they have is a small boat, that's it. You have seen boat like this, a canoe shaped boat like this. Like a kayak shaped boat like this. Or a round boat, coracle bolte isko. Either a canoe or a coracle. Canoe or a coracle shaped round boats, or this kind of boats they have without motor. So what they have to do? They have to go and catch fish. So this, when they don't have sufficient equipment, going in deep into the sea and catching fish is not possible. So what across the world I have noticed this, majority of the fishermen, what they do after dinner, they start at night, like around 11 o'clock in the night. Khane ke baad, they'll carry some lantern because they have light they require. Torch also they can't carry because batteries also they'll run out. So they'll carry lantern rahega, fishing nets and all. They'll carry whatever they want. Correct? They'll start at night because of this which breeze? Land breeze. They'll start from here because the wind is blowing which direction? Toward the sea. So they start around 10 o'clock, 11 o'clock in the night. And they go, because when the wind is blowing like this, the waves also will be like this. So waves will support them. They'll come deep into the sea. They come. They cast their net. Entire night they'll catch fish. Okay. Next day morning, around 10, what happened? The wind start blowing like this. Sea breeze. They come back. They return. You got it? When they return here, because of the sea breeze, the wind will be blowing like this. So the waves also will be in this direction. So they can easily come to the shore using onshore winds. When they come here, their family will be waiting, friends will be waiting. So they'll give the fish to them. They'll go and rest. Because the entire night they were in the sea catching fish. So they'll go and rest. That is the reason in most part of the world, women go and sell fish. Men take rest during the day. You notice that fish market, if you have visited, you will know what I am saying. And not only in India, I have seen in other countries also. It is the women who go and sell the fish in the market. Men go and catch fish at night. So this is practiced worldwide, globally. So this is simple wind, how it helps fishermen to catch fish. It's a non-taxable income and also fulfills their nutritional requirements also. The fish fulfills their nutritional requirement as well. Very economical, not expensive for the fishermen. It also gives them money, a source of income, and non-taxable income. Sea breeze, land breeze. And also nowadays wind turbines. Government across the world they are placing wind turbines also in the coastal areas. Because the wind is blowing a lot every day. So sea breeze, land breeze helps them to generate power also. In India, the best spot to set up wind turbine is Kanyakumari. Here. Kanyakumari. Because we are Arabian Sea, Indian Ocean, Bay of Bengal. 3 seas meet here. Correct. 3 water bodies here. Bay of Bengal. This is Gulf of Mannar. Park Bay. Here, this spot. We have the Asia's largest wind plant here. Mupandal. Mupandal wind farm or wind energy plant, wind farm बोलते हैं इसको. In Kanyakumari, near Kanyakumari, is the Asia's largest wind farm. Mupandal, Tamil Nadu. Mupandal, Tamil Nadu. You can Google this for pictures. Mupandal is the Asia's largest wind farm. Okay, sea breeze, land breeze every day. It will help them to generate sufficient power. 1500 megawatt plant है ये. The largest 1500 megawatt wind farm in Tamil Nadu. Mupandal, Tamil Nadu. Asia's largest wind farm. Mupandal. Spelling on the board. Muppandal. Clear? Wind energy. So local winds, 4 types we have covered. Land breeze, sea breeze, anabatic, katabatic. Now, all of you see the world map now. Go to the world map, please. See here now. So local winds of the world heading. Local winds of the world. You can take some world map, blank map. In your world map, like in your atlas, lot of maps are there which you are never going to use. Turn the page. We'll get so many maps. Like one of the map is population. We'll never be using that map because population, none of us are concerned. So go to the population map. World population रहेगा, हाँ, use this. World migration, world population related maps. Some map which you are not going to use ever. Those maps के ऊपर you can draw. Whatever I am going to draw on the. See, local winds are classified either based on temperature, based on location. They are named based on certain places where they blow. Okay. Some winds are very popular. Some winds are very dangerous as well. We have to consider all aspects and we have to classify local winds of the world. Based on temperature, some are hot, warm, cool, cold. Like this, we classify them based on temperature. Okay. Some local winds bring beneficial effect to the coast, out of the local people there. Some bring devastating impact like forest fire and all. Some local winds have caused lot of damage, causing forest fires like Santa Ana. Santa Ana is a local wind in California, Southern California. It was responsible for large scale forest fire in Los Angeles last year. There is another called Brickfielder wind hai Australia mein. It caused forest fire in Australia. So some local winds are deadly, devastating impact. Some winds are called as doctor wind because they bring moderate influence to the coast and help the local people. Okay, some are good, some are bad. So based on temperature, based on their impact, we can classify local winds. So I am going to mention them. I am going to use certain colors. You can see some winds are very, very cold, like this. Siberian winds here. We call it as Buran. Buran is a local wind in Siberia, Russia. That comes from Siberia region and then Central Asia, Mongolia, Karaburan, it is called as. Buran and Karaburan. Here we have Himalayas and Tibetan Plateau. Remember Pamir, Himalayas, Tibetan Plateau. Because of this, we are protected by the local winds. Otherwise, this cold local wind should have reached India also. The local wind should have reached northern India. Buran and Karaburan are the cold, icy blizzards that blow from Siberia and Central Asia towards our northern India. Because of the height of the Himalayas, Himalayas act as a barrier for the cold waves. These cold waves can bring down the temperature by 30 degrees, minus 30 in winters. Already Delhi, North India suffers 1 temperature. Minus 30 you can imagine. Because in this region, it's all minus 30 here. surrounding Himalayas. That cold winds are blocked by the Himalayas. Okay. Same icy blizzards continue in Greenland, Iceland, Canada also. Blizzards, they call it as blizzards. In Norway, it's called as Helm. 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 Norway. Blizzards. These are all cold winds. Cold winds of the Arctic. They all come from Arctic. Extremely dangerous. In Canada also, the temperature comes down to minus 40, 50. Great Lakes. There is a Niagara Falls. Niagara Falls will freeze in winter. January, May. It will be so cold. The waterfalls, have you seen waterfalls freezing? Usually the water is like flowing from highland to lowland. From a cliff it jumps so it freezes and becomes ice. So in winter, so it's that cold wind, icy blizzard. Okay. These are in winter. Some local winds are seen in some seasons also. For example, in India, we have a local wind that blows in North India. Lu is a local wind. Only in summer. Some wind are found in winter. So as a result, local winds are not found throughout the year. They are seen only during certain seasons also. Summer may we have hot winds, winter we have cold winds, like that. In India, there is another wind that blows across the coast called Elephanta. From Mumbai, Elephanta caves, many of you might have heard of. Elephanta caves. So as the name of the wind is also Elephanta. It comes from Maharashtra to Goa, Karnataka coast. Up to Canara coast, the wind blows along the coastline. So the name of the wind is Elephanta because it starts in Mumbai. Elephanta caves. So the name Elephanta. It's a local wind that blows across the coast. So you see arrow mark I have written. So you'll understand. If the two-way arrow mark is written, it means bidirectional. One-way direction, if it is written, is unidirectional. Understand this. If the arrow mark is written in one direction, that means the wind is blowing in that direction. If the two-way arrow mark is written, bidirectional. Okay. Another important wind, Chinook. Chinook is the local wind of North America. It blows across Canada, US, over the Rockies. Why I have written like this? Because it comes from the coast, goes up the Rockies and comes down. This Chinook wind melts all the frost here, protecting the crops. So it's a farmer's friend. Chinook is a farmer's friend. It protects the wheat, winter wheat in Canada, US. Chinook benefits the local farmers. So that is then people call it as a farmer's friend. See the question. So they are asking, which wind is called as farmer's friend? Chinook. So I don't want you to remember that, but just remember the local name. If I write all that, everything will be clogged. Just remember the wind name. Next, Santa Ana, another local wind, deadly wind. I'll write in red. This causes forest fire. Santa Ana. Santa Ana is a local wind in California. Southern California, causes forest fire. Forest fire. Pampero. Pampero is another local wind in Pampas grassland. Yes. Argentina. This one. This is another local wind here called Berg. South Africa. Berg. Local wind that blows from the land towards the coast. Berg. Another wind here called Harmattan. Harmattan brings relief from the humidity. Harmattan. Sirocco. Kamsin. Ghibli. These are the local winds blowing from Sahara. I'll write the spellings here. Kamsin in Egypt. Ghibli in Libya. Sirocco in Morocco. These are African winds blowing from Sahara Desert towards Mediterranean Sea. Another wind blows from Mediterranean Sea out, Levanter. Levanter. From the Mediterranean Sea towards Atlantic Ocean. Levanter. You'll get a notes for this. Don't worry. Send you the printout. I'll ask them to send a printout because each wind name description I'll send. Okay. For other batch also I've given. For you also will give. Okay. Otherwise you'll not be able to remember what is what. I want you to remember location now in today's class. Notes. Then another wind. We'll finish this. See. Mistral. Mistral here. Mistral in France. Mistral. Another wind from down to north. Fohn. F-O-H-N. Fohn. Fohn is a wind that blows in Italy towards Switzerland over the Alps mountain. Alps. Fohn. Okay. Mistral is a wind in France. France. Mistral. Fohn in Switzerland. Another wind that blows like this. Bora. Bora. Ukraine mein we have a local wind called Bora. Ukraine and Balkan region mein we have a local wind called Bora winds. Southerly buster. Southerly buster. Then brick fielder. Australia. Brick fielder and southerly buster. It comes from the south, so southerly buster. So different names, different winds. Okay. Some of them you remember, please. So many questions mein paper mein they have asked what is Chinook, where is Chinook? North America. Okay. Then they have asked Pampero. Then they have asked Sirocco. Then they have asked Mistral. These four they have asked. Fohn they have asked. That's it. Till now. Okay. I am expecting this. They haven't asked Santa Ana. This is the one which caused forest fire in California, US. Because the wind brings extreme dry conditions. One is low humidity. Plus, when the trees brush across each other, the friction can also cause fire. Okay. That can spread the fire very quickly also. Because in Southern California, we have a lot of, let's say, eucalyptus type trees, which will catch fire very quickly. Simple diagram, local winds of the world. They're asking, match the following question or some local winds which are in news, they'll ask. So in the next session, we'll discuss global winds. Then I'll cover cyclones, anticyclones and all we'll cover tomorrow. Tomorrow, most of the topic will be over. Please revise and come. Whatever we have done today, you have to revise. Okay. Anyhow, time is up, so I can't continue. Any doubt? So you can scan this for your PDF. Please go through the NCERT today itself. Class 11th Fundamentals of Physical Geography.